join. And this is your shearing force diagram for the question that I gave you. Guys, simple or any confusion about it now?
Simple, sir, and well understood.
Anybody of the triangles, I will need my bending moment. I don't know what the units would be. It will be unit of weight multiplied by unit of length. Whatever they are, you can write like this. No, it's not given. What do I do? At A, it will be 0. At C, it will be plus half. Length will be L by 2 into height is WL by 2. It becomes plus WL square by 2.
By eight,
Yeah,
eight, sir, eight.
by 8. Okay, my mistake. By 8 minus WL square by 8 becomes 0. The bending moment would be then like this. A, C, B. You have 0. To some scale, you have plus WL square by 8. You have 0. You are doing from base to vertex. So from base to vertex will be steep first and then becoming horizontal. It will be a mirror image of it, which will be like this. And this will be the BM diagram for the question. Yes or no, guys?
Yes,
Yes.
sir.
Don't worry, I'm just going to make the box shaped vessel first, as per the information given in the question. This is my box shaped vessel. Its length is 40 meters. Light displacement is 320 tons. And its breadth is given. No, it's not given. Okay, never mind. It is divided into 4 holes of equal length. Let's say this is number 1, this is number 2, this is number they will be from forward end, whichever you take forward, and you can take on the left side also. So there is nothing stopping you anyway. Okay, now in number 1 cargo, you have 200 tons of cargo here. This is 200 tons of cargo. Here also you have 200 tons of cargo. Each hold is obviously 10 meters long, guys. And you have double the cargo in the middle holds. So this is the how the cargo is loaded. Does everybody agree with the question that I put on the screen, the diagram? Is it in line with the uh, text, beta? Yes or no?
Yes, sir.
Okay. Now tell me, guys, look at this vessel. A, it's box shaped. B, this light displacement here said is 320 tons. Okay. Now I know the light displacement of a ship is never uniformly distributed. Why? Because there will be somewhere the machinery space where the engine concentrated load would be there. Somewhere you may have the windlass or the mooring winch, there will be concentrated loads. I accept whatever is the logic. But then if you want me to use exactly how the light displacement is distributed, then it is imperative that you tell me how the light displacement is distributed. Yes or no? Correct, Peter? Then you will have to tell me out of this 320 tons, how much is the machinery and where is machinery located? How much is windlass,
Yes,
where
sir.
is wind located? How much is this one and where it is located? Then you have to give me complete details of the breakup of the light displacement. Yes or no? Correct? If I just say light displacement is 320 tons and I have to see how, yeah, are you back now in the meeting? Somebody who was asking the doubts, is he in the meeting now, beta? Before before we started the topic?
Yes, sir. Opposite.
Okay. We'll go back to it once we. You have been in the discussion, or you missed out any part of the discussion, beta?
Oh, no, sir. I'm in the discussion. Observing.
Okay. Let's continue with it. I'll take your question before we close out for the day. Okay, don't worry. Okay. So now, guys, if 320 tons is the light displacement given to me, then the best I can assume is light displacement is uniformly distributed along the length. Yes or no? Correct? That's the best I can work with, because otherwise you should give me the details, right? Straight line here. This becomes the shearing force diagram for the box shaped vessel. Nothing new. Drawing SF from the load diagram. The only thing you had to learn was how to make the load table. Once the load table is there, then you can all draw the load diagram. From load diagram, now we have come to SF diagram. And compare it to the SF that you got. Minus 100 plus 100. Don't you think it is the same? It is the same beta. See, at A, it is 0, SF. At next point, it is plus 100. Mid length, it is 0. This will be my last question for the day. Then I'll take the doubt. Somebody was just had raised the doubt at the beginning of the session, and then we'll close it. A box-shaped vessel, and let me do this question. You don't worry about it. You pay attention, and you only seek clarification wherever you're having doubts. A box-shaped vessel, 30 meter into 8 meters, floats in seawater, 5, length 12 meters, and of cross section 1 by 1. When two uniform loads, each 3 meter long and 1 meter broad, are placed on the log along its length extending from 3 meters from each end. Okay. Log floats at an even keel draft of 0.8 meters in fresh water with its axis parallel to the water line. That means it's floating with its axis parallel to the water line. Draw the SFBM diagram of the log stating their maximum values and the points where the beam along the beam length where they occur. Guys, has somebody attempted it, or you guys left it because you are not sure about it? What is the status till this? And those of you who have done can match the diagram. This is the side of the log, length 12 meters and square cross section of 1 by 1. So this breadth is 1 meter, this height is 1 meter. When two uniform loads and RD of the log is 0.5 is the RD. When two uniform loads of each 3 meters long at the end, so this 12 meters, this will be 6, this will be 3, this will be 3. Then there is a uniform load here, beta, and there is a uniform load here. Each one of them is 3 meters, and of course these loads are equal, right? Then with this load, it floats at an even keel draft of 0.8 meters, right? Then with this, it is floating at a draft of 0.8 meters in fresh water. You have to draw the SFBM diagram. Is the diagram clear to everybody, or there is a concern about the diagram first? What you have to do is then it becomes like a ship, which is 12 meter long, 1 meter wide, okay, floating at 0.8 meter draft with these weights. So you have to first get these weights. You remember yesterday we did the first question of our box-shaped vessel, in which the box-shaped vessel had cargo only at the ends. You remember, guys? The first question that we did yesterday. You remember? Don't you think this question is similar to this? Are these two diagrams not same in terms of vessel? Question. So here, how will you get these weights? First, you will get the total weight of the log plus. So this is like the load displacement. Total weight, that is log plus load on top, will be how much? That will be by law of flotation. How much is the volume under the water? It is length of the log 12 meters, breadth of the log 1 meter, and draft of the draft of the log 0.8 in fresh water into 1. How many tons does it come to?
9.6.
Sorry,
9.6.
9.6 tons is the weight of the log plus the weights on top. Okay. Now, what is the weight of the log? That is like the light ship. Okay. It will be the volume of the log multiplied by the RD of the log, which is given in the question as 0.5. What is the volume of the log? Log is 12 meters long, 1 meter wide, 1 meter high. Multiplied by its RD 0.5 will become the weight of the log. 6 tons. Okay, guys?
6 tons.
Yeah. So that means weights loaded on the log will be 9.6 minus 6, that is 3.6 tons. That is 1.8 tons each, right, guys?
Yes, sir.
because there are two weights, 1.8 tons each. So now it is like this. So
Yes.
this will be same. Yes or no?
Yes, sir.
Anybody? First, we have to familiarize with some of the terms that we'll be using in our discussion and how we'll be drawing the diagram when those terms are used. You need to again standardize your process of working. If you are random in your way of working, it will always create confusion in your minds. Now, we may be given different types of beams, primarily two types only, but there are more types. There can be a wavy beam, there can be a wedge-like tapered beam, there can be many. But types of beam when I am going to talk about here are the types of beams which are you asked in our exams. Okay. So tomorrow you do a naval arch book of some high level, or you do maybe naval architecture degree book, you may find beams of different types beyond these two also. Okay. In our case, we'll be using the word light beam. What does light beam mean? Light beam means a beam whose own weight is negligible or inconsequential, insignificant in context of the question. So light beam means a beam whose weight can be ignored as far as the question is concerned. Is that clear, guys? Is the word light beam clear to everybody? Light beam comes, we will draw it by a single line. So if I draw a beam by a single line, that means I'm talking of a light. Okay, what happens if the beam has weight which cannot be ignored? Then it depends how the weight is distributed. What is in our questions is a beam of uniform cross section. That means, what does the word uniform cross section means? That means all along the length of the beam, whether it is circular or it is square or it is triangular, whatever it is, the cross-sectional areas at any point along the length, wherever you may see, the cross-sectional area is same. That is the uniform cross-section. Have you understood the meaning of the word uniform cross-section, beta? Cross-section, we will draw it with some thickness like this, and we will mark it like this. So the single line above will represent light beam to us, and this is beam with uniform cross section. I hope these two terms are clear to everybody, guys. Right?
Sir, we will be only, these are two types of beams
That's what
which they will be asking us. One is light.
Yes, that's correct. Otherwise, there can be a beam like this also. Of maybe there can be a beam like this also. Wedge type. So there can be so many types of beams which can come. A beam can be like this also, non-uniform cross section. You see, at different places the cross sections have changed. So there can be different types of beams. We are not going to go into all those types. Our discussion will be restricted to light beam and beam of uniform cross section. Am I clear, guys? Clear?
Yes, sir.
Please confirm at every step that you are understanding, because if we falter on the very fundamentals, then we are going to have problems. And these beams can be loaded. Why do you have a beam? So that you can put force on it. Why do you put a beam under your roof? So that it can take the weight of the roof. So what are the types of forces or the weights that can be applied on the beam? Again, the types here are limited to our questions. Okay, there can be many more types. We are not going to dwell into those types. Okay, so this will be, again, when I'm saying types, it's specifically in context to our discussion. Okay. One can be a point weight or point force. What is a point weight or a point force? Is a force or a weight which is technically acting at a singular point. It acts at a single point. The full force is acting at a single point. In that case, the weight or the force is called as a point weight or a point force. Okay. If I have a beam, let us say light beam, or maybe a beam of uniform cross section, I'm drawing both of them side by side, guys. If I have to put a weight like this, in case of a uniform cross section beam, I'll show like this, wherever the position, whether it is at the ends, middle point, wherever it is, wherever the force. So when I show it like this, the downward means it's a force which is loaded on the beam. And what does it mean? It's one single arrow. That means it's a point force acting at a point along the length where the arrow has been placed. Is that clear, guys? This can be a uniformly distributed force, or UDL as we call it. UDL, uniformly distributed load. In case of a light beam, the weight is uniformly, it is not acting at a single point, it is acting over a certain length. That means it may be acting over this point length. What is uniform? That means from X to Y, the weight has changed at a uniform rate. It is changing at a uniform rate from X to Y. That is the meaning of word uniformly distributed. And if it was a beam with a uniform cross section, then this is my beam, and I can take another color to show UDL over it. That can be more length, can be less length, that can be entire length of the beam. Let us say the UDL is here. Let's say another UDL is like this, placed on this side. So these are the UDLs I placed. Understood, guys? Understood? Clear, beta? Okay, fine. So we have learned what are the two types of beams that will be handled by us, what type of forces can be put on these beams, or what type of weights can be loaded on the beam. And the third thing we must understand is what is the type of support, because beam, okay, you're putting a force from top, then the beam should continue going towards the center of the earth. If it's not going towards the center of the earth, then it needs to get some support somewhere. Okay, like the forces, downward forces, the upward, sorry, Beta, are you telling me or what? Now, type of support can be, again, in our context, will be limited to two types of support. One type of support can be a point support, or also called as a knife edge support. So these are the terms which may come in the question, and they should not confuse you. What is knife edge support? It's same as the point support. That means if I have a light beam, and let us say it is supported at the two ends over point supports, then I'll show the supports like this. If there is a uniform cross-section beam and need not be supported at the ends, let us say it is supported 2 meters inside of each end. So that means maybe it is supported here and here. They can be supported wherever, you can place them wherever. But these are the point supports. That means technically the support point is at a singular point. Okay. The other type of support can be where it is supported over a certain length. What do we mean by that? If this is the light beam, or this is the beam of uniform cross section, it may be supported over a certain length instead of being at a point support. Something like this, guys. What do you do when you keep a beam? You make it overlap for few feet or few meters on the plane surface. So that means now the beam is resting on a plane surface over a certain distance. This is a support over a certain length. The other could be this one, or other could be also over a certain length. Choice is yours. Or the entire beam can be placed over the ground. Then it is supported all along the length. Then the beam is supported all along the length. So these are the types of two supports. It can be singular point support, or it can be supported over a certain length. Length can be anything from whatever smallest you want to think of to the entire length of the beam. Are the types of supports clear? Cantilever. See, until now we have supported the beam at minimum 2 points. Minimum 2 points. If it is resting over a surface, then points are many more. Okay. But if we support the beam only at 1 point, how do? You must have seen the plumber when he cuts those threads conventionally. What do? They put a C channel into the wall, right? If this is the wall, they put a C channel like this, and this channel, this is the beam. Then this beam can be light beam, or this can be a beam of uniform cross section. When a beam is supported only at 1 point, then it is called as cantilever. Chhajja beta, like balcony of your house, because it is supported on one side and the other end is free. So that is also called cantilever. So cantilever is a beam, in context of our discussion, would be a beam which is supported at 1 point only. I'm saying 1 point, that need not be the end itself. That could be any 1 point as long as the beam is balanced then. Okay, so that is the cantilever concept. When it comes to the question of cantilever, we'll again use this and we'll talk about it. Okay.
So how is it different?
We first, whenever we have the question of SFBM, first part we'll do is based on the language of the question. Based on the language of the question, we will first draw the beam diagram. And then we will do the second step of calculating the reactions. Now, it's very, very important that the beam diagram is correctly drawn. If you draw it wrong, it's going to give you wrong input and you are going to mess up the question. So there is no scope for you to fool around with this diagram, guys. Now, what do I mean by the beam diagram? And I'll make and you'll understand. You can read this question. There is a light beam AB whose length is 10 meters. Okay, so that means light beam, I'll represent by a single line. It is A to B, its length is 10 meters. Okay, it is supported over a point support at its ends. That means it is supported like this at end A and it is supported like this at end B. The beam carries a point force of 50 newtons at its mid length. So at mid length, it carries a point force of 50 newtons. And it carries another 30 newtons of point force 2 meters from end A. So 2 meters from end A, you have another point force of 30 newtons here. This distance is 2 meters. Then obviously this distance will be 3 meters. And this distance will be 5 meters. This is what I meant by when I said draw the appropriate diagram. Do you agree with the diagram? Is this diagram according to the question? Yes or no? A particular question which is on display. Do you agree this will be the diagram? Yes or no? I'll make for 1 or 2 questions and then I'll start you to start making first. Yes, tell me. Okay. So this is what I meant by the first step, that is drawing the diagram of the beam. It is not only the beam, the forces on the beam also need to be shown. Okay, guys? Everybody is good with the diagram?
Yes, sir.
Yes, sir.
The second part, calculation of reaction. Now you see, this beam has a downward weight or force of 80 newtons, 30 newtons here, 50 newtons here. The beam is experiencing a downward force of 80 newtons. What should this do? They should make the beam go towards the center of the earth. But why the beam is not going towards the center of the earth? Because of these two supports. Correct, beta?
Yes, sir.
You have table in front of you. If you drop your pen from a certain height, it will start falling. But when it comes at the table, it will come to rest because it finds the table on the way. If the table was not there, it will go to the floor and then come to rest there. If the floor was not there, there was a well dug out, it will go to the bottom of the well. That means the weight will keep taking you towards the center of the earth because it's law of gravitation. But then somewhere, wherever the support comes, the body may come to equilibrium and may stop moving, continue its journey towards the center of the earth. So in this case, when it has two supports at end A and B, they do not allow the beam to go any further down. Okay. Now, what is, for every downward force, if the body is not moving down, there has to be an equal and opposite force, because they have to be in equilibrium with each other. So what happens? The weight of the beam is passed on to support at A and support at B. When the weight of the beam is passed on to the support by Newton's third law of motion, there is equal and opposite reaction. So where will the reaction act? Reaction will act at the supports. Why? Because weight has been passed at end A and B where the supports work, and reaction will be, as per Newton's third law, equal and opposite force acting there. So reaction will be acting at A and B. As per Newton's third law of motion, in this case, what will be the total reaction, guys?
80 Newton.
80 Newtons. Okay. So now, out of this 80 Newtons of reaction, some of it may be acting at A. So let us call the reaction at A as RA. And let's call the reaction at B as RB. Now, all of you have already agreed with me that RA plus RB would be 80 Newtons. Correct, guys? Yes or no?
Yes, sir.
Yes. Now the next we'll do is, we'll split this 80 Newtons and find out how much is acting at A and how much is acting at B. Okay. For that, we will take the moments of these forces. Now, when I use the word force, I mean all the forces, irrespective of whether they are acting downwards or they are acting upwards. When I use the word force, it includes upward as well as downward forces. Okay. So now you tell me, guys, on this beam, how many total forces are acting? Tell me how many forces are acting on this beam. Count the number of forces that are acting on this beam.
4.
Four, sir.
Sorry, 4. From left to right, can you
Four,
name
four.
these 4? Yeah,
Four.
from left to right, can you name the 4 forces, please? I'll write down as you name them.
RA.
RA,
30, 50
30,
RA, 30
30,
newtons, 50
50
newtons,
50 Newton,
and RB.
RB.
Okay, beta. Now these 4 forces, we can take the moment of these 4 forces about any point along the length of the beam. You can take the moment about any point, technically. What is recommended is that you take the moment about one of the supports. Okay, technically, principally, you can take whichever point you want to take the moments about. But what is recommended is you take the moments about one of the supports. Why? You'll see the advantage of taking the moments about one of the supports. Now, in such a case, since we are all writing from left to right, our natural instinct, it's instinctive. You can choose B also, you can take any point, doesn't make a difference. But I'm sure everybody will feel, yeah, A seems to be more convenient because I tend to read from left to right. So you can take any point. I'm not saying A has to be taken, no. But what I'm strongly recommending is that take the point about which you're taking the moments as one of the points where the beam is supported. So let us say in this case, let us say we take moments about taking moments about A. Moments of what? Moments of the 4 forces about point A. What do you mean by taking at point A? That means, beta, it means hold your pen at one of its ends, that is A. Okay, just hold right at the end, and the full length is then free. Then go little distance on the pen and act 30 newtons of force, or some force from upwards, from downwards force. Tell me, guys, if you're holding the pen at its left end and you're putting a force of 30 newtons like this one on the pen, is the pen tending to rotate clockwise or anti-clockwise?
Clockwise.
If you, what I'm doing now is only to explain, do not mess your diagram. Do not mess up your diagram. See, what I'm saying is, we are taking moments about A. I'm just, for the sake of explanation, I'm saying I'm freezing this point. If I'm holding at this point, this force would cause a clockwise movement. Correct, guys? Yes or no? On the beam. Correct? It will tend to rotate the beam in the clockwise direction. Yes or no?
Yes,
Correct,
sir.
sir. Yes, sir.
Likewise, the 50 Newton will also try to rotate the beam in the clockwise direction. About A. This is all about A. You change the point, these
Yes.
directions may change. And this force RB will tend to rotate the beam in the anti-clockwise movement about A. Yes or no?
Yes, sir.
Has everybody understood how to figure out it's about A? And instead of every time writing clockwise, anti-clockwise, we make algebraic equation by announcing, let us say we take, you have to write down, taking clockwise as positive and anti-clockwise movements as negative. So we have announced what sign we are going to take. So guys, what will be the moment of each force? About A. Now please, this is about A. Huh? This is not, you just can't say moment, like axis or the point about which you are taking the moment has to be identified. We are taking about A. Now, what will be the moment when you take the moment about keel of any weight? What do? Weight multiplied by distance by lever. Lever is the distance of its geometric center from keel. Here also, you will multiply each force by its lever. Lever from where? Lever from the reference point. What is the reference point? A. So guys, what will be the moment of RA force about A? RA into, what will be the RA into 0? So whether you put plus or minus does not make any difference. Okay. Guys, using the sign convention, what will be the moment of 30 Newton force about A? Clockwise it is, so clockwise is plus. And
Plus 30.
30 into 2. Correct, guys? Okay. What will be the moment of the 50 Newton force about A? Clockwise plus 50 into 5. Correct, guys? And RB will be anti-clockwise into 10. Does everybody agree with what I have written or any questions? Please clarify now, don't drag. Okay, now. My question is the beam rotating?
Yes.
No, sir.
Beam is rotating?
No.
No, sir.
Okay, so
No, sir.
beam is not rotating means what? That the resultant moment about point A, because then otherwise it should have been rotating about point A. If it is not rotating about point A, that means resultant moment about point A must be 0. Why? Because clockwise must be balancing the anti-clockwise one, right, guys?
Yes, sir.
Yes, sir.
Otherwise the beam should have been rotating about point A, correct? So
Correct.
as the beam is not rotating about point A, this has to be 0. Why? Because beam is not rotating. Beam is in static equilibrium. It's in equilibrium, it's not rotating. So that means resultant has to be 0. Understood, guys, why it has been equated to 0?
Yes, sir. Yes, sir.
And this will now, before we get the values, you see, why did I recommend that you take the moments about one of the supports? By taking moments about A, this RA has disappeared from the expression. Had you taken some other point than A or B, then what will happen? Both RA and RB will remain in the equation. Then the equation would have been solved with simultaneous equations. It will become more difficult. That is why I recommended that always take the moments about one of the supports. Am I clear now?
Yes, sir.
Okay. So what happens in this expression? Because we have taken moments about A, lever of RA becomes 0. RA goes out of the contention here. This gives you RB is equal to 60 plus 250 by 10, 31 newtons. Correct, guys?
Correct, sir.
Now I put this reaction on the diagram, 31 newtons. And we have already said RA plus RB is 80. So if RA plus RB is 80 and RB is 31, then RA would be equal to 80 minus 31 equal to 49 newtons. Yes or no?
Correct, sir.
I put RA also on the diagram as 49 newtons. This is what I mean by calculation of reactions. Please review it. See if you have any question coming to your mind. If any more questions on A, drawing of the beam, and B, calculation of the reactions. Values of reactions we have already calculated. We had this diagram A to B, length was 10 meters. We had the point supports. We had 50 newtons mid length. We have 30 newtons here, a distance of 2 meters, 3 meters, 5 meters. We had RA of 49 newtons and RB of 31 newtons. This is the diagram I'm talking about. Is that clear? This is the beam diagram.
Yes, sir.
Let's name these 2 points where the forces are there. Okay. Or okay, let's name them. Okay. Let's say I call this point as C, this point as D. C is the center, D is the next point I've marked. Okay. No mind. So up to this point, reaction calculation for this simple case, all that is clear to everybody. Any more doubts? Last opportunity, beta. All clear up to until now? Okay, fantastic.
Yes, sir.
Now I'll take any one point along the length. Tell me, do you want me to take between A to D? Do you want me to take between D to C or C to B? Tell me any section in which I'll take any random point.
C
C
to
to
B.
B. Okay, let me take this point X here. Okay. It is C to B, whatever the distance. Distance is immaterial in today's discussion. Tomorrow it will become relevant. Today, no. Now let's see what are the forces acting to the left of X. That means I take stock of the forces from left. This red arrow, whatever I'm drawing now, red arrow, don't draw. This is only for explanation. Okay. Don't take down anything now, guys. Okay. If I take all the forces to the left of X, then I have one force, 49 newtons acting upwards. I have 30 newtons acting downwards, and I have 50 newtons acting downwards. Guys, what will be the resultant of all these forces to the left of X? Sorry?
31.
31 Newton, and that will be acting downwards. Correct, beta?
Correct, sir.
Let's do the similar exercise for the forces to the right of X. To the right of X, there is only one force, and that is again 31 newtons incidentally, but that is upwards. Correct, guys? Do you see that? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Maybe it is by chance. Let's take another point here, Y, and carry out similar exercise at Y. To the left of Y, I have two forces. I have 14 on the left of it. I have 49 newtons acting upwards and 30 newtons acting downwards. This results into a resultant of 19 newtons upwards. Yes or no, guys, to the left of Y?
Yes, sir.
Okay. Let's take the stock of forces to the right of Y. We have 50 newtons downwards and we have 31 newtons upwards. Again, the resultant is 19 newtons.
Downwards.
This time it is downwards. Now, this cannot be a sheer coincidence. You can carry out this exercise at any point, whichever you want, along the entire length of the beam. What do you find? And these two cases are good enough to set the confidence that wherever you may calculate, these values may change. Here it was 31, here it's 19, fine. But what do you see? That on either side of point X, the resultant of the forces to the left of X was 31 newtons. to the right of X was also 31 newtons. Only discrepancy was that if it was downwards here, it became downward here. But the numerical value of the forces remained same. Yes or no, guys?
Yes.
Correct?
Yes.
Now, if you hold if you close the cap of your pen and hold the entire cap into your palm, hold the entire cap into your palm. Done that? So there is some part of the pen which is hanging out. Yes or no? Correct, beta?
Yes, sir.
Now let that be the point Y, where the cap ends. Let that be the point Y. What happens on this part of your pen? This part of your pen at point Y. At point Y, the forces to the right of it are tending to move this portion, this part at Y by 19 newtons downwards. The right part, because of the resultant of all the forces to the right of Y, 19 newtons is the force acting at Y, which is tending to move the right portion downwards. Yes or no, beta? Correct?
Can you please
Correct, sir.
explain which point is the Y, sir? Pen?
Where you are holding the pen. That is where the cap of the pen ends.
Okay, sir.
Okay, so what happens? This part is hanging out, no? This part is hanging out of your hand, right? Correct, beta?
Yes, sir.
So
Yes, sir.
on this at Y, where you have now gripped the pen, at Y, 19 Newton force, you can see, is trying to basically move at Y. 19 Newton is trying to push this part down at Y. Yes or no?
Yes, sir.
Okay. If you hold the other side, the lengthier side, now hold this side, hold this one, the entire length. What happens to the shorter side, cap side? 19 Newton is trying to move this portion upwards. Correct? Yes or no? Correct?
Yes, sir.
What is this 19 Newton trying to do? This 19 Newton is trying to break the beam at Y. This 19 Newton, up or down, is trying to break the beam at Y. Whether the beam will break or not, that will depend on the strength of the beam. Okay. But this 19 Newton is trying to move one part with respect to the other, up and down. This 19 Newton, which is trying to break the beam at Y, is the braking force on the beam at Y. And another name for the braking force is the shearing. Shear means break. So at Y, this 19 Newton is the shearing force on this beam at point Y. 19 Newton is the shearing force on this beam at point Y. Exactly the same by same logic. The shearing force at X is 31 newtons. Shearing force at X is 31 newtons. So what do we see? That the force that is trying to break the beam at any point, say for example X, the force which was trying to break the beam at X is nothing but the algebraic sum of the forces to one side of it. Why? Because when we took like this from on the left side, it came to 31. When we took to the right, it again came to 31. Let's not talk about up and down for a while. They have to be up and down because then only the beam will tend to break. If both start acting in the same direction, what is going to break the beam? The beam is not going to break. Okay. So what I'm trying to say is that this 31 newtons at X or 19 newtons at Y, which is trying to break the beam at X and Y respectively, is the shearing force at these 2 points. Whether the beam will break at Y or X or not break at any point, that will depend upon how strong the beam is. So this is what the shearing force is. So please try to understand what I have said and let me know. Let me clear while you are doing it. Let me clear this diagram. I'll redraw it You can shoot your doubts. So if I have to calculate the shearing force at any point, then what is, from this discussion, what is the shearing force at any point?
Of any one side.
Yeah, it is the algebraic sum of all forces to one side of it. Correct, beta? Any one side, right? Correct? Yes or no?
Yes, sir.
Okay. So whichever point I have to calculate the shearing force, I'll just take stock of the forces to one side of it, and that will be the value of the shearing force. But the problem which comes is that if somebody gives me from Y, so the person who has gone from left to Y will say 19 newtons upwards, and the person who comes from right to Y will say 19 newtons down. Good, both will give the same value, but there will be a mismatch in the directions. One would say up, other would say down, and both are right actually. Okay. To remove this anomaly, that there should be a discrepancy in the response, a sign convention is introduced. What is the sign convention? When I go from left to that point of interest, I say when I'm going, this is what I'm saying, I go from left to right. And when I'm coming from right to the point of interest, I say right to left. Okay. So there is a sign convention which has been introduced to remove this upward downward business, so that our answer would be plus minus, and both will give the same answer. Either both will get plus or both will get minus. How? When we go from left to right, let me use different colors. When we go from left to right, so when we go from left to right, guys, upward forces are taken as positive and downward forces are taken as negative. So in case of Y, 49 Newton is plus, 30 Newton is minus. So this 19 Newton upward is nothing but it translates into plus 19 Newton. Yes or no? By the sign convention. Yes, beta? Okay. To harmonize the answer, sign convention from right to left. Okay. Or you can say right either लिख दो, left either लिख दो, or arrow ऐसे कर दो, कोई बात नहीं, एक ही बात है. Right to left. The sign convention from right to left is reciprocal of it. You don't have to remember both. You can just in reverse. Upward will be minus, opposite to this, and downward will be plus. So when we have come from D to this point, 31 will be upward will be minus. So minus 31 plus 15, and this will also translate into plus 19 Newton. So by this reverse sign convention, from left to right or right to left, both will get plus 19 Newton as the shearing force at Y. Is that understood, beta?
Yes.
So the answer will be
won't have any this plus or minus sign, correct?
Sorry?
Shearing force won't have any plus or minus sign.
No, but minus, and because we are getting upward and downward, shearing force is the tendency to break, right?
Yes.
Whether it is, that's what I'm saying, whether
Okay, sir.
Yeah, whether one portion goes up or the other portion goes down. But yes, there will be some shearing force. So just to harmonize between the response of up down, this convention has been introduced so that everybody gives the same answer of plus 19 at Y. Is that clear, beta?
Yes, sir.
Okay. Now, we have done the sign convention. Fantastic. But let's not every day keep writing left to right, right to left, and then get lost in the sign convention every day. Let's agree in the class, since we have a tendency to read from left to right, because the language that we use for this particular discussion, then let's say wherever I have to calculate the shearing force, I always go from left to right. I don't come from right to left at all. That is easier for me to say. I'll not follow this side at all, right? I can always say I don't want to take this route. I want to take this route every time, though I have an option, right? Correct, beta? Correct?
Correct, sir. Correct.
So let's decide in the class that we will always go from left to right. So whenever I have to calculate the shearing force at y, I'll only go this way. If I have to calculate here, I'll go this way. I will not come from right to left at all. Why? Because if I standardize my process, then upward forces will be positive, downward will be negative, end of the story. Correct, beta? Left to right, upward will be positive and downward would be negative. Yes or no? Yes or no, beta?
Yes, sir.
Yes, yes. Just reverse of BM, sir.
अरे अभी BM तो इसके बाद आएगा ना, तो BM से लाएगा तो
Sir, before that, so you're saying that now we have got 19 newtons.
So, do we all decide that we'll always go from left to right, guys? Yes or no? And when we go from left to right, upward forces will be positive or negative?
Positive.
And
Positive.
downward will
Positive.
be negative. Okay, very good. So now let me clear this diagram again. And now I'll ask you, we'll take some points and I'll ask you to give me the shearing force at those points with the sign, and we'll keep going from left to right. I will draw the beam diagram. This is the diagram. Whatever messing up of the diagram I'm doing, it's only for explanation. Your diagram has to remain absolutely clear. Okay, this was the diagram. Okay. Now, guys, I'll take some points and you have to give me, let me mark some points. Let me mark them in blue. I'm marking a point which is just to the left of A. I know to the left of A there is no beam only. So it is just to the left of A. The second point I'm saying is just to the right of A. That means both these points, which ones? Point 1 and point 2. Both these points, okay, both these points, 1 and 2, are basically just to the left of A and just to the right of A, but they are practically at A, both of them. So they
Yes.
are just, it's A, just to the left of A, just to the right of A. That means the moment you go past it. Let's take more points. Let's take 3 here. It can be anywhere along this section. Let's take another point 4, which is just to the right of D, and another point 5, just to the left and right of D. I take point 6 here. I take point 7 here. I take point 8 here to the left of C. I take point 9 just to the right of C. I take point 10. I take point 11. I take point 12. I take point 13 just to the right of D. And then I take point 14 just to the right of D. So 13 and 14 are like 1 and 2. The way 1 and 2 were at A, likewise you have at D 13 and 14. Okay. Now at these points, we will always go from left to right. We will not come from right to left. We have already agreed.
Yes,
And
sir.
when you'll go from left to right, guys, in this direction, upward, you'll not use up and down now. You will use the sign and give me. Okay. Upward will be positive and downward will be negative. Okay. So I've written here so that there is no confusion in your minds. Now I'm writing the point here. At point 1, to the left of point 1, is there any beam?
No.
No, sir.
No.
So when there is no beam and nothing to the left of 1, so the shearing force at 1 is 0. Correct?
Correct, sir.
Now, what will be the shearing force at 2? To the left
Plus
of
49.
to the left of 2, from left and A to 2, there is only one force, that is 49.
One.
So it is plus, for y minus beta, left to right is plus 49. Na beta? Upward is positive, na beta? Yes or no?
Yeah, okay. Yes, sir.
Can you repeat that, please?
Tell me what will be the shearing force at point 2. You tell me based on what you have understood.
49 plus
No,
49.
no. Sure? Or any
Yes,
doubt?
sir.
So what is
No,
it that you want? What was the doubt? Tell me, beta. I'll
no,
answer
I
the doubt.
think no. I thought you said just to the left of two. So I
Just,
thought
no, just to the right of A. Just to point 2. Just, if I said something wrong, maybe it must have been slip of tongue. Otherwise, it's point 2 just to the right of A. Okay. Okay, guys. Tell me, guys, what will be the shearing force at point 3?
Plus 40.
Plus 49. Does everybody agree?
Yes, sir.
You
Yes, sir.
can what you can do is, if you have a doubt, just tear off a small page from your notebook, cover the screen, cover the beam, and keep opening as you're going to the right. Keep opening up the beam. What will be the shearing force at point 4, guys?
Plus
Plus
49.
Plus 49. Okay, very good. Now, when you go to 5, even 30 newtons come into existence. Yes or no? 30 Newton is to the
Yes.
left of 5. Correct, guys?
Yes, sir.
At point 5, the shearing force will be plus 49
Plus 19.
minus
Minus
30
30.
plus 9. Correct, beta?
Yes, sir.
Now, you see, the best way to see now is, instead of every time starting from the start line and then coming, see, this plus 19 has already accounted for the force from A to D, 5. 1 to 5 all have been accounted in plus 19. Yes or no?
Yes, sir.
correct, sir.
So when I go to 6, what do I see?
Plus
Is there any change taking place from 5 to 6?
no, no,
So
no.
that means it will remain plus 19. Correct? Correct, beta?
Correct, sir.
Yes.
Up to now, up to 6, all accounted in plus 19. Is there any change from 6 to 7?
No,
No,
sir.
sir.
So it will remain plus 19 at 7 also. Does everybody agree?
Yes,
Yes, sir.
Is there any change from 7 to 8?
No,
No,
sir.
sir.
So at 8 also will be plus 19. Yes, there is a change from 8 to 9. And that change will apply to what? That change will apply to plus 19. The change will apply to plus 19. So plus 19, and what is the change? Minus 50.
15.
Minus 31. Correct, guys?
Yes, sir.
From 9 to 10, there is no change. So it will remain minus 31. 10 to 11, there is no change. It will remain minus 31. 11 to 12, there is no change. It will remain minus 31. From 12 to 13, there is no change. It will remain minus 31. From 13 to 14, there is a new force coming into existence, which will apply to minus 31. So 14, it will be minus 31 plus 31, becoming 0. Do you all agree with it?
Yes, sir.
Yes, sir.
Any questions on these so many points that we have taken? We'll cut short afterwards, but first you need to agree that these are the shearing forces. Correct, beta?
सर
Okay. Yeah.
सर ये जो जितने आपने से पॉइंट लिए हैं सर, जैसे 6 के बीच 5 के बाद 6 7 8 लिया है, जहाँ हम मिनिमम ले सकते हैं सर, या मैक्सिमम लेने हैं?
अरे तो यार पहले ही तो वो छोड़ दो उसको. मैंने तो randomly point ले लिए. Let's continue with the discussion. All will be answered. Let's not go off track right now. Have you understood what is being done, beta?
yes, sir.
Yes, sir.
Yes.
Okay. Now you tell me, guys. Now you tell me. If you look at point 1 and 2, what is point 1? Just to the left of A. That means practically A. What is 2? Just to the right of A. That means practically A. That means if I put A and 1 and 2 together, that is happening nowhere else but at point A. Yes or no?
Yes, sir.
This change from 0 to 49 is taken to the right of A. It has become plus 49. That means where has it changed from 0 to plus 49? The change has taken place at A. Correct, guys?
Yes, sir.
Correct.
Point 1 and 2 basically represent A, because one is just to the left of A, other is just to the right of A. So they basically, that means the change from 0 to 49. If I go to left of A, it is 0. To the right of A, it becomes plus 49. Then where has the change taken place? The change has taken place at A. Because in between the two, in between 1 and 2, the only point is A. There is no other point between 1 and 2 except A. Understood, guys?
Yes, sir.
Correct, sir.
So that means this change from 0 to 49 would have taken place at A. Yes or no?
Yes, sir.
But going by the same logic, what do points 5, 4 and 5 represent? Look at the diagram. They represent point D. What do points 8 and 9 represent? They represent point C. Correct? What do your point 13 and 14 represent? They practically represent point D. Yes or no?
Yes, sir.
Okay. Now I have sufficient number of points where I've got the shearing force. How we'll cut short, we'll talk about it later. But if I now draw a diagram in which I take the length of the beam on the x-axis and the shearing force on y-axis in whatever units it is in newtons this time, and I draw a diagram of the shearing force from A to B, that means this is A. 3 meters from A is D. 2 meters from A is D. 3 meters from D is C. And 5 meters from C is B. Correct, guys? This is my beam. On the x-axis is the beam. Now, on the y-axis, I have the shearing force. And if I look at the table that I got, my values are between plus 49 and minus 31. So I can take 10, 20, 30, 40, 50. So plus 10, plus 20, plus 30, plus 40, plus 50. Minus 10, minus 20, minus 30, minus 40. I take a scale here also. Now I can change to the red marker and I draw a diagram. Now you see what happens with that. At A, it has changed from 0 to plus 49. Look here, 1 and 2. So that means change from 0 to plus 49 has happened at A. So this is plus 49. At A, it has changed from 0 to plus 49. Do you agree with this? Correct, beta?
Correct, sir.
Then at all points from 2 to 4, including 3, it has remained plus 49. That means, and then at D, it changes from plus 49 to plus 19. That means from A to D, it has remained plus 49. That means the graph would be like this. This is plus 49. At D, it becomes plus 19. Plus 19 would come somewhere here. That means at D, it comes to plus 19. Then from 5 to 8, that means D to C, it has remained plus 19. And at C, it changes to minus 31. Then it remains minus 31 up to B. And at B, it changes from minus 31 to 0. And I get this diagram. First of all, before you go on anything else, do you agree with this diagram that I have drawn based on the values that we got? Yes or no?
Yes, sir.
Anybody has any questions on the diagram before? This is of course 5 meters, right? Distance. This one. Now, if you are in agreement with this diagram, then this diagram is the shearing force diagram for this question. This is the shearing force diagram for this question. Any questions on this beta that we have drawn before we go to pick up the shorter methods of doing them? All good up to this point? Okay.
All good.
Now, okay. I'm going to clear it out and now we'll learn how can we cut short on the number of points. Yeah, please some method will standardize our working so that I can do it with bare minimum number of points. What will be bare minimum? That will depend from question to question. It is not that every question you will have 3 minimum points or 10 minimum points. No. In some you may have 2, in some you may have 7, you may have 10. So the necessity will depend on the complexity of the situation, not on the length. When I'm saying, it's not that if this beam becomes 20 meter long, I'll take 28 points, no need. So we'll now devise a method based on what we have learned until now. Okay, now I'll tell you how do we make the SF table. For this same beam, I'll draw the beam here. And if you have any doubt, you can keep a piece of paper, cover the screen. As I tell, after that, I tell you, you can keep uncovering later on. So you can do that. If you're clear with the things, then it's okay. RA was 49. RB was 31. Midpoint was C, where it was 50 newtons. And 2 meters from here was D, which was 30 newtons. Okay, guys? Now, this part you have done for first diagram. So let's have a quick recap of the steps that we have taken until now. First, we made the diagram. Okay. Second, we calculated reactions. Now, third is identify key points or critical points for SF diagram. What do I mean by this? This is not a standard IMO vocabulary. This is our own understanding. What do I mean by this? By looking at this diagram, I figure out minimum points where I must calculate the shearing force. That means if I do not calculate shearing force at those minimum points, I will be messing up my diagram. So that minimum point number of points is unavoidable. Now the question could be, sir, tomorrow if I have a doubt whether I should take this point or not, if you have a doubt on a point, please include. Because if you include one extra point, it's not going to make the question wrong. It will only take a little more time for you to solve. But if you miss out on a key point or a critical point, then it will be dicey as far as the shape of the SF diagram is concerned. So identify the critical points for in that particular situation at which you must calculate the shearing force. Now, what are the critical points? How do I decide on the critical points? And therefore, I'm saying the diagram, beam diagram has to be spot on. Okay. Now, to critical points, first thing you will do is you will include both the ends. Okay. Second, you will include all points of where you have the point force. Where you have the point force. When I'm saying point force, whether upward or downward. Okay. These are the two things for this question. We will, when it comes to different type of question, you will be able to figure out here something else will be added. Okay. So you can keep that open for the time being. Now for this question, only critical points will be the ends and the point forces. Now if you meet both these conditions, then how many points are critical point, guys? 4.
4.
Yeah, because A and B are the ends and we have 4 point forces. 49 is a point force, 30 is a point force, 50 is a point force, and 31 is a point force. But A and B are already included because of ends, and you add C and D to that, and you have 4 critical points. So for this question, you have 4 critical points. Once you identify the 4 critical points, now this is all not to be documented in the paper. This is not for basically you to write. Now we make the shearing force table. For how many points? The minimum points that I have picked up. What is the structure of the shearing force table? Shearing force table would be like this. Here would be the shearing force. These are the points. This will be the shearing force. You will write the unit of the shearing force here. In this case, it is Newton. It is the same as the unit of force in the question. Then we have 4 points. 1, 2, 3, and 4. Now, when you write these points, do not jumble up the order. Please respect the order in the diagram. So have an eye on the diagram and make sure the points are documented in the same order as they are on the diagram. So you please make sure this is respected. A, B, C, D. You cannot make it for this diagram A, C, D, B. No. Or A, B, C, D. No. The sequence of the points has to be as per the diagram. Is this point well understood, guys?
Yes, sir.
Yes.
Okay. So don't mess up with the order. Don't tomorrow tell me, sir, I wrote it wrong. Then if you write it wrong, then bad luck. Okay. Now, these cells, what are the cells? Cells are these spaces under A, D, C, and B, where we are going to fill up something. These cells, wherever you have the point forces, pay attention what I'm saying. Wherever you have the point forces out of these 4 points, you divide the cell into 2 parts. Tell me, do we have a point force at A? Yes or no?
Yes, sir.
D,
Yes, sir.
No.
C,
No.
D, yes.
Yes.
So that means all the 4 have to be divided. If there were points where there were no point forces, we don't have to divide. What do I mean by dividing? I divide this vertically into 2 parts. Now you'll say, why have we divided into 2 parts? Wherever we had the point forces in this diagram, what did we do? We took a point to the left of the a point to the left and a point to the right. Yes or no? Like 1 and 2 made for A, right, beta? Correct?
Yes, sir.
Right? So the same thing, we are not going to write A and B, but what happens is on the upper part of each cell will represent to the left of the point, and the lower part will represent to the right of that point. For example, first I'll fill up this cell. That means to the left of A, just to the left of A. Then I'll fill up this, just to the right of A. Then I'll fill up this to the left of D. Then you will not number it like this. I'm just doing it for the first time. And this is the order in which we'll keep filling up the values here. Okay. Now you take that paper that you have torn off, cover the thing up to A, and to the left of A, is there any force? No. So the shearing force to the left of A is 0. Do you agree with me?
Yes, sir. Agrees.
Now go to just right of A. First, now what do? We'll only account for change. So carry forward this 0 here first. Now from left of A to right of A, is there any change?
49, plus 49.
So plus 49 is the change. So I allow 49 as change, and the shearing force becomes plus 49. Is this clear to everybody?
Yes, sir.
Clear.
I carry forward this result of cell 2 to cell 3. Why? Because up to cell 2, it's all accounted for in 49. Look at the diagram now. From right of A to left of D, is there any new force?
No, sir.
No change, sir.
So there is no change. It remains 49. Correct, guys? Yes or no?
Yes, sir.
Yes.
Then I carry the result of 3 to 4 plus 49.
Minus 30.
Minus 30 is the change from left of D to right of D. Minus 30. And it becomes plus 19. Correct, beta?
Yes, sir.
I carry forward this plus 19. And I'm asking you, From right of D to left of C, is there any change? Only look at
Zero.
that section.
No changes. Zero.
So
Zero,
this will be plus 19. I carry forward this result plus 19 here. From left of C to right of C, I have minus 50. It
50.
becomes minus 31. Then I carry forward minus 31. And from right of C to left of B, the change is 0. So it's minus 31. Then I carry forward this minus 31 and I have plus 31 becoming 0. Correct, beta? Okay.
Yes,
So
sir.
one thing can I add?
Yes.
Yeah.
So like just for the crux of the situation, can we mention?
Now I make the SF diagram here, beta. Under A, I have A. Under D, I have D. Under C, I have C. Under B, I have B. Okay. It goes from plus 49, so 10, 20, 30, 40, 50. You can calibrate it. Shearing force in newtons here, both up and down. Minus 10, minus 20, minus 30, minus 40, minus 50, 10, 20, 30, 40, 50. Okay. Now, at A, now look at the table. Now the table speaks by itself. At A, the value changes from 0 to plus 49. Correct, beta?
Yes, sir.
And here, you see, it's changing from 0 to plus 49. So it changes from 0 to plus 49. Then from plus 49 up to D, it remains plus 49 only. Then at D, it changes from plus 49 to plus 19. Then it remains plus 19 up to C. Then it becomes minus 31 at C. Remains minus 31 and becomes 0 at B. We get the same shearing force diagram instead of 14 points that we took there. Now we have done it with this table that we made with just 4 points, right, guys?
Right, sir.
And this is your shearing force diagram for this particular question. Beam is named AB by the question. Length of the beam is 10 meters. Its weight is 50 newtons. And is this 50 Newton at one point or is it uniformly distributed, guys?
Uniformly distributed.
Uniform.
At what rate? At what rate? 5 newtons per meter, right?
Yes, sir.
Yes, yes, sir.
50. Now you put the supports. There is a knife as support at A. There is a knife as support at B. There will be reaction at A. And there will be reaction at B. There is no other force on it. So the total downward force is RA plus RB is equal to 50 newtons. Does everybody agree with this step on the diagram?
Agreed, sir. Agreed.
Now I will calculate by moments. In this case, but such a simple case, I can directly see that RA will be 25 newtons and RB will be 25 newtons. But nevertheless, let's calculate by moments because now, as I said, preferably take the moments about one of the supports. So let's take moments about A. Now, taking moment, now whatever I'm writing is to be written, guys. Taking moments about A clockwise, positive, anti-clockwise, negative. Please write it. Okay. Now, first you identify how many forces are there in this question. How many forces are there? How many forces are there?
Three will be there.
Three, very good, very good. I always do it and you can follow if you want, or if you don't want, that's your choice. In rough, I always write the 3 forces from left to right. RA, then it is the weight of the beam, and then it is upper. Correct, guys? These are the 3 forces?
Yes.
Yes or no? Guys,
Yes, sir.
I agree with you. Oh, so let's write it. So what will be the moment of RA about A? RA into 0. Correct, guys?
Yes, sir.
Now, we talk of 50 newtons. Now, guys, we agree that this weight, 50 Newton, is not concentrated weight. But for the purpose of moments, like on a ship, if you have a 40-footer container placed on deck, a 40-footer container is placed on deck, what happens? The weight inside the 40-footer is distributed all along its length and breadth, yes or no?
Yes,
And
sir.
height, correct? But when I take container as one object, so again I'm saying, I know the weight is not concentrated if the container weighs, let us say, 30 tons. Now 30 tons of the weight is not at one point. But when I have to take the kg or I have to take the LCG, in other words, when I have to calculate the moments, I have to treat the container at one object as one object, yes or no?
Yes, sir.
For the purpose of moments only, the force is not concentrated. But for the purpose of moments, one object can be taken as one force, yes or no? Correct,
Yes, sir.
beta?
Yes.
And what will be that point? That will be the center of gravity of the container. Yes or no?
Yes, sir.
Correct, beta?
Correct.
Exactly the same way. I have this beam which is 10 meter long. Every cross section has its own weight. But if I have to take the moment of the full beam, then only for the purpose of moments, mark my words, I'm making some very emphatic insertions in between. Only for the purpose of moments, this 50 Newton can be assumed to be acting through its center of gravity, yes or no? Like the container example
Yes.
I gave you.
Yes, sir.
Sorry?
Correct, sir. We can take its center of gravity.
Correct. So, but it is only for the purpose of moments. Only for the purpose of moments. Okay. Not the force is not acting through it. The entire force is not concentrated at one point. It's concentrated, spread over the entire length. But only for moment it can be taken as a singular force, right, guys? So tell me, what I do is, you can follow it if you want. You don't want to follow, don't follow. It's your choice. What I do is, I take my pencil, a very light pencil, like I'll take the yellow marker. I'll mark the geometric center of gravity of this beam and just mark a very small arrow and just leave it like there for a moment, because after that this point has no relevance to me. Correct, beta? Because the force is not concentrated here. Yes or no? Correct?
Correct, sir.
Correct? Okay. And I'm not writing anything on it so that it does not tomorrow later on confuse me. I'm not writing anything at all there. I just put a small arrow there to help me in identifying. So now, tell me, what will be the moment of the weight of the beam about point A?
15 to 5.
Into 5.
Who will tell me the sign?
Plus 15.
Plus into 5.
Plus
15 to
50
5.
into 5. And RB is anti-clockwise, so minus RB into 10. And this has to be 0, yes or no?
0. Yes.
This gives you RB is equal to 250 by 10 equals to 25 newtons. Yes or no?
Yes, sir.
Okay. How I knew it is 25 newtons? Because at the mid length, if I see the distribution of forces both downward and upward, they are mirror image of each other. Yes or no?
Yes, sir.
Upward forces A and B, and the weight of the body, weight of the beam, everything is symmetrical. So therefore I could make out it is equal, but you can always calculate by moments. Right, beta? Everybody is good with the moments
Yes, sir.
and reaction calculation. So the second step is done. Now guys, again, this is my rough work here. Tell me the key points or the critical points. Look at the diagram. Use whatever was told to you earlier. Which are the critical points in your opinion? Minimum.
3.
3, sir.
Somebody says 3. Okay. Which are those?
ABC. ACB.
AC. Okay. Why C is critical? You can take, as I said, if you have doubt, you can take. But why C should be taken? Why do you need C?
Because
Tell me what is there acting?
We can say it should be 2 also, sir.
What is that? What is? No, no, I'm just asking. You take C. I have nothing against it. You will still get the answer. But why C? You think should be counted?
Because
Because
G is
usually
acting down.
It's a force,
sharing
sir.
force,
It's a force.
sharing force can act
Sorry?
more on the center.
Sorry,
no,
It's a force that is acting downwards.
which force is acting through C?
no
CO.
force
So
is acting
uniform
just
force.
for, sir.
Eh?
The weight of the beam, sir. Weight of the
That is
beam
for
is
the
acting.
You guys don't listen
no,
to me. What I said.
uniform beam. It is UDL.
What did I tell you? What did I tell you? That only for the purpose of moment, if you are treating beam as one object, then the weight can be assumed to be acting through there. Did I write 50 Newton there on the yellow arrow?
Yes, sir.
Did I write there?
No, no.
No, sir. Yes.
What,
Sir,
what
we
did
know
I
that
tell?
it is distributed uniformly, but like if we consider point C, then we can take that the force is acting.
So are you trying to say that the moment I go to the left of C and right of C, entire 50 Newton will come into picture?
No,
It will
sir.
not
Next
depend on the.
will
not-
So then,
No,
so
sir.
then,
That will
so
be
then,
5
so-
into
so-
5.
yeah, it will depend on the length, no?
Yes, sir.
Yes, sir. It will depend.
So only for the purpose of moments. Why? क्योंकि कुछ points के इस तरफ है, कुछ उस तरफ है. For the purpose of moments, I made this statement and you see, I warned you there that I'm inserting some important points. What points did I insert? That only for the purpose of moments, you can take this entire weight to be acting through its center of gravity. You forget everything after listening, right? And suddenly you say, if you take C, I have no issues. I'm not against C because I also told you that if you have any doubt, please take C. Okay, I'll take C also, but C is not genuinely required. That's all I'm trying to say.
Actually, sir, that just for the graph purpose I took C. That's it.
No, you can take
I'm
two
making
more. No, you can take two
symmetrical.
more.
Yes, sir.
You can take two
Yes,
more.
sir.
I said, what difference it makes to me?
Yes, sir.
But what I was asking is, when I'm saying what were the minimum points, then C does not qualify to be in the minimum points to be taken. That's what I'm saying. I've already said if you want to take more than minimum, it's up to you. So let me do A and B and C. I will not be using. I'll just leave C in between, blank, and just to satisfy your this thing. Now we make the SF table. And I'll only use 2 points, though I'll be making C also in between. And then we'll see that C also automatically matches with the graph. So A, C, B. Okay. Sharing force in newtons. Guys, which cells need to be divided into 2? A, C, B, or only A, B, or only A, or none of them?
A and B.
A and B.
A and B.
A and B. Okay. So now your reason for selecting C has gone for a toss, correct? Fine.
Yes.
No mind. Okay. What now? Now I'll not say anything. Tell me, what will be the sharing force in the upper cell left of A? 0.
0, sir.
First I take forward 0. What is the change from left of A to right of A with sign?
25 newtons. 25
अरे
newtons.
sign.
Plus 20.
Sign
Plus
for
25.
Plus
Plus 20.
plus 20.
आधा आंसर देने का शौक हो गया बेटा तुम लोगों को. Plus 25. Okay. Let me take up to C. Plus 25. Okay. What is the change from A to C? Is there any force
0.
coming from? There is no
0.
change.
Yes, sir. Yes, sir.
There is no change.
Sir, left का है ना
Yes,
sir?
sir.
One second.
There is change.
One second.
Minus 25.
One second. Everybody, those who have doubt, just tear off a piece of paper. First cover it up to A, and then uncover up to C. Now you see, is there any change that you are seeing from A to C?
Plus 25, sir.
So
Yeah.
minus 5 into 5. Minus 25.
Yeah, weight of the beam. This
Minus
weight.
25. Minus 25.
This weight. Yes or no? Yeah. So minus 5 to 5
5.
becomes 0. Correct?
Yes, sir.
Then I carry forward 0. What is the change from C to B? Again, another
So
minus
minus
20.
25. Minus 25.
and then it becomes minus 25 plus 25 becomes 0. Correct, guys? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So this is the table. Now I'll make the graph without C, and you will see that in graph also C comes 0. I'll not use C for making the graph, and you'll see that R value from graph also comes 0. Now I make the
Sir, I have a doubt regarding this C. C के लिए भी दो before C और after C में क्या आएगा सर?
why C has to be, when do you divide into 2? When do you divide into 2?
Okay sir, when the point no points are there, point weight होगा तभी divide करेंगे.
Point force, beta. Don't say point weight, point force.
Okay.
I'm not marking C at all. At A, it changes from 0 to plus 25. Okay, let me change to blue. Okay. At A, it changes to 0 to plus 25, and same distance will be minus 25 here. Changes from 0 to plus 25. At B, it changes from minus 25 to 0. I'm just circling for discussion sake. Now this point and this point have to be joined. Now, they can be joined in infinite ways, different curves, straight line, curves, so many curves, circular, non-circular, so many ways can be there to join. How do I join them? Now you look, this diagram holds the key, beta, the beam diagram.
Straight.
When you go from A to B, every meter is the change at a uniform rate. Is the change taking place at a uniform rate?
Yes, sir.
From plus 25 to minus 25, what has made it from plus 25 to minus 25 was the weight of the beam, correct?
Yes, sir.
And weight of the beam is uniform. It's 5 newtons per meter, correct? Correct. So the change from plus 25 to minus 25 has happened at a uniform rate. And we know from maths that whenever there is a rate of change is uniform, when the rate of change is uniform, the graph is a straight line. It's a slanting straight line. The graph of a uniformly changing figure is which is changing at a uniform rate, is a straight slanting line. So from there, the fact that this diagram tells us that the rate of change is uniform, that tells me that these 2 points have to be joined with a straight line. So put your scale on these 2 points, join them, and this becomes the blue line. Blue diagram becomes the diagram, SF diagram for this question. And you'll see this is cutting here at midpoint, the C. So at C it is 0. In the table also it was 0. Okay, beta? So you could have drawn it with A and B also. C was not required, but if you've taken C, it's okay. But don't taking C and then taking 50 newtons as point force there will be a blunder. That will be a blunder. Please look at it and let me know if you have any doubts. Now you should not repeat these mistakes when such things. Yeah. But don't always doubt yourself either. Okay. May I request everybody to make this diagram first? Then I'll make, and if you make mistakes, then you will ask yourself why you have made a mistake and then correct it. Please make the diagram of this question. That is the first step. So first thing I said was to make the diagram. If your diagram is wrong, the question is going to be wrong, bound to be wrong. Sure. Guys, those who wanted to draw, have you drawn?
Yes, sir. The diagram drawn.
Just a minute.
Okay, Okay. Though, let me know once you're done, then I'll draw it better. Because I want you to first make it, because if it's right, it will give you a lot of confidence. If it guys, is this the right diagram or something? I have also, you can correct me if I have missed out anything.
Same, sir.
Anybody who needs clarification on diagram, please let me know. Anybody who needs the diagram? None? Okay, guys?
Made it, sir.
Okay.
So can you repeat? Your voice got cut.
I said
sir.
answer my questions. Is the reaction at point A a point force? Yes or no? At A?
Yes, sir.
Yes, sir.
Okay. Is the reaction at the other end also a point force? Yes or no?
Yes, sir.
No, sir.
Agree that in this diagram, this is only for discussion. Huh? This is not to be taken down. Tell me how many point forces are there?
5,
RA
sir, 5.
and 10, sir.
4, sir.
RA and 10, 2 point forces.
What was my question? Who said 4, 5? What was my question, beta? What was my question to people who said 4 or 5? What was the question? Did you listen to the question before responding? I said in this diagram, how many forces are point forces? Now answer the question.
2.
So 2 forces.
So you guys start responding without even listening, caring for the question, right? Good. Fantastic. I'm trying to just make sure that you people understand the concept. I don't want to get into writing the expression straight away. So 2 forces, RA is a point force and 10 Newton is a point force. Does everybody agree?
Yes,
Agreed.
sir.
Correct?
Yes, sir.
And uniformly distributed forces, I'm not saying UDL, I'm saying forces up or down. 30 Newton is a UDL. Then weight of the beam is UDL, it's uniformly distributed. And reaction on the right side is also uniformly distributed. Do you agree with me? Out of 5 forces which are acting on this beam, 2 are point forces and 3 forces are uniformly distributed. Does everybody agree with my expression?
Agreed, sir. Agreed.
Yes, sir.
Okay. So, for the purpose of moments, I don't think you have any doubt about the point forces. Okay. The forces which are not the point forces, which are 3 in number this time, what will we do for the purpose of moments? For the purpose of moments, only for the purpose of moments, the forces will be assumed to be acting through their respective centers of the force, correct? Center of gravity is for the weight, but centers of their force, right? Center of gravity is the center of force of weight, right, beta? Correct?
Yes, sir.
Yes, no? So now I'll use my yellow marker only for the purpose of explanation that the three forces that we are talking about, for the purpose of moments, they are not acting at one point. I'm again saying don't get confused. For the purpose of moments, this 30 newtons can be assumed to be acting from here. This 50 newtons, the weight of the beam, can be assumed to be acting here. And this reaction on the right side can be assumed to be acting upwards through this for the purpose of moments. Do you agree with these three arrows that I marked? Yes or no?
Agreed, sir.
Yes, sir.
Correct, Peter?
Correct.
Okay.
Correct.
Okay. Now, since I will need this point to name the reaction, in very light, I can call it as X. I will not, this point after reaction will have no relevance. So what will I calculate? I'll calculate Rx. I'll calculate Rx, and that Rx will not be acting at this point. That will be uniformly distributed over 4 meters. Right, guys?
Right.
Right, sir.
Okay. Now you see how I do. And if anybody does not agree with any of the things I'm doing, please interject then only. Because otherwise, kya hoga? You'll just keep wasting your time. Then everything that is being done after that would also go down the drain. Now you see, I have 5 forces. I'm taking moments about A. Moments about A. I'll take clockwise as positive. Anti-clockwise is negative. From left to right, my first force is Ra. That will become Ra into 0. My second force is 30 newtons. That is over 3 meters into 1.5. That will be downwards, so minus clockwise. So plus 30 into 1.5. Okay. Then I have 10 Newton of concentrated one. Again clockwise, 10 into 5. Then I have the weight of the beam, 50 newtons, 50 into 5. Then I have 1, 2, 3, 4. Then I have this reaction at X minus Rx into 8. And this is equal to 0. Please review this expression and ask me very specific question if you have anything about this expression. If you have any very specific, that's what he's saying. Is he right, guys? And you see how I'm writing. I'm not going to write it at X. Now you see how I'm documenting on the diagram. I'm saying reaction is equal to 43.125 at a rate of, can you divide by 4 and give me 110 point, how much? Can you divide 43.125 by 4? 781 Newton per meter. Does everybody agree? This is how I document it on the diagram so that I know that this reaction is not acting at one point. Right, guys? Clear? In the first case,
Yes.
in the first case, 30 Newton UDL is coming to an end. So at point D, 30 Newton UDL is coming to an end. Correct? Yes or no, beta? The
Yes,
starting
sir.
of the starting of the UDL is already covered by A. Correct?
Yes, sir.
Yes, sir.
At E, the reaction which is uniformly distributed starts. Yes or no?
Yes.
And that ends at B, which is automatically covered. Yes or no?
Yes.
So, where in the case of a uniformly distributed force, whether upward or downward, wherever these forces start or terminate, those points also need to be included. You remember I had left the third point here. The third point I had left here blank. Yes or no?
Yes, sir.
That was for this purpose. So that means my points will be A, B, C, and E. E and B, right? These will be my points. The minimum points I'll have to take would be A, D, C, E, and B. These are the minimum. If I don't take so many points, I will not be able to close out my shearing force diagram. Have you understood, guys?
Understood, sir.
Any questions on the
Understood,
choice
sir.
of points? Okay. Now, please make the shearing force table. And if you have a doubt, make it in rough and fill in the values. I'm not going to say anything. Again, like diagram, you make as many mistakes as you want to make. No issues. Please do it by yourself. Make the table, divide whichever you want to divide, not divide, do whatever you want to do. I will make the table after that. And then let's see how many of you are right on it. Five, bottom, 1, 2, 3, 4, 5. Okay, now please ask me whatever doubts you may have. We got B. Okay. Then we said we have to have all the points where the point forces are there. In this diagram, there are only 2 point forces. One is the RA, other is the 10 newtons. So that means we have to, RA is already covered in the A. That means 10 Newton needs to be included. I called it at C. So now I have 3 points, A, C, and P. Now, if we look at the diagram, beam diagram, what do we see? When we start from A and go towards B, after 3 meters, this force comes to an end. Though it is not concentrated, but that is where it breaks. Okay, so that means this point also there is a change taking place evidently. So we take this point as D. So this was D after A. Likewise, the way you had a break in force on the UDL after C at this point, let me use the laser. I don't want to mess up the diagram again. Guys, anybody has doubt? There is a break in a force here, yes or no? That is why D has been chosen, yes or no? Correct?
Correct.
And there is a break in force here also. The buoyancy starts in from here, the reaction starts in from here and goes up to B. B is already there, so that means we have to identify this point also. Which point? The point where the reaction begins. Now reaction is not totally acting there, but where the reaction begins. Okay, so we had A, we had D, we had C, we had E, and we had D. And that's how we came to 5 points. Is the choice of points clear to everybody now, guys? Clear, beta?
Yes.
Okay. Then we made, I'm again explaining one more time because I don't want people to be struggling after the class. Then we made a table for 5 points. This is shearing force in newtons. The points have to be in the same order as in the diagram. So then A after A is D in my diagram, so it will be D. After D is C, after C is E and B. So I made these 5 spaces for the thing and I put the points in the same order as they were put earlier on the diagram. Then I looked at the diagram as to which are the concentrated forces. Why? Because wherever you have the point forces or the concentrated forces, and now in this diagram, if you see, RA is a concentrated or a point force, and this 10 Newton at C is a concentrated force. Because there are only 2 concentrated forces, what we'll do is we'll divide the cells of these 2 points into 2, that is to the left and to the right. So we'll divide these cells. Let's divide these cells. Okay. Now that means A needs to be divided into 2. Now I'll change the color so that you don't miss out on the thing. And C is divided into 2 because there is a point force. Is that clear to everybody now? Somebody who was saying why at C? Is that clear, beta? I'll again give commentary now as I'm writing, and I'll use the green pen so that the 2 cells divided into separate cells don't get missed out. If I look at the diagram, I'm looking at the beam diagram. To the left of A, there is no shearing force. I carry forward this 0 here. The moment I go to the right of A, just to the right of A, where there is no distance covered as such, the new force that comes into picture is RA upwards. And RA upwards was 46.875 plus, and it becomes plus 46.875, guys. Then I carry forward this plus 46.875. Now look at the diagram. I'll mess up this diagram, the smaller one here. From A to D in this span, guys, how many forces are coming? The UDL is completely coming in this range. So that means 30 newtons downwards minus 30. And also the weight of 3 meters of beam. Weight of 3 meters of beam would be minus 5 into 3. And when you account for this, this becomes plus 1.875. Any questions for A or D, beta? Anybody? Clear, beta?
Clear.
Yes, sir.
Then we carry forward this plus 1.875. And I go back to my diagram. From D to left of C, because this upper cell is to the left of C. From D to upper left of C, you have 2 meters of beam weight which comes into picture. That means 2 meters of beam weight will be minus 5 into 2. And this is what becomes minus 8.125. Then I carry minus 8.125 here. And from left of C to right of C, you have another minus 10. The concentrated load comes into picture, making it minus 18.125. All clear about C, beta? To the left of C and right of C, clear?
Yes, sir, clear.
Yes, sir.
Okay. Then we carry forward this minus 18.125. And now we see from right of C to the left of E. Look at this diagram. The only thing coming into picture is 1 meter of beam weight. 1 meter of beam weight will be minus 5 into 1. This becomes minus 23.125. Okay. Then we carry forward minus 23.125. And from E to B, you have the weight of this much beam, that is 4 meters, minus 5 into 4. And you have the total reaction of upwards of 43.125 plus 43.125. So this becomes 0. Is it now clear to everybody, or still anybody has doubts, beta? Tell me now.
Clear, sir.
Last
Clear,
opportunity for people to sort out the simple. This is the complex situation I created intentionally. Whatever confusion has to happen, let it happen here in this question, because I have brought in everything in this question. Now we go on to making the diagram. My value is plus 46. Plus 46 seems to be maximum, and minus 23. Plus 46 minus 23, so I'll leave little more space. I can use green here. Now I can use this green space here. I leave more space on top, some lesser space down below. Okay. I have A. From A, 3 meters from A, I have D. From D, I have 2 meters, so 3 will be here, 2 would be here. This is 3 meters. This is 2 meters. 2 meters later, we have C. Then we have P at 5 meters here. And we have E 1 meter from here. Something like this. So this is 1 meter. This is 4 meters. Now I'll basically, what is it going to? 0 to plus 46. So let us say plus 46 is here. Whatever, you can choose the scale. I'm not going to go to exact scaling here. So I will just use the approximate scale and do it with black marker. So I go from 0 to plus 46 here, guys. 46.875. So this is 46.875 plus. Then from there, I go to plus 1.8 at D. So I come here. This value is plus 1.875. Okay. The issue is, how do I join these 2 points? I go back to this diagram where I'm putting the tick mark. I see from A to D, the forces were the UDL, which is uniform, and weight of the beam, which is also uniform. That means the rate of change will be uniform. Have you understood why I'm saying the rate of change is uniform, beta? Because the changes from A to D involve 2 forces and both are uniformly changing, right? So the resultant will also uniformly change, yes or no? Correct, beta?
Correct, sir.
So I will take my scale and join them with a straight line, like this. Then, after 1.875, it goes to minus 8 at C somewhere here. Minus 8.125. Okay. Now I see from D to C, there is only one force which is changing the weight, and weight is changing at a uniform rate. So I again put my scale between these 2 points and join them. Okay. They are all both straight lines independent of each other. Then from 8.125, it comes to plus minus 18. Minus 18 would be somewhere here. So it goes to minus 18.125. Then from there it goes to minus 23. At E it goes to minus 23. I look at the diagram from C to E. C to E is the change only because of the weight of the beam. So it will be at a uniform rate, straight line. Okay. Then E to B is 0. What are the forces from E to B, beta? One is the weight of the beam, which is uniform. Other is reaction, which is also uniform. 2 forces, reaction and the weight. Up to this part, everybody is good, or any doubts up to this point? Calculation of reactions and the drawing better. Everybody is good up to this point now? Or any concerns? None? Fantastic.
None, sir.
Then we had the SF table. And for SF table, what had we done? We had chosen these 4 or 5 points. Then we made the table and we got shearing force at these points. I'll write the shearing force here that we got, or can somebody give me the shearing force? At A, it was from 0 to plus 49. At B, it was plus 49 to minus 9, plus 19. At C, it was plus 90 minus 31. And at B, it was minus 31 and 0. Looking at the beam diagram, because it's a simple one, these were the shearing force values we got. Yes or no, guys?
Yes.
Correct. Okay. Now, the shearing force diagram, I'll make a small one here, not a very big one. I don't want to occupy space. 2 meters from A was D. Okay. 3 meters from D was C. And 5 meters from C was B. And then in blue, if you allow me to make the diagram. And if anybody has still any concerns about what we have done, please let me know. 0 to plus 49 remained plus 49. So this was plus 49, guys. Then it came to plus 19 to a scale, of course. Then it came to minus 31 and became 0. Everybody agrees with what I've done until now, beta? Or any
Excuse me, sir.
Yeah.
Sir, I am having the same problem right now. Do you have the screen, the slide on?
I have the slide on, beta. Is it visible? Let me check with others. Is it visible to others, beta?
Yes, sir. Yes, sir.
Okay,
Yes,
sir.
sir. Visible.
Can you please sign
Yes,
out
sir.
and sign in again? Sign out and
Oh,
sign
sir,
in again.
I'll do that, sir. Okay, sir.
Do that and let me know once you're back.
Okay, sir.
Yesterday I said, okay, give me between A to D, D to C, or C to B. And the distance between those 2 points was not relevant yesterday. But today, when we are going to talk about bending moment at a point now, can you mute yourself better now? When we are talking of bending moment at a point, its location along the length of the beam will become relevant. Okay. So just to save on time, let me take a point X, which is 1 meter from D. It could have been any point, guys. Okay. It's just I've taken randomly. Okay. But now this distance will become relevant. Yesterday, this distance was not of importance. Now, which is our point of interest? X. We want to calculate the bending moment at X. Okay. What is going to cause the bending moment at X? The forces which are acting on either side of X. Let's take, yesterday we took the stock of, we took we saw what was the algebraic sum of forces to one side. Let's today carry out the same exercise for moment. Okay. Now, guys, we are talking, yesterday you all saw how we took moment about A or any other point, okay, when we were doing the reactions. Today, we are going to take moments about X, the point in question, okay. So what are we doing? I'm not writing that here. We are taking moments about point X. And let's take, first, let's go from left to right, and then I'll come from right to left. Now, to the left of X, there are two forces, 49 newtons and 30 newtons. Guys, if you hold the right side of the beam at X, because your point of interest is now not A but X, so lever shall be about X. Clockwise or anti-clockwise direction of the moment will be with respect to X. Now I'm just putting a rectangle here to highlight that this is the point about which we are taking the moments. I'm sure you'll agree with me that the moment of 49 newtons about X would be clockwise, as you can see with this arrow. And the moment of 30 newtons about X would be 49 Newton will be clockwise, and 30 Newton will be anti-clockwise, as you can see with these two arrows with respect to X that I have marked. Does everybody agree or any questions? Moment of 49 Newton about X will be clockwise, and moment of 30 newtons about X will be anti-clockwise. Does everybody agree with that directions, clockwise and anti-clockwise with respect to X?
Yes, sir.
Agree.
Okay. So the moment of the moment of the forces to the left of X are force multiplied by lever from X. So for 49 newtons, which is clockwise like this, it will be 49 into 3. Does everybody agree? This will basically result into clockwise of 7 to 12, 147 clockwise kilonewton, Newton meter. Yes or no, beta? 49 Newton will cause a moment of 147 Newton meter about X. Yes or no? Tell me, guys.
Yes, yes,
If
Yes, sir.
if anybody has any doubts, because let's not wait for 10 forces to be written and then going to the first one saying why it was so. Lever from X of the force is 2 plus 1, 3 meters. So that is 49 into 3 is the moment. And you can see in the diagram, I have marked the arrow, it is clockwise. Exactly the same way, the moment of 30 newtons will be anti-clockwise. I am drawing the arrow in the anti-clockwise direction, and the moment would be 30 into 1. And this will be 30 into 1 Newton meter. Why Newton meter? Because the unit of the force is Newton and unit of distance is meter. So the product is Newton meter. This results into a resultant of, if I take the resultant of the two moments, the forces to the left of A give you a resultant moment of 117 Newton meter in the clockwise direction. Does everybody agree with this inference of mine or any concerns? Does everybody agree with this?
Right, sir.
Or any? Sure?
Agree, sir.
Okay, very good. Let's do the similar thing to the right of, for the forces to the right of this X. X. Again, I have two forces. Which are the two forces? One is 31 Newton, one is 50 Newton, other is 31 Newton. These are the two forces to the right of it. Now, if you see about X, tell me, is 50 Newton going to cause clockwise movement about X or anti-clockwise, guys?
Clockwise, sir.
It is going to cause clockwise movement. See this arrow. And about X, 31 Newton is going to cause anti-clockwise movement. Okay. What will be the clockwise moment of 50 Newton? It will be 50 into 2. Am I right, guys? It will be clockwise,
Yes.
100 Newton meter. Correct?
Yes,
But
sir.
why? Because this distance is 2
2 मीटर का सर,
meters.
1 मीटर है ना सर पीछे.
Correct. Right. Okay. The 31 Newton will cause anti-clockwise movement of how much? 31 into 3 meters from this end into 7. Am I right, guys? Lever is 7 meters for 31 from X. Yes or no?
Yes, sir.
This results into an anti-clockwise movement of 7217. I take the algebraic sum of these movements to the right of X, and I get again a value of 117 Newton meter. But this time it is anti-clockwise. Correct, guys? Please see these two workings and let me know if there is any concern. Today, the numerical value is same on both the sides. Difference is on one side it is clockwise, on the other side it is anti-clockwise. And I will not take another point because yesterday we took 2 points to satisfy. This you can carry out at any point along the length of the beam. You will be obtaining similar results. What is the similarity? The values on both sides will be same. Same does not mean 117. They'll change from point to point. But whatever is the value of the bending moment for the forces to the left of the point, same will be the numerical value of the moment of forces to the right of point in question. Only thing is, if one is anti-clockwise, other will be clockwise. If the first was clockwise, the second will be, other side will be anti-clockwise. Understood, guys, what I'm saying? You will find similar results. If you want, I can carry out one more point. Let's say we are at a distance of, let's say 1 meter from end B. Let's talk of point Y. Now to the left of Y, there are three forces. What are the three forces? 45 Newton, 49 Newton, 30 Newton, and 50 Newton. These are the three forces. Now about Y, now let me change the color to blue. I'll mark the, after some time you don't have to mark these anti-clockwise, clockwise things. About Y, now Y is the point of interest. 49 Newton is going to cause clockwise. 30 Newton is going to cause anti-clockwise. Now about Y, 50 Newton is going to cause anti-clockwise. Whereas 50 Newton about X was causing clockwise. So you can see for different points, different forces may change. For some point it may be clockwise, for the other point it may be anti-clockwise. Am I right, guys? Yes or no? Correct, beta?
Yes, sir.
Okay. So this distance is now 4 meters, right? So for 49 newtons, it is 9 meters of lever and it is clockwise. So for 49, it is 49 into 9 equal to 9 9s are 81, 8, 401. 36, 8, 41, 441. Am I right, guys? 441 Newton meter, and that is clockwise. Please let me know. Otherwise, if there's a mistake, it will show up by itself. Don't worry. Second would be the 30 Newton force. 30 Newton force is going to be at a distance of 6 meters from Y, and that is 30 into 6 equal to 180, and this will be anti-clockwise. 50 Newton is at a distance of 4 meters, so 50 into 4, 200, again anti-clockwise. The resultant will be 380 anti-clockwise, 441 clockwise, so it will be 61 Newton meter. The resultant in the clockwise direction. Please check it. If I made any mistake, you can let me know.
But 30 into 7 होगा ना sir?
Which one better?
The 30 Newton will be
Into 7, sir.
30 into 7 hoga? Why?
Yes, sir.
Yes.
Why? Why?
Because you took 1 meter from B side.
Okay. So that means, okay, 30 into 7. Okay, my mistake. 30 into 7. Okay, make it 210. Then how much it comes to? What is the resultant then? 210, 410. So it is 21. Is
30.
it? 31.
30.
31 Newton
31.
meter. Okay, clockwise. Right, beta. Okay, fine. Okay, everybody's good about now moments about Y, or any questions? Why is this point? Okay. How many forces are to the right of Y? Only one. What is its lever? 1. Is it going to cause clockwise or anti-clockwise? It's going to cause anti-clockwise movement. So the force to the right of Y will cause anti-clockwise movement. That will be 31 into 1. That will be 31 Newton meter. Again, we see the similar thing. Numerical values are 31 on both sides. If it is clockwise on one side, it is anti-clockwise on the other. I think now you should not have any doubts as to whether this sort of thing will be experienced at all the points. Yes or no, guys? Correct?
Yes, sir.
Now, again, you hold the pen with the cap closed and hold the pen up to the where the cap ends. So that is the point X. Okay. Now, if you are holding the pen at X in your palm, right? You've supported it. What happens? The right side of X, this much of length, is causing a bending moment of 117 Newton meter in the clockwise direction. That means this part of the pen is tending to bend upwards with respect to point X. Yes or no? Just see. If you try to move the right side upwards in the anti-clockwise direction by 117 Newton meter, so at X, what will happen? The right side will tend to bend upwards. Yes or no? Yes or no, guys? Can you feel it?
Yes, sir.
So
Yeah, tell me if somebody was saying something. 117 Newton meter is the bending moment which is tending or trying to bend the beam at point X. Please analyze what I have said and let me hear your doubts. Agreed? Moment at different points, like Y you got a different value, X you got a different value, you take another point Z, it will be a different value. Whatever are the bending moments at different points. Why? Because the forces, their distribution about the point will change, and as you shift the points, the levers would also change. Levers from each force would also change because the distance from the forces will keep changing as you shift from one point to another along the length of the beam. Right, guys? Yes or no?
Yes, sir.
So this 117
Yes,
Newton meter at X is its bending moment. Likewise, 31 Newton meter is the bending moment of the beam at Y. Now, whether the beam will bend or not, that will depend on the strength of the beam. Whether the beam will bend or not will depend on the strength of the beam. And if the beam is non-flexible, then it may just break, not even bend, because then okay, it does not have the flexibility to bend, it will break. So this is what is called as the bending moment. So if somebody asks you what is the bending moment, yesterday we defined shearing force as the algebraic sum of all the forces to one side of point in question. Yes or no, beta?
Yes, sir.
Right? Exactly the same way, bending moment is the algebraic sum of moments of all the forces to one side of the point in question. Bending moment is the moment of all the forces. So moment kiska hoga? Moment will be of forces, guys. So which forces? To any one side of the point in question. So bending moment is the algebraic sum of moments of all the forces, not the forces, the moments of all the forces to one side of point in question. Is the concept of bending moment clear to everybody, guys?
Sir, excuse me.
Yeah, tell me. Yes or no?
Yes, sir.
Okay. So this chapter we close here. Now, this anomaly, yesterday also we were getting the anomaly if the forces on one side were upward, on the other side were downwards. If they were downwards on one side, they were upwards on the other side. How did we resolve it? We resolved through a sign convention, which was reversed on either side, reverse of each other. The same thing we do here also. Why? Because on one side it is coming clockwise, on the other side it is coming anti-clockwise. So both will give 117 Newton meter answer, but one will say clockwise, other will say anti-clockwise. So what is the sign convention that is introduced to remove this anomaly? It is what sign convention is when you go from left to right, beta. When you go from left to right, as we went from A to X, clockwise moments are taken as positive and anti-clockwise moments are taken as negative. Obviously, if you're coming from right to left, convention gets reversed. Clockwise movement gets negative. I remember only one, I don't remember both. I can write from the first, from the second one, and this becomes positive. So the convention is reversed so that both either become plus 117 or both become minus 117. Is that clear? Clear, beta?
Clear, sir.
So let's see what will be the sign of 117. Can you see what is the sign of 117 then? Both from left and right, just see the sign. When I go from left to right, 147 is clockwise, so this is positive. 30 is negative, so this becomes plus 117 Newton meter. I don't call it clockwise or anti-clockwise. When I come from right to left, clockwise is positive, so this is clockwise, this is positive, this is anti-clockwise, this becomes negative. Is it? No, anti-clockwise is negative. Sorry, by mistake. Anti-clockwise is no. Clockwise is negative. So clockwise is negative. Anti-clockwise is positive, and this again results into 117 Newton meters plus 117. Correct, right? The opposite sign convention in our case at X is going to give us the value of bending moment as plus 117 Newton meters. Is that clear, beta? So we'll not call it as clockwise or anti-clockwise. We'll give it by sign plus or minus. And here the answer at X is plus 117. Is that clear, beta? If I shift the points, it is going to become very cumbersome because every shift of point will change the lever, cause the lever to change. So if I start calculating the bending moment at say 5, 10, 15, 20 points along the length, It's going to be very, very cumbersome. Not that it is not doable. It's going to be not a user-friendly way. First and foremost, you tell me, if I, like yesterday, if we decide that we'll always go from left to right and I forget this. So when I go from left to right in a beam, that beam which is there, okay, RB. Now, if I take any point, let's say here, Y or whatever, if I go from left to right, guys, look at the sign convention. Tell me, is it the upward forces which are going to cause clockwise movement or downward forces which are going to cause clockwise movement? Correct, beta? That means, and yesterday when we went from left to right, upward forces were positive and downward forces we took negative. That means, in other words, when I'll go from left to right, in shearing force, upward force is positive, downward force is negative. When I go from left to right, clockwise movements are positive and they will be caused by upward forces. That means moments of all the upward forces when going from left to right will be positive and moment of the downward forces would be negative. And that's how you got plus 117 at X, or you got 31 Newton meter at Y, whichever you say. We can see what will be the sign of 31. We can see. We were not going to get into this cumbersome calculation of multiplying by levers because you see, some of you corrected me. I also made this mistake. Somebody said 49 into 3, whereas I had taken 49 into whatever I had taken. Okay. Somewhere, no, in this, you corrected me somewhere, I think. Where did you correct me? In the lever? 49 into 3.
30 into 7, sir.
30 into 7. Okay, here you corrected me 30 into 7. Fine. So what happened? I made a mistake. Why? Because it's not a user-friendly way. It's not a user-friendly way. Anybody can make a mistake. The clerical mistakes are possible. But let me take you back to the SF diagram. Where is my point X? My point X was 3 meters from end A. That means it was here. Correct, beta? X is here on the line. 3 meters from end A, 1 meter from D. Yes or no? Correct, beta? Correct, beta?
Yes, sir.
Does everybody
Yes.
agree? Go to the shearing force diagram now. Is X here? Yes. Calculate this area to the left of X under the shearing force diagram.
It is coming 117 positive.
Positive because it is above the x-axis, right?
Yes.
The bigger rectangle will be 49 into 2 plus, of course, it's
19
plus,
into 1.
and the other will be plus 19 into 1, and this will give you plus 117 Newton meter. Why Newton meter? Because here the scale is meter, here the scale is Newton, so product will be Newton meter. Correct, guys? So what do we see? The area under the shearing force curve to the left of X is plus 117 Newton meter, which is exactly the same as the bending moment at X. Yes or no?
Yes, sir.
Okay. Let's carry out a similar exercise for Y also, and let's see what it turns out to be. For Y, Y is 1 meter from B. Y is here. What is the area to the left of Y? Here is Y, guys. What is the area to the left of Y? This yellow shaded area. This one,
1, 2, 1.
this one, this one, this one. This is the yellow shaded area to the left of Y. There are 3 areas. One is plus 49 into 2. Other is plus 19 into 3. And the third one is minus 31 into 4. Am I right, guys? These are the areas to the left of X, left of Y in the diagram. Yes or no?
Yes, sir.
Correct? And what do you get the algebraic sum of these? Plus 31 Newton meter. Just see, I've not done it. You can do it and see. It will come plus 31 Newton meter. Yes or no?
Yes.
What we'll be doing is we'll be using our shearing force diagram. We'll be using our shearing force diagram to get the BM. we will not be fighting with levers. We will not be wrestling with levers. And that is the reason why yesterday's full session was on the shearing force diagram. Why? Because if your shearing force diagram is wrong, then it's not going to get you the correct results further. So,
Sir, what doubt, sir?
yeah, keep it simple. Because natural tendency is from left to right, so let's stick to our natural instincts, you know. Okay. Okay, chalo. So now we'll be using the shearing force diagram to get our bending moment. Everybody is aligned up to this point? If any more questions on this, let me know, because then I'll be solving this complete question from beginning to end, writing down the steps so that you know the full process from beam to the bending moment. Diagram, everybody's good with it? Right, guys? Okay. Then we said, let's calculate RA plus RA, RB, everything. Now we are saying RA plus RB is equal to 80 newtons. You know it. Anybody who's got any doubts can speak up. Otherwise, I'm presuming that you are understanding whatever has been taught earlier, and we are moving with it. Okay, now, so RA plus RAB is 80 newtons, taking moments about. So I'm writing all the steps so that there is no confusion about what should I write, how should I write. Taking moments about A. So let the reaction be at A be RA, at B be RB. Taking moments about A, clockwise as positive, anti-clockwise negative. Now I take RA will be causing a clockwise moment, so RA into 0. 30 Newton will cause an anti-clockwise moment, minus 30 into 2. 50 Newton will cause an anti-clockwise moment about A. 50 into 5. RB will cause a clockwise will cause an anti-clockwise moment. So this is clockwise.
Sir?
Sorry, this is plus. Sorry,
Clockwise
this
आएगा
is
sir, 30 into 2
yeah,
clockwise.
कर दिया बेटा, कर दिया. RB into 10 equal to 0. This will give us RB as 31 Newton, and this implies RA is equal to 80 minus 31 equals to 49 Newtons. And I put my reactions on the diagram. RB is 31 Newtons, RA is 49 Newtons. All good up to this point, guys? All good?
Yes, sir. Yes, sir.
Okay, then next was we identify the critical points, and the concept used was both the ends, all the point forces, and in case of any uniformly distributed case, wherever there is a break in the distribution. Correct, beta? These were the three criteria: ends, point forces, and break in the uniform distributions. Yes or no? Correct?
Break in
Yes,
the
sir.
distribution.
Yes, sir.
Okay. So now then based on that, in this case, there is no UDL or anything. So we have straight A, D, C, B as the points. Then we'll make the SF table. Four points. 1, 2, 3, 4 points. Sequence must be respected. A, D, C, B. Shearing force units will be same as the units of the force. All the cells where you have point forces, they get divided into two. One to the left of the point, other to the right of the point. It becomes 0 at A, 0 plus 49 plus 49 here. Okay, plus 49 and 0, so plus 49 there. plus 49 minus 30 plus 19 here, plus 19 and 0 plus 19 here, plus 19 minus 50 minus 31 here, minus 31, change is 0, minus 31 here, minus 31 plus 31, it's 0 here. Does everybody agree with this table? Any questions?
Agreed, sir.
No, sir. This is okay.
Now we'll draw the SF diagram. Okay. You will of course take the scale on the y-axis and x-axis. You have A here, 2 meters from here you have D, 3 meters from here you have C, and 5 meters from here you have B. And you'll have shearing force. Audible, guys? Okay, fine. Audible, no? Confirm?
Yes,
Confirm,
sir.
sir.
Audible.
Okay, fine. Once you've done the shearing force diagram, which we did up to yesterday, now we'll come to the bending moment table. Okay. Now, you will pick up, next point will be identify the critical points for BM. Identify the critical points for the BM table. Yesterday we learned how to identify the critical points for SF, yes or no, which I just repeated a while back.
Okay.
And now
SF.
today we'll learn the critical points for BM. All the points which were there for SF, by default become critical for BM number 1. Clear? Is the first thing, if the SF diagram is crossing the x-axis at any other point than these, if the SF diagram is crossing the x-axis at any other point than these, which you have already selected, then those points also become important and need to be picked up. Only 2 criteria. All that were used for SF. 1, 2. If other than these points which are already selected, if x-axis is cut by the shearing force diagram at any other point than these, those points also need to be factored. Am I clear, guys?
Clear.
Okay,
Can you
simple.
repeat? I lost my connection. Can you repeat, please?
Where did you lose the connection? What did you hear?
Sir,
the
I
last?
think you were saying something like other than any other points other than the points given in SF table, it cuts the x-axis.
So that's what I said. So what is, you have not missed out anything.
Okay.
You have not missed out anything. Don't worry.
Oh, okay.
Sometimes we just have this apprehension that we might have missed out, right? Okay, fine. So in this case, which are the points critical for BM, guys? Then.
So can I reverse that? I just got A, D, C, B.
Yeah, okay. Is it cutting at any other point? The shearing force diagram is cutting at C. C is already selected, right? Yes or no?
Yes. Yeah.
Okay. So now we'll make now you see, you continue below this, but I am doing it here in this part. We make the BM table. And how do I calculate BM? I'm not going to calculate. Beta mute kar lo, please. Mute kar lo, please. Mute kar le, bhai. Okay. Now this BM table, we are making it very clear that how am I calculating BM? By areas under SF diagram. Is that clear? And now I make the BM table. And there will be no subdivision like SF table. It will be only one cell each because there will be no sudden change in the areas. So I need 4 points. These are the 4 points. These are the points. Again, the order is to be respected. Don't violate the order. What is the order? First is A in my diagram, then D, then C, then B. Here I'll have the bending moment. Units will be the product of the units on the y-axis and the units on the x-axis. In our case, the product is Newton meter. All clear up to this point, guys? Piece of paper, cut a piece of paper, cover the full SF diagram, align it with the y-axis, and ask your, once you've covered the diagram, is there any area under the shearing force diagram to the left of A? Yes or no?
No, sir.
What is the area under the shearing force diagram to the left of A? It is 0. So the bending moment at A is 0. Clear, bete? Is that clear?
Clear, sir.
Yes, sir.
Now carry forward this 0 to the next cell. And now move your paper to D and see what is the area that has come now between A and D. The area that has come into addition now is sine will be up plus 49 into 2. It will be plus 98. Yes or no, guys?
Yes, sir.
Is this clear at D? How did I get at D? Is that clear to everybody?
Clear, sir.
Yes, sir.
Okay. Now carry forward this plus 98 because up to D all is accounted in plus 98. Move your paper to C. What is the change from D to C? It is plus 19 into 3. Am I right?
Yes, sir. Plus
Correct?
19.
Yes, sir. 19
So
into
that
3.
will, yeah, so that will become plus 57. So that will be 155.
155.
Carry forward this plus 155 and move your paper to B. What is the change between C to B? It's minus 31 into 5 and it becomes 0. Please see it, evaluate it, and let me know if there is any. Now I'm going to BM table. Let me use the red one so I'll have clarity even if there's some overlap. Don't worry, I've decided to give the tomorrow session also to Beam only. So don't worry about it. We'll do all the questions that I shared with you yesterday. This is my graph for the BM table. Though my BM has all positive, there was no need for me to leave anything down below. So this part is not required, not relevant because there's nothing in negative. Okay. Under A, I have A. Under D, 2 meters later, I'll have D. 3 meters from there, I'll have C. And 5 meters from there, I'll have B. I will choose a scale of BM on the y-axis. Units will be Newton meter. And this will be my BM. Now I put these values, beta. How do I put these values? Let me use the green marker also here. First, I plot these values. At A, it is 0. So based on my scale, suppose this is plus 100. This is plus 200, let's say. At D, it is plus 98. So it is plus 98 here. Then at C, it is plus 155. At B, it is 0. I have just marked these points. Yes or no, guys? Correct? Based on the scale on the y-axis, right, beta?
Yes.
Okay. Now, how do I connect these points? Whether I join them with straight line, do I join them with a curve? For that, now you have to have your eye on the SF diagram. Go back to the SF diagram, and whatever I'm doing is only for explanation. You don't do that, guys. As I'm going, if I divide this into equal parts, is the area in as I remove my paper from one segment to the other, is the area increasing at a uniform rate from A to D? Yes or no?
Yes, sir.
Yes, yes, sir.
Area is increasing at a uniform rate. Why? Because this is a horizontal line. Correct, beta? Yes or
Yes,
no?
sir. Yes, sir.
If the area is, and you have got BM how? By adding the areas?
Yes, sir.
That means if areas are increasing at a uniform rate, the BM is also increasing at a uniform rate. Yes or no?
Yes, sir.
Yes, sir.
And yesterday, what did we say? When something is
That is, it
changing
is
at
a
a uniform
horizontal
rate, it will be a straight line.
straight line.
Slanting
Slant
straight line.
straight line.
So
Slanting straight line.
put the scale here, join them with a straight line. Okay. Go back to the diagram between D and C. From
Please,
D to
again,
C, it's again changing at a uniform rate. Yes, it's
Okay.
changing at a uniform rate. Join them with a straight line. Now look at the diagram, SF diagram between C and B. It's also changing at a uniform rate, reducing at a uniform rate. Yes or no? 31 newtons per meter. Yes or no, beta? Correct? So again with a straight line. This green one becomes the BM diagram for this question. Here you have the SF diagram, here you have the BM diagram, and the question is complete. Need to be calculated. Okay. So now I'll make the SF table for it. We need only 2 points here, guys, A and B. Yesterday we said if somebody was saying I need C also, you could have taken, but it's not actually required. Okay. So points A and B. Shearing force units will be newtons. I have a point force at A and B, so both need to be divided. To the left of A, it is 0. I carry forward 0. When I shift to right of A, plus 25 comes into picture. It becomes plus 25. I carry forward plus 25. From A to B, the entire weight of 50 newtons comes into picture. It leaves me with minus 25. I carry minus 25. And then I have plus 25 becoming 0. And then I draw the shearing force diagram here. A and B. Then I use the blue marker. Plus 25 minus 25. At A, it goes from 0 to plus 25, then it goes to B at minus 25. Because it's changing at a uniform rate, we already discussed it yesterday. This is a straight line and then becomes 0. This is minus 25. Does everybody agree with the diagram? Yes or no? Okay. Where do you think is it crossing the x-axis, the SF diagram? Where is it crossing the x-axis?
Middle side.
Middle. Give the reason. Middle is correct, but why?
Area above
See.
the x-axis and below the
No.
axis.
No. But I'm just naming these points only for your satisfaction. Let's say this point P, I don't want to confuse with A and B and all that. P and Q are the 2 points. Okay. They are joined by what? A straight line? Yes or no?
Yes, sir.
Correct. What is the value of P? 25 plus 25. What is the value of B? Minus 25. Since both values are same and joined by a straight line, then obviously the 0 will come halfway through. Yes or no?
Yes, sir.
0 will come midway. Yes or no?
Yes, yes.
Because it is joined by a straight line, not because of areas. Areas can be equal. If here then area में तुम्हें क्या करना पड़ेगा? पहली बात तो areas बराबर क्यों है? That is what you have to explain. But what I'm saying is anything which is, let me go on the blast diagram and say, here, suppose this is the base. Suppose this is 100 here, beta, and this is 10 here. Now, obviously, where will it cross? It will cross closer to 10. Yes or no? Hai? If it is minus 10 and plus 100, and I join them, where is it going to cross the x-axis? Closer to 10? Yes or no?
Yes, sir.
Tell me, guys.
Yes, sir.
Yes, sir.
And if I make it this also 100, then it will cross midway. Yes or no?
Yes, sir.
Yes.
Okay. It is because When they are unequal, we'll see them later. Right now, because this, correct, beta?
Yes, sir.
Okay. Okay. Now for BM table, what was the criteria for choice of points? BM table by areas under SF diagram. What was the criteria, beta? I told you to pick up the points. How many points we'll need?
All SF critical points.
Plus
And
point where graph is
And
crossing.
point cutting the x-axis also. All SF critical point and point cutting.
even I heard somebody saying endpoint. Where does this endpoint word come for BM here?
No, sir.
use-
End point. And sir. A and D.
And acha, and okay. So the points. So how many points from this diagram you think need to be taken?
3.
3 points.
3. Okay. Why? Because at C it is crossing the x-axis. Understood now? If in the last time when I made the statement, if somebody had the doubt, now is the doubt cleared? That here you see we took A and B point for SF, but SF diagram is cutting at C also, so C has to be picked up for BM. Correct, beta? Okay. Clear to everybody?
Clear, sir.
Yes.
Okay.
Clear,
What will be the units of BM? Newton meter. Okay. What is the area under the SF diagram to the left of A? 0. I carry the 0 forward. What is the change in area from A to C? It is that positive triangle. Positive triangle will be half base into height. 125 ka adha was what? Plus 67.5. Am I right, guys? Correct? How much it comes to? So much only, no?
Plus
52.5.
52.
62.5.
Okay. Plus 62.5. Fine. Okay, beta. I carry forward the 62.5 here. What is the change in area from C to B? This is how I'm thinking. What I'm telling you is what I'm thinking to myself when solving. It is minus 62.5. It's the same triangle. So becomes 0. Is the BM table clear to everybody?
Yes, sir.
Now we come to the BM diagram. There is no negative thing, so I don't have to have anything on the lower side. I can have it like this. I have A, midway C, and I have B. Here I'll have BM in Newton meter. And I'll mark these points. A is 0. This is plus 62.5. And then becoming 0. So we can have it good at this aram se yahan le lo kahin bhi. Isko yahan matlab yahan rakh lo plus 62.5. So here is at C and here is at B. Is the marking of points clear, beta?
Yes, sir.
Now the question is about joining these points. Okay. Now, what I'm doing is explaining. Okay, so don't think that it's part of the working. No, it's explanation only. Now I am integrating areas under the triangle. If I divide this into equal lengths, is the rate of change uniform? Yes or no? First answer in yes or no.
No, sir.
This area is much more than area A. 1 is more than 2. 2 is more than 3. So the rate is changing. Yes or no as I'm going from base towards the vertex. Correct, beta? Okay. Understood? Or you are integrating areas under a straight slanting line. When you are doing this, the result would be a curve. It will not be a straight line. Result would be a curve. Okay, now I'll give you some tips. Now, a triangle can come in 2 ways. How can it be 2 ways? One is I can have a triangle in which I'm integrating areas like this. Other could be a triangle in which I'm adding the areas integrating like this. This is not a standard vocabulary. The first one, I will call it as base to vertex. You are going from base to vertex in triangle A. Yes or no, beta? Correct, beta? In triangle B, you are going from vertex to base. Correct, beta? Yes or no? Let me open a new page only. Let me, why mess it up here? Let me open a new slide. Yeah, it was here. I don't know why I missed out. It was here. The question was here. I think I missed out somewhere. Right? No, this is a triangle. There can be two situations. One could be like this. If I'm integrating like this, I will call it as that I'm going from base towards vertex. Correct, beta? Correct. B is base to vertex. Correct, beta? Or if the triangle is like this, I'm going from vertex to base. Do you understand the difference in the two cases? In the first case, initially the rate of change will be more. And then as I'm going away towards the vertex, the rate of change is reducing. Yes or no, beta? Here you will have the maximum rate of change in the beginning and you will have the minimum rate of change towards the end. Yes or no, beta? In the first case.
Yes, sir.
In the second case, you will have lesser rate of change in the beginning and you will have the maximum rate of change at the end. Yes or no? Correct? Understood what I'm saying? Understood, beta?
Yes, sir.
When you integrate the areas in such cases, the graph would be like this. For the first case, the graph would be like this. First, the rate of change is more, and then it is reducing as I go towards the vertex. So here is the base, from base to vertex. When I'm integrating, first it's more, then it is reducing, and when it is becoming horizontal, that means it has become now 0. Yes or no? The curve would be like this for, this is from base to vertex. Understood, guys? Understood?
Yes, sir.
When I'm going from vertex to base, initially the rate will be less. Initially the rate would be less. This horizontal part will come in the beginning and then it will pick up the speed. Correct, beta? If this one is from vertex to base. Understood, guys? You see both the diagrams are different. Can you appreciate the difference? Have you understood the concept?
Yes, sir.
Is that clear? This, when you are going from vertex to base, it will be like your GZ curve. It will be first running near to horizontal and then picking up. From base to vertex, it will pick up and then it will taper down. Guys, any questions on what I'm trying to explain? When you are trying to cut short with minimum points, you must use basic common sense, common knowledge. I would not say sense, common knowledge. And this is what is straight out of this discussion. Yes or no? Correct, guys?
So just one thing, we won't complete the curve, right? We'll just leave it halfway, right?
When the triangle ends, the curve will be like this, no?
Correct, yeah.
I'm talking of the curve for the triangle. I'm not drawing the BM diagram here. I'm integrating the area under the triangle, man. With what will you complete this? When the triangle ends here, it ends, yes or no? Correct?
Yes, sir.
Correct, yeah.
Okay. Another property of a triangle, simple property, all of you know. If you have a triangle, with whichever way you take, base to vertex, vertex to base, it will have a certain area. So triangle ABC will have certain area of triangle ABC. Now, if I take the midpoint of the base and I draw a line here, and now I get this triangle AXY. Now, this XY divides the triangle into two portions. Portion 1 and other is a trapezium. Correct, beta? This will always divide the area of the triangle in the ratio of 25% to 75%. That means if the area was A of the full triangle ABC, then area of the small triangle, this area would be 0.25 of A, and area of this trapezium would be 0.7 by taking any example. Why? Because this height will become half, base becomes half, so half into base into height will become 1/4 of the original area. So area of the smaller triangle will be 25%, and the area of the trapezium would be 75% of the area of the whole triangle. Is that clear, beta?
Clear, sir.
Okay, now you see here the same thing. So these small things, if you remember, they will come handy in giving shape to your thing. So what you can sometimes, if you want to do, if you're confident in giving the shape, you can give the shape. Otherwise, if you have any apprehension little bit, and if you know about this property, then you see what happens. In this case, if I take the area at the midpoint, then we are talking of the trapezium, beta. Yes or no? Correct?
Yes, sir.
So I can mark a point midway, and I get another value which will be 75% here. So you see, from my graph also, this value is coming almost 75% of the full. In this case, if I have to mark here, from here, I'll have to mark 25%. You see, this is coming almost 25%. So this is how these shapes get justified. So for vertex to base, it will be first horizontal, then steep rise. In case of base to vertex, it will be first steep and then getting horizontal at the end. Whatever I have said in this, is that clear before I take you to that question and use this knowledge for shaping my BM diagram?
Yes, sir.
Yes, sir.
From A to C, am I integrating between from vertex to base or base to vertex? A to
Base
C.
to vertex. Base to vertex.
Okay.
Base to vertex. That means, let me change the color, otherwise blue and blue will not probably highlight the thing. So it will be first steep and then getting horizontal. I'm intentionally doing it light. Okay. Tell me, from C to B, is it the triangle from C to B, is it vertex to base or base to vertex?
Vertex to base.
Vertex to base.
So it will be mirror image of it. Why? Initially it will be less. Less means like horizontal, and then it will get steep. Or if I do from B to C, the curve will come like this. So it will be a mirror image of it. And this will be my BM diagram for this particular SF diagram. Now you'll say, sir, why did you do it in light? I also want to do the same thing if you have any doubts. That if I want the BM to be marked unofficially at the midpoint between A and C, let us say X. How much will be the area to the left of X? It will be 75% of 62.5, yes or no, beta?
75%.
Correct? To the left of X will be this trapezium, right? Correct?
Correct, sir.
So if I divide the 62.5 on this scale into 4 parts, at the midpoint, you see I'm automatically getting that value by experience. Yes or no? Correct, beta?
Yes, sir.
Yes or no?
सर ये सर थोड़ा प्लीज वापस ये लास्ट पार्ट जो बताया सर.
I asked you what will be the ratio of this area of the trapezium based on our discussion on the last slide.
So 75%
Of what? 75% of what?
Of the total area of the total triangle, sir.
Okay, what is the total area? Look at the table. What is the total area of triangle? This triangle to the left of C.
62.5.
So what will be the area up to X of this trapezium? It will be 70% of 62.5.
Yes, sir.
See, I did not mark this point first. First, I used my concept, and now you see. अगर तुम्हें कोई डाउट हो तो उल्टा भी कर सकते हैं. पहले हम इस पॉइंट को रफली मार्क कर दें, अपने आप शेप ऐसा हो जाएगा. यस और नो? करेक्ट बेटा?
Clear, sir.
Okay, and the other side will be the mirror image of it, and we give it like this. This becomes my BM diagram for this question. So beam, SF, BM, it gets completed in a very short span of time. is supported at the point 2 meters from end A and at a point 4 meters from end B. It carries a point load of 13 kg at its mid length. Draw the SF and BM diagrams of the beam and state their values at 2.55 meter from end B. It's January 2022. Now, all of you to make the diagram of the beam and stop and put all the possible values that you can put on the diagram, which need not calculated. Whatever is given in the question, load your diagram with the given values, guys. Can you please do that? One step at a time. This will be a test of how much have you absorbed over the last 2 days until this point. I think I was very clear yesterday that in this case we'll use directly in kgs, yes or no? Correct, beta?
Correct, sir.
We'll use in kg, right? Am I right if I say that I have to divide only 3 of them? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Then please fill up the values.
A 0, sir. Minus 14. Minus 14 plus 50. Plus 36. Minus 42.
-6 आएगा सर.
Yeah, कर दिया बेटा, I've done already.
Yes sir.
Minus 13.
-30. -19.
Minus 19.
-19.
Minus
-28.
28. 47.
-47.
Minus
So
47.
plus 75. 28.
28.
-28 -28.
बंदा आ गया एसी चेक करने आएगा किसी भी टाइम को, अगर एक वाले एसी अभी ठीक करो ठीक करेगा
तो भाई तू एसी वाले से ठीक करा ले, यहाँ पे तो ट्यूशन पढ़ ले तू. Okay, म्यूट कर लिया अगर. Okay. Is the sharing force table? Anybody has any problems with the sharing force table?
No, sir.
Simple, guys.
Yes, sir.
So let's now make the sharing force diagram. And again, I'll mark the points and I'll wait for people to make it. So look at the scale. I have minus 19, minus 47, and I have plus 36. So I have on both the sides of the x-axis. I have A, then 2 meters from A, I have X. Sorry, this is X. 2 meters. Then I have C. This is 6 meters. Then I have Y, which is 4 meters. And then I have B, which is another 4 meters. Okay. Now, you please draw the shearing force diagram, guys, whichever way you think appropriate. Plus 50, that's it. 10, 20, 30, 40, 50. 20, 40. Okay. I'm not speaking intentionally, guys, because I want you to make sense out of it. All are straight lines, so don't worry about little bit of by hand deviations that you're seeing. All are straight lines. Is this what you have drawn?
Yes, sir.
If done, then 50% of your question is over. That means shearing force, up to shearing force, the question is done. Anybody who is struggling in getting the SF diagram now? Don't copy it from the board. That has to be used for self-assessment and self-evaluation better. My diagram should be used for evaluating your own work that you have done, rather than just copying it. It will not serve any purpose. Anybody in the class has any doubts now? Or somebody is still doing? Somebody wants me to wait further?
So please wait for 2 minutes.
Yeah, so please let me know once you're done, beta. So speak up, no issues. Do it. Do it. Don't worry. I'll wait for you, beta. Once you're done, do it, complete it, let me know. Then only I'll start my discussion.
Done, sir.
Anybody else in the class who is still doing and wants me to wait further? Or if anybody has now doubts, please let me know. What is the change in SF? SF has changed from plus 36 to minus 6. What is the change in the SF?
30 minus 42.
It's
42.
42 units of change, right? 42 units
Yes,
of
sir,
change,
42.
correct? So for 42 units of change, you have gone over a distance of 6 meters from X to C, correct, beta? X to C over for a change of 30 plus 36 to minus 6, that is 42 units. You took a distance of 6. Why? Because it's a straight line thing. That's why we are using unitary method. To change 1 unit, you will need 6 by 42. Correct, beta?
Yes, sir.
And to make 36 to 0, how much you need to change? 36? Correct? So for a change of 36, this will be into 36. How many meters it comes to? Up to 3 decimal places?
5.143.
So you're saying XZ is equal to 5.143 meters. Is that what you're saying, beta?
Yes, sir.
Now from the graph, nobody can ever read 5.143. You agree with me?
Correct.
Yes.
From graph, it is coming 5.34, sir.
That can come anything. Now that depends on your pencil. Tip of the pencil also will count. Yes or no, beta?
Yes, yes.
That's what I'm saying. So in such simple cases, you can calculate exactly. You don't change the graph. You just calculate them by unitary method. And if X to C is 6 meters, X to Z is 5.143, then Z C is how much, beta? 6 में से minus कर दो. 0.8857, is it?
857.
Okay, 0.857 is ZC then. Through this, what will happen is then my DM at B will become 0. If you take it 5.3 as somebody was saying, then ZC will become 0.7. Then areas, the BM will not become 0 at the end. Why it will not happen? Because of the error in taking this point where it is crossing the x-axis. So you'll know why the error is coming, correct? There may be some complex situations in which we'll make adjustments, but in such simple cases, it does not warrant any adjustment. You can calculate and exactly move with the things. Is that okay, beta? Have you understood what I'm saying here?
Yes, sir.
Okay, now having got to these distances, can you please fill up the values of the BM? You already know, I've already told you how to fill up the BM values. So please fill up the value of BM. And just imagine, had you taken 5.3 or 5.2 or 5.8, whatever you're getting from the graph, then you can understand what sort of difference will show up towards the end. Anybody has any problems with the BM table, please complete the BM table before we go to the BM diagram.
Sir,
Yeah.
sir, in case we forget this trapezium parabola, we can divide by rectangle and triangle, sir. We can do that.
You can do, but it will keep. You're trying to cut short. Why you want? What is there to remember? Half the sum of the parallel sides multiplied by the height here, by the perpendicular distance between them. Right? You can do whatever you want, but what, are you trying to save time? Yes or no? You're right. You can do it by sum of triangle and rectangle. It will give you the same answer. Why not, beta? Okay. Is that okay? Yes, you can divide them into triangle and you can do that way. If you've done that way, it's fine as long as you're not wasting time.
Okay, sir.
Okay, fine. Guys, anybody still doing the BM table? Or if it's done, let me know. Okay, let me draw it here then. This border is red, so I can take the blue white here a little better. Okay, guys. Minus 55. Okay. I'll just ratio down below. We have A. Then 2 meters from A, we have X. Then 6 meters from X, we have C. So, yes, 6 meters from X. Yeah, we have C. Then 4 meters from C, we have we have Y. And then 4 meters from Y, we have the end B. Between C and X, we have somewhere here, we have our Z. Okay. Now I mark these values. I want up to 80 on the plus side. So if this is 80 here, then it will be 40 here, 60, 20, 10, 30, and this is 80. Okay. With the same calibration, if I go up to 60, 10, 20, 30, 40, 50, 60. Here will be my BM in kg meter. I'm speaking aloud so that all of you can make sense out of it. This is plus 40. This is minus 10, minus 20, minus 30, minus 40, minus 50, minus 60. This is plus 10, plus 20, plus 30, plus 50, plus 60, plus 70. Okay. Now we mark these points. At A, it is 0. At X, it is minus 14. So minus 14 would be somewhere here. At Z, it is plus 78. So much here. Then it is plus 76 at C, so slightly less than that. Then minus 55 would be here at Y. And it's 0 at B. Please see, do you agree with the marking of the points or there is any confusion? Done, guys?
Yes, sir.
Okay. We'll join them. Tell me from, look at the SF diagram. It's here. SF diagram is here, guys. Here. This one. From A to X, is the triangle from base to vertex or vertex to base? When you're going from A to X.
Vertex to base.
So it will be like this, little horizontal and then like this. Correct, guys?
Yes, sir.
Okay. The other triangle from X to Z, is it base to vertex, vertex to base?
Base to vertex.
Base to
vertex.
So it will get horizontal towards that side and it will go like this.
सही बना रहे हैं.
The shorter triangle is insignificant. You can just join them, though it is base to vertex to base, but it's okay. The distance is so less, it doesn't make a difference. Now we come to this part of the trapezium. As somebody was saying, for area, can I treat it as a rectangle and a triangle? Yes. For giving the shape, only a hint that again, in case of a trapezium, there is one smaller side, one bigger side. If you were to divide into a rectangle and a triangle, the triangle would have been from vertex to base in this case. Yes or no? Correct, Beta?
Yes, sir.
So the curvature will depend on the triangular part, because otherwise it would have been a straight line. So now we can treat it as if we are integrating from vertex to base. Okay. And so it will be first, the rate will be lesser and it will be maximum as we reach here. Something like this, it will be the curve. It is more towards Y, you can see the steepness, and it is less out here. Yes or no, Beta? Do you agree?
Yes, sir.
Okay. And the last rectangle triangle is from base to vertex. It's base to vertex, so it will be horizontal towards the vertex and it will be like this. Have you got the diagram correct? Yes or no? More or less.
So trapezium we did with assuming vertex to base, right? And the last one was base to vertex.
The last one is a triangle. Last one, I don't have to say anything. I said trapezium also, you can more or less be guided. It's only a hint, not that it will fit in perfectly. But when you are going from smaller side to bigger side, it's like going from vertex to base, right? Because if you try divide into two parts, one rectangle, other triangle, then the triangular part in this case is from vertex to base. Yes or no? Yes or no? Correct, guys?
Yes.
Okay. Now there is no point in MMD exam spending more than this time on this time that you have spent on the BM diagram. Why? Because if you spend more time on it, it's not going to add any value to your marks. You'll in fact be eating time from the other questions then. And this is the BM diagram, which is reasonably acceptable for the exam for this particular question, which is from MMD. Guys, before we go to the last part of it, the values at 2.55 meters from end B, we can talk about it in a while from now. But is all the steps of this question are clear to everybody?
Yes, sir.
Now we come to the issue of the BM and SF values 2.55 meters from each end. Okay. Now, whatever I have told you all this while, that should be good enough to guide you through. See, look here. first and foremost. Here is the SF diagram. Where does he want the value? He wants it here. At what distance? 2.55 meters from end B. Yes or no?
Yes, sir.
That means this value is the value he's looking for SF. Correct, beta?
Correct.
Does everybody agree? Sharing
sir.
force
Yes,
at
sir.
2.55 meters is basically what blue I have. Let me take it into that. He's talking of this value on this line, right, beta? Correct?
Yes, sir.
Now, if you do not have time, then you can say from the SF diagram, shearing force at 2.55 meters from end B is whatever you can read off from here, plus so much is the value of the SF. But in such simple cases, you can get a better value by unitary method. What is the shearing force at Y, beta? What is the shearing force at Y? Look at the diagram only.
28.
28, sir.
Plus 28. What is the
28.
what is the shearing force at B?
0, sir.
0.
And it has changed from plus 28 to B over 4 meters of length.
4 meters, sir. Yes, sir.
You want it at a distance of either you can say this much or 2.55 from here. Doesn't make a difference. So we can get for 2.55 straight. Okay. So what I'm saying is, beta, from 0 to 28, it has changed over 4 meters. So over 4 meters, it has changed to 28 units, right? Correct?
Yes, sir.
Over 1 meter, it will change by this much, correct? Why? Because of the weight of the beam, 7 kg per meter is what you're getting here, okay? We want it for 2.55 from end B into 2.55. This will be the plus, this much value will be the SF at 2.55 meters from end B. How much it comes to?
17.85 kg.
17.85 kg is the SF at this point. Now, obviously, when you will read from here with such a small scale, you see my graph is not too much out. It is showing about 16, 17, 18. But obviously, there will be restrictions of the scale, which will not give you value something like 17.85. Yes or no? Correct, beta?
Correct, sir.
Correct.
Agreed?
Yes.
Agreed.
What will be the value? Will it be positive 2.55 meters from end B or negative?
Negative.
Negative. Okay. So some time back, somebody asked me, he was integrating the area under the SF curve from right to left. You remember some discussion came up in the class when I said, why you want to do it from there? You remember? Correct? Do you agree with me at this point, area under the SF diagram, this will be the value of bending moment at this point, yes or no? What is bending moment? It is area under the SF curve to one side of the point, right? So one way is,
yes, sir.
I take all these areas to the left of it, which are plenty of areas to deal with. Correct. The other way of quickly getting in this particular question is I calculate this area, yes or no?
Yes, sir.
Yes. And in this value is already calculated. This is 17.85. You have already got the shearing force height of this triangle. 85, correct? So now, you see, when we are going from left to right, the bending moment is the whatever shearing force is above the x-axis, that is plus bending moment. Now we have gone from right to left. So this will be negative value. And you can see in this diagram also, this is negative beta. Correct, beta? Correct?
Correct, sir.
So what will be the precise bending moment? Precise bending moment will be half of this triangle. It will be minus half. Why minus? Because we have gone from right to left. Half into base of 2.55 into height of 17.85. This will be the BM at 2.55 meters from B. It is minus how much coming, beta?
22.75.
Sorry?
22.758.
22.758.
758 kg meter.
758.
Oh, kg meter. Okay. Let's see from
Yes.
my graph, what did I get? You see, it's coming about 20.
Yes, sir. 22.
Correct. Yeah, whatever it is coming, 20, around 20. You see, if you don't shape it properly, see now you'll understand the significance of the shaping. Because if I had drawn it like this, then the value here would be something altogether different. Correct, beta?
Correct.
Then the value here would be this much. So the shaping is important of the curve. But in such simple case, it could have been precisely calculated. One is you can calculate the area, but make sure you give it the correct sign. You can't give it plus sign. Why? Because in the BM diagram, the BM here is negative, and this would also be negative because you've gone from left to right. Right to left, sorry, you've gone from right to left. Correct, beta? Yes or no?
Yes.
So the answer to this question would be SF at 2.55 meters from end B would be plus 17.585 kg, and BM would be minus 22.758 kg meter. That will be the precise answer. But as I've been repeatedly saying, if you have problems with all this detailed understanding, BM question that some of you may have attempted, has somebody done it or you're yet to do it? Let's not answer the questions. I said, what is then holding 300 kgs? Effectively, the beam itself is now, as far as ground is concerned, the beam has a weight of 900 newtons, force of 900 newtons, right?
Yes, sir.
Then where is the confusion? That's why I'm taking up these questions so that you don't have. I hope others have taken 900, or was that the general confusion, guys?
900.
No, sir. No, sir.
Okay.
900.
Okay, so then, and I'm sure three points you would have done would be sufficient, right?
Yes, sir.
Yes, sir.
3 points.
So SF would be in newtons. We can take 3 points. They will be A, C, and B. C would be divided into 2.
Divided
At
2.
at A it is 0. To the left of C would be 5 meters of weight and 5 meters of reaction. So 5 into 30, 60, sorry. 5 into 60 is 300 will be minus, and 90 into
90 into 5, sir.
450 will be plus. So it will be plus 150. Am I right,
Yes,
guys?
Yes, sir. Plus 1.
Then
Yes, sir.
plus 150 minus 300 will be
300.
minus 150.
Minus 150.
Minus 150 plus 150 will become 0. If it is not becoming 0, let me know. Correct, guys? Correct?
Yes, sir. Correct, sir.
Okay. Now the shearing force diagram would be like
So how
this.
about plus 150?
You tell me how what did you get? What did you do yesterday? You tell me what have you done better?
Sir, I did the same thing. Minus 300 plus 150. So plus 440.
Sorry, minus 300
Yes,
plus.
sir. 300 plus 450.
So that's
So
right.
what, that is where? That is at which point?
At point
At
B.
B, sir.
Haji?
At point B, sir.
At B.
Hmm.
First you
Yes, sir. We carry forward minus 150.
Yeah, and then from C to B, what are the changes? From right of C to the B.
Yes, sir. Minus 300. That is weight is acting downward.
And plus.
Uniformly.
And plus
And plus
450 of. So what is
sir.
the result?
Yes,
What
sir.
is the resultant of 300 minus and 450 plus?
Plus
Why is it not becoming 0 in your case? Tell me, guys.
No,
if it is not.
No.
becoming
It is
0,
becoming
sir.
0, sir. You took
So
plus
then
150
matter ends. Then matter ends, na man. If it is 0 now, after so much of practice and so many days of discussion, I have just written the change here, right? Resultant change.
Yes, sir.
Okay, never mind. At A it is 0. At C first it goes to plus 150 with a straight line, comes to minus 150, and with a straight line goes here. Is this the SF diagram everybody has got?
Yes, sir.
Yes, sir.
PM would be good again with 3 points. By areas under, you can keep writing. I'm not writing complete. I don't want to spend too much of time on it. BM will be now Newton meter. You have 3 points, A, C, and B at 0. It's plus half into base will be, now it was 10 meters, so 5 into 150, 75 into 5, 375 if I'm not mistaken, plus 375 minus 375, 0. The BM diagram will be all plus. So I'll have A, I'll have B, I'll have C, sorry, in the middle, and I'll have B here. Here it is plus 375. I'm integrating from vertex to base. So the diagram would be like this. Something like this, a bell type. Something like
Yes,
this.
sir.
This is the BM diagram. I hope the class by and large is comfortable with. Why I've rushed through with the explanation is, if you're having problem in now understanding what I'm saying, then you need to again look into where are you getting stuck. I don't want to invest at my graph. It will be like this and like this. My mistake. In a hurry, I just made it like this. Okay. It will be a sharp point here, right?
Sharp point. Yes.
Yeah. Okay. If that was the doubt, then you're right. Okay, beta. B. The diagram is going to be like this, somewhat like this. That was your doubt, is it?
Yes, sir. So that's what I was confused.
Okay. Fine.
Can you
No.
explain one
Good. You raised it. Good. You raised it. Okay. Load of 15 kg is a 0.6 meters from end A. So this is how many meters? 16. So this is 8. Somewhere here at 5 meters. You have a weight of 15 kg at a distance of 5 meters from here. Okay. Draw the SFBM diagram for the beam. Sorry, 6 meters. Okay, let's make it 6 meters. Okay. Where is the beam supported? Supported at 2 meters from each end. Okay. If this is 6, 1/3 of it will be one support is here. 2 meters. Other support is somewhere here. 2 meters. Firstly, is the diagram correct, guys? Those of you who have made it. Obviously, first we'll have to name the reaction points, because reaction points are not already named. Maybe I can call them whatever you want to call them. I can call them X, Y, or whatever you want to call them. It's okay. Don't change that. So now, if you take the reactions, has everybody calculated what is the reaction at the left support?
85.
Sir, RX
Sorry?
is 90.
90.
Okay.
90.5 is 85.
85. Okay. Anybody getting different from this? Then we can check. If you are not getting different, then why waste time? Or if anybody has any doubts now on the reaction part. Quickly, I'll have these 4 points to be taken, A, X, Y, B, and also the point where the weight is put. So maybe I can call it Z or C or whatever you want to call it. So I'll have 5 points at which the SF table has to be made. If anybody has made less than 5, if you have taken more than 5, no offenses. But if you've taken less than 5, then serious concerns. Here the SF will be in kg, 1, 2, 3, 4, and 5. At A, we do not have a point load. At X, so A, then we have X, then we have Z, then we have Y, then we have B. At middle 3 points, we have point loads. At A, it is 0. I carry over 0. Up to left of X will be 2 meters of weight downwards, so minus 20. So it will be minus 20. I carry forward minus 20 plus 90 becomes plus 70. I carry plus 70. Then I have 6 meters, 4 meters of weight minus 40 plus 30 plus 30 minus 15 plus 15 plus 15. Then I have this was how much? 6 and 2, 8. 8 meters of weight minus 80 minus 65 minus 65 plus 85 plus 20 plus 20 minus 20 0. Are these correct values, guys? Everybody made of straight lines, guys? Yes or no? Or
Yes,
any
sir.
goof up?
Yes, sir.
Very good. Very good. Very good. Very good. Very good. So basically, this is my shearing force diagram. The blue one, right, guys? Anybody in the class? I'm sure this point will be an additional point. Let me call it as P, because I've already used X, Y, Z. So guys, I'll have to calculate ZP and I'll have to calculate PY. Yes or no? Correct?
Yes, sir.
Yes.
So has anybody calculated what is ZP or PY, whatever? This is my plus
ZP
30 plus
ZP 1.5, PY 6.5.
ZP is how much beta?
1.5.
1.5 and 6.5. Anybody who needs help, all set to make the BM table with one more additional point. Please do not forget to write BM table by areas under SF diagram. Okay, we have followed by Z, then followed by P, then Y, and lastly B. The units of BM will be kg meter, guys. At A, it is 0. At X, it is minus 20, area of negative triangle, correct? I carry forward this minus 20, then area of this trapezium will be 30 plus 70, 100, 50, 50 into 4, 200, plus 200, so plus 180, plus 180 minus, plus only half into base is 1.5 into height is 7.5 into this 1.5. How much it comes to?
11.2.
11.25. Okay, that makes it plus 191.25. 190. Yeah, plus 191.25 minus half. Then 6.5 into 65. How much it comes to minus me?
Minus 220.
1.25 minus
21.25.
211.25, is it?
Yes, sir.
Okay. So how much it comes to? Minus 20. Okay.
Minus
Then minus 20 plus 20 becomes 0. Anybody are all plus plus. There is one small minus coming in. So little bit will keep below it. Okay. So I have A. Under X, I have X. Under Z, I have Z. Under P, I have P. Under Y, I have Y. And under B, I have B. I've been speaking very loudly so that all of you know. My spacing doesn't seem to let me bring B this side because A to X and Y to B is the same distance. It's 0 here. It's minus 20 here. Then it's plus 180 here. Of course, you'll be doing with the to a scale beta. Then plus 191. Let me change the color of the pen to green or something. Left in your working. Then minus 20 is at B, Y. And it's 0 here. Okay. From A to X, it's base to vertex to base. So it will be like this. Then it is from bigger to smaller one. So it will be steep first and then getting slower. Okay. Then it goes from, this is small distance, doesn't make a difference. Then it is vertex to base. So first it will be horizontal and it will get steeper towards Y. So something like this. And then it is base to vertex. Like this. Correct, guys?
Yes, sir.
Okay. Now, if you are not short of time, then it has to be calculated. Now, how will I calculate? Guys, tell me, what is the bending moment at P? It's 191.25, correct, beta?
Yes, sir.
Correct, guys?
Correct, sir.
Okay. That means this area plus this area plus this area is all totaling to plus 191.25. Yes or no?
Correct, sir.
Yes, sir. Similarly,
That's what it means. BM at P is 191.25. Does everybody agree?
Yes, yes. Okay, got it.
Okay. Now, if the BM at point Y has to become 0, at this point, not Y, this point, whatever this point you can call it. If it has to become 0 here, then that means that 191 plus should be offset by this green negative area, correct, beta?
Correct, sir.
Correct. So what I can quickly do is I can find out at what distance does this area become 0. But this will be involve a quadratic equation. How? Let us say this distance is x meters. From where? From P. Okay. Now you see, from P to Y, what is the change in the height? 65 units, correct, beta?
Yes, sir.
Correct. And what is the distance from P to Y? 6.5 meters. Correct, beta? Yes or no?
Yes, sir.
I am saying distance from P to Y is 6.5 meters. And the change in the shearing force from P, where it was 0, to this point Y, it is 65 units. Correct, beta? So what do I want to find out? I want to find out the value of shearing force at this point by unitary method. How will I find out? Over 6.5 meters, the shearing force has changed by 65 units. Over 1 meter, it will change by this much. And what is the distance I have covered from P? I have covered x meters. Over this much distance, it will change by so many meters, right? And this comes to 10x. Yes or no, beta? Correct, bacho? Yes or
Yes,
no?
sir.
Yes,
So
sir.
this height is 10x. Area of the green triangle whose base is x, height is 10x, should be equal to 191.25, and I'll get the value of x. So what will be the area of the triangle? It will be half, base is x, height is 10x, and how much should it be for it to become 0? 191.25. So this becomes 5x square is equal to 191.25. You can get x square first by dividing by 5 and then take square root of that and give me what is the value of x you are getting, beta.
$6.185.
6.185, which you'll never be able to read from your graph. Okay. So from end B or from end A if you want, from end A the distance will be how much? It will be 2 meters plus 4 meters, 6 meters, 6 meters plus 1.5, 7.5, 7.5 plus 6.185. This will be the distance at which it is becoming 0. Now you see, if I'm trying to read from here, from the graph that I have drawn, there also if you see, if this much distance was 6.5 meters, then I'm sure this distance looks like about 6 meters or so. But naturally, there'll be plotting errors and reading errors. You cannot read as accurately as 6.185. But in such simple cases, it is safer to calculate and give the answer. It is safer to calculate and give the answer. Is the last part of the question clear to everybody? You can give the distance from end A or you can give the distance from end B. Okay, beta? Clear, guys? Is 191.25, so the green should also be 191.25. We are finding x, the distance from point P, where the negative area will become 191.25. That's what our objective of the calculation was. Now you can take it down and you can ask me if there is any doubt. Beta. L and weight W per unit length. It was one part of it. It was not a full question, beta. But anyway, that's not the important part. Important thing is it's from MMD exams. A beam of weight length L and weight W per unit length. So there is a uniform cross section beam. AB, length is L, and weight would be equal to W into L. Why? At the rate of W. He's not given. He's not given us the units. So W units per meter, right, guys? Per unit length. He's not given the units of length also. He's not given a unit of length. He's not given the unit of weight. Now it's okay. So now supported at its two ends. I'm sure all of you would agree with me that RA and RB will be equal and half of each other, half of total downward weight. So this will be WL by 2 and this will be WL by 2. Does everybody agree with the reactions?
Yes, sir.
Okay. So the shearing force diagram would be like this. A, B, take any scale and mark plus WL by 2 and mark any scale with minus WL by 2. If it is coming, I don't know, any RA. At A, it goes from 0 to plus. So let me change to blue. At A, it goes from 0 to plus WL by 2. Then at B, it goes from minus WL by 2 to 0. And these two free ends will be joined by a straight line. Why? Because it is changing at a uniform rate. And this will be the center of the beam. Does everybody agree?
Yes, sir.
This blue one is the SF diagram for, you can make the SF table and make the SF diagram. This will be the SF diagram. If anybody has any problems, you can let me know. So if you want to make the BM table, you can make the BM table, no issues. You'll have to, of course, make. I'm just trying to cut short. BM table by areas under the shearing force diagram. We'll have to take minimum 3 points. One, there'll be A. I've already told you what cantilever is. The SF diagram of a cantilever is not a concern. You can't just follow what you have learned. Okay. Be careful when it comes to the BM diagram. The cantilever BM diagram would be, the BM would be 0 at its free end. You see, the cantilever is supported at one end. I'm talking about normal cantilever. The April 21 is pretty altogether different. Supported somewhere 2 meters from the end. That's anyway. What I'm talking about is a fixed end and a free end. That is actually pure cantilever, honestly speaking. Okay. So there is a fixed end which is fixed in the wall or something, and there is an end which is hanging, which is free. So that's how we call them as free end and the fixed end. SF, no problems. Draw the way you've learned. There's absolutely no issue. The problem starts with the BM sometimes. Okay. So please remember that the bending moment of a cantilever would be 0 at its free end. If you remember this and then keep the sign convention in mind, then you are done with the BM also. So would you be able to recall that for a cantilever, the BM would be 0 at the free end and the maximum bending moment will be at the support. Why? Because it's trying to bend directly from that point. You see, when you have to bend a pipe, what do? You put it somewhere, you have formed the cantilever, you have just taken the support at one end of that point, and then you bend it. Why? Because you get the maximum bending moment at the point where it is supported. Yes or no? Correct, beta?
Yes, sir.
Correct. So the maximum bending moment for a cantilever would be at the support end, and minimum bending moment would be at the free end. Is that clear? Okay. Now I'll just take this, what he has made. Don't worry about the diagram which is on display. I've taken it for the question for the purpose of explanation. And these are from the normal engineering college naval, these book, this is a normal cantilever, and this SFBM is normal college, engineering college stuff, you know. He's given a cantilever in which the left end is supported. So I'm making this cantilever. This is the cantilever diagram. Left end is supported end. It's a light beam. Okay. It has 30 newtons at free end. Then, okay, he's taken, let me take these distances only, no problem. At 0.6 meters from, so the total length is, has he given the total length? Is not given, is it? Just see, it is 6 meters to
6
NDE.
meters.
Okay, it must be in the question, 10 meters or something must be there then.
6 meters.
Because, yeah, so no, 6 meters is up to point E, beta.
No,
and
sir.
length,
No,
Yeah.
total.
Then you have point B. Let me take the same points. Then you have at point C, you have 70 newtons, and this distance is 0.6 meters. So let me mark the distances here. Okay. Then you have point D, at which you have C, D, 40 Newton, kilonewton. Newton doesn't make a difference. Okay, let me just, I'm marking Newton, never mind. 1.5 meters from here. And then you have 60 Newton somewhere here at point E, at a distance of, don't worry about kilonewton, Newton things, shape will remain the same, 2.4 meters. And this distance is 6 meters, right? Okay. Okay, this is end A. So we have points from left, A, E, D, C, B. Okay, beta. What is the total force, downward force on the beam? It's 30 plus 70, 100, 100 plus 40, 140 plus 60, 200 newtons or kilonewtons, whatever it is the total force on the beam, yes or no?
Yes, sir.
Correct. So the reaction will be equal to 200 newtons, yes or no, beta? Does everybody agree with the reaction part?
So this is which question number we are doing?
The one we are not doing any newtons, yes or no?
Yes, sir.
And where is this reaction going to act? This is going to act at point of support, that is A. Right? Correct, beta?
Correct, sir.
Okay. Now, as far as the SF diagram is concerned, you continue following what you have learned for a beam. For a SF diagram, there is no change in the scheme of things. If you see this diagram, there are 1, 2, 3, 4, 5 points, I'm sure. Would you like to make from left to right the SF diagram bit of by yourself? SF table rather. Please make the SF table. SF would be newtons. 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. So A, E, D, C, and B. May I request everyone to fill up these values? This is the question we are doing. Somebody wanted to know which question, this one. He is given in kilonewtons. I have by mistake taken newtons. It's okay. So are all forces point forces? Yes or no, guys?
Yes, sir.
So that means all the cells will have to be divided.
Yes, sir.
To the left of A would be 0. Am I right?
Yes, sir.
To the right of A would be plus 200.
Plus 200.
We carry forward plus 200. Up to E, there is no change. Left of
0.
E, so it will remain plus 200. Then we bring plus 200. Minus 60 will be plus 140. Then we have plus 140. No change up to D. So
0,
remain
1,
plus 140. Then plus 140. Minus 40. Plus 100. Plus 100. 0. Plus 100. Plus 100. Minus 70. Plus 30. Plus 30. 0. Plus 30. Plus 30. Minus 30. 0. Does everybody agree?
Agreed, sir.
Everybody to have a look at it, and especially somebody who asked me the question number, are you okay with the SF table? Distance from A, the distance from A would be how much? 2.4 minus 6, 3.6. So at a distance of 3.6, you will have point E, and from 2.4 minus 1.5, another 0.9. At a 0.9 distance from here, you will have D, and then 0.6 you will have 1.5 minus 0.6, again 0.9. 0.9 you'll have C, and you will have B at 0.6. Okay, let me have the green line for drawing the BM diagram beta. You can ask me if there's any doubt. At A, it changes from 0 to plus 200. Then it remains plus 200 up to E. Then it reduces to plus 140. Then it remains plus 142 D. Then it reduces to plus 100. Remains plus 100 to C. There it reduces to plus 30. Reduces plus 30 up to B and becomes 0. Do you agree green is the shearing force diagram, everybody in the class? Yes or no? Okay, now if we follow what we learned, then what will happen? If I go from right to left to right, unfortunately this becomes, I'm going from fixed end to free end. Yes or no? Correct, beta? Correct?
Yes, sir.
So what will happen? Then what you have learned as per that, the bending moment becomes 0 at the fixed end. And it will become maximum at the free end. Yes or no?
आपने उल्टा बोला था ना सर,
सर
फ्री एंड
उल्टा
पे
बोला
0 है.
I'm saying if we follow what we have learned, also pay attention to the previous sentence.
Yes, sir. Yes, sir.
If we follow what we have learned about a beam, then as per that, you will have 0 at the fixed end and maximum, 0 at the fixed end and maximum at the free end. That is what will happen. That's what I'm saying. Yes or no?
Agreed, sir.
So that means for BM, you will have to be careful. That's what I'm trying to hammer home. Like SF, I told you, please follow what we have learned. No problems. Understood, guys?
Yes, sir.
Understood? Okay, fine. Now you see, beta, why the BM at the free end is 0. First, let's calculate it, satisfy ourselves. If I calculate the bending moment at B, and I have one more force reaction of 100, 200 newtons upwards here, right? So at B, to the left of B, we have 1, 2, 3, 4 forces. This force will cause clockwise moment. This force will cause these two will cause anti-clockwise about B. This will also cause anti-clockwise, and this will cause clockwise. Okay. Now, what will happen about B? What will be the moment of this one? At B, this moment will be 0. Is it correct? 6 bar or so. So this will not work with from free fixed to free. You'll have to go from free to fixed. So remember that. Okay. Now, if I go from free to fixed, now to the right of B, is there, and now I'm making BM table first by our shear calculations. And in BM table, I'm talking of point B to the left of it and right of it. Then I'm going to talk about point C. Then I'm going to talk about point D. And then I'm going to talk about point E and lastly about A. Guys, to the left of B, dusri baat. Now, since we are going in this diagram from free to fixed, are we going from left to right or right to left?
Right to left.
Right to left.
Right to left. Okay. So sign convention for bending moment from left to right was clockwise was positive, anti-clockwise was negative. But we are not going this. We are coming from right to left. And if we are coming from right to left, then clockwise will become negative and anti-clockwise will become positive. Correct, beta? So we will be following this sign convention now. Correct, beta?
Yes, sir.
Right? To the left of B, to the right of B, sorry, to the right of B, is there any force?
No.
What will be the bending moment to the right of B? 0?
0.
Okay. Now, or at B, it will be 0 basically, because to the right of B, the distance will slowly keep increasing. Okay, so for BM, there is no need to divide into 2 because shearing forces to be divided into 2. Fine. What will be the bending moment at C? How many forces are to the right of C?
1.
1. About C, is it causing clockwise movement or anti-clockwise movement? See this one.
Anti-clockwise.
Clockwise movement. Is the clockwise movement positive or negative as per the sign? Yes or no?
Negative.
Negative, sir.
Negative.
So it will be minus 70 into 0.6, which will be minus 42. Yes or no, beta? Correct. At C, the bending moment would be, let me just clear it once again. Let me remove all the arrows. Okay, let me come here again now. Okay. Now, firstly, from right to left, I'll write only what is relevant now. Right to left, sign convention is clockwise is negative and anti-clockwise is positive. Does everybody agree in continuation to our earlier discussion? Yes or no? Correct, beta?
Yes, sir.
Correct, sir.
Agree, sir.
Why we are taking right to left? Because we want to go from free end to fixed end. Okay. The first point in our diagram on the is the free end, that is point B. At point B, PM is 0. Everybody agrees. Now we go to point C. To the right of point C, there is only one force. And if I take the moment of forces to the right of C, then the moment will be clockwise. And first it will be, I write the value 30 into 0.6, which is the 30 into 0.6, that will be equal to 1.8. Is it correct, beta?
18, sir. 18.
18? Okay, 18. It will be 18. Second thing is, about C, you agree it is clockwise. And if you look at the sign convention, when it is clockwise, it should be negative. So at C, the value becomes minus 18 Newton meter. Does everybody agree, beta?
Yes, sir.
Okay. Guys, calculation at C is clear to everybody? Yes or no?
Yes, sir. Yes, sir.
At D, if I take the moments of the forces to the right of it, I have two forces, these two. Both are clockwise. If both are clockwise, they will be added, and clockwise are negative, so it will be negative and negative. As far as 30 newtons is concerned, it will be 30 into 1.5. Okay. And the other one will be 70 minus 70 into 0.9. Correct, beta? This will be equal to 45 minus 63 will be minus 108 Newton meter. Does everybody agree about calculations at D?
Yes, sir.
Okay. Then I'll tell you the shorter way also. I'll tell you the shorter way, but I'm just trying to explain it to you. What will be the bending moment at E? There are three forces. This one also comes into force. All are clockwise. If all are clockwise, then we will have basically everything negative. So minus 30 into 2.4 is the distance. Minus 70 into 0.9 and 0.9, 0.8, 1.8.
0.8.
Minus 40 into 0.9. How much it comes to, beta? Can you total it up and give me? Minus. Now all of them are all of them are clockwise, and all will be negative. So it will be minus 30 into 6 minus 70 into 5.4 into 40 into 1.6 minus कर देंगे तो it will be 4.4. No, 1.5, 4.5, sorry, my mistake, 4.5 into, sorry, minus, this is also minus, not plus, this minus, this is minus 60 into 6 minus, how much is left, beta? 2.4.
3.6.
3.6. 3.6, okay. How much it comes to total minus, how much, beta?
954.
954 minus You see all these values match with the BM diagram here. They are all negative. One is supported on the left end like this. And I have, let us say, this is 30 newtons. And let's say there is at the mid length, we have 20 newtons. And this is end A, this is end B. And let's say this is center. Let us say this is 5 meters and 5 meters. We draw the same cantilever with support on the right side. And I have the same cantilever drawn here with 30 newtons at free end and 20 newtons here, with this being 5 and this being 5. Guys, both the cantilevers are same. Only thing is the direction in which the free end is different. Yes or no? Correct, beta?
Correct, sir.
Correct.
Okay, rest everything is same. Okay. Now, if the question does not say which side should you have the fixed end or the free end, then I can draw it whether I draw the diagram to the left or I draw to the right. Is the question still the same? Yes, but their SFBM diagrams would slightly change. Now, first I will do the one to the right, which you are all familiar with. This case. Okay. Let me call these points as they are. Fixed end is A, middle is C, free end is B. Now I'm sure all of you would agree that reaction at A would be upwards and would be equal to 50 newtons. Does everybody agree, beta?
Yes, sir.
Now I make the SF table. I think those of you who were asking some doubts, they will automatically be answered here. I'll take 3 points, and out of those 3 points, I'll have to divide all of them into 3 parts. SF will be newtons. I can take from left B, C, and A. To the left of B, there is no force. To the right of B, I have minus 30 downward. Then at C, to the left of C, I'll have minus 30. To the right of C, I'll have minus 30 and minus 20 equal to minus 50. To the left of A, I'll have minus 50. And then I'll have plus 50 becoming 0. Does everybody agree with the SF table? Then this is my SF diagram. This is B, this is C, this is A. Okay. A is the free end, fixed end, and B is the free end. At A, it changes from 0 to plus 30. Minus 30, sorry, my mistake, guys. 0
At
to
B,
minus. At B, it changes from 0 to minus 30. And then it remains minus 30 up to C. Then it changes to minus 50, remains minus 50, and becomes 0. Correct, guys? This is the SF diagram for this case. Yes or no?
yes, sir.
Okay. Now what will happen? Now, fortunately, my free end is to the left side. Now I'm making the BM table here. At what points? 3 points is good enough again. No need to add any more point. So this is BM. 1, 2, 3. What is the area under the SF diagram to the left of B? It is 0, guys. Yes or no? Correct?
Yes, sir.
Yes,
To
sir.
the left of C is how much? Minus 30 into 5. Correct, beta?
Yes,
Minus
sir.
150.
Yes,
Okay.
sir.
To the left of A would be minus 150, minus 250, minus 400. Am I right?
Yes, sir.
Yes, sir.
Does everybody agree with the BM diagram, BM table rather?
Yes, sir.
Okay. Now with this, we can draw the BM diagram. And why? Because at the free end, it has automatically become 0. It has automatically become 0 at the free end. And it's all minus, minus, minus. So I'll have space on down below. Here is my B. Here is my C. Here is my A. It's 0 at B, it's minus 150 at C, it's changing at a uniform rate, so they'll join by a straight line, and then it changes to minus 400 at A, right? It is like this, right? And this is how it basically, at the fixed end, you'll have the maximum BM. At the fixed end, you'll have the maximum BM of minus 400. This is how the diagram comes up in this case. Why? Because the here SF was also negative. BM also remains negative. Why? Because if I take the BM at C, this will be anti-clockwise, and from left to right, anti-clockwise is negative. Yes or no, beta? Correct?
Yes, sir.
Correct? So when
Yes,
I take the support to the right, then it does not cause this sort of confusion. But the same thing, if I draw it for this left hand side A case, let me come here now. The SF diagram, the reaction would be here, which will be equal to 50 newtons. And now we'll have the SF table. SF table in this case will be for plus this time. So I'll have A, C, and B. B is the free end. It will be all divided into 2. So 0 to plus 50, then plus 50, then plus 50 minus 20 plus 30. It will be plus 30 plus 30 minus 30 becoming 0. Does everybody agree with the SF table for the left diagram?
Yes, sir.
Yes, sir.
Okay. Now, if I draw the SF table diagram for this, it will be all plus plus plus. So I can keep on one side at A, C, and B. C is midway. So it goes from 0 to plus 50. It remains plus 50, reduces to plus 30, remains plus 30, and becomes 0. This becomes the SF diagram. You see what happens is, in this case, the SF diagram is above the x-axis, correct, Peter? Because the supported end has come to the left. Yes or no?
Yes, sir.
Okay. Now, when I go for BM, now you see the thing is, BM diagram for both the cases will come same. Now, here I come, and I'll do now with areas under the GZ curve, under the SF diagram, sorry. So it is A, C, and B. B is the free end. Now, integrate the area under the SF diagram from right to left, from free end to the fixed end. What is the area under the SF diagram to the right of B, or up to B rather, to the right of B? 0? Yes or no?
Yes, sir.
Yes,
Yes, sir.
yes, sir.
It is 0. What is the area? First, let's talk of area, not the sign. What is the area under the SF diagram to the right of C? It is 150. It is 150. 30 into 5, right? 150.
Yes, sir. 150.
I have intentionally not said plus 150. Why? Because now I'm going from right to left. Whereas SF diagram has been drawn from left to right. For BM, I'm going from right to left. So what will happen? This positive will become automatically negative. So the value will be minus 150, but that minus 150 would be somewhere, that value would be, value will be 150, but it will not remain plus. Why? You look at this diagram. If I come to C, this force will cause clockwise movement, and from right to left, clockwise movements are negative. Correct, beta? Yes or no?
Yes, sir.
So it will be minus 150 here, and this will be joined by a straight line. And then the area to the right of A is all 150 plus 250, 400. It's all above the x-axis. So the BM from right to left will become negative. So now it will come to minus 400, and this will be joined by a straight line. This will be the BM diagram for the question. What is important to note here is that BM diagram, if given a choice, is a concentrated load of 45 kilonewton at its free end and also a UDL of 20 kilonewton per meter over its entire length. Find the SF and BM at the wall and draw the SF BM diagram. Okay, guys, just because taking the support to the right is left is more complicated, shall I take the support to left and do it so that this issue gets settled once for all? Shall I take the support to the left, because there we'll have the bending moment from free end, then we'll have to reverse the thing. So what I'm doing is I'm intentionally taking the support to the left. He's not told us which side is the support. I have a light beam. This light beam is 6 meters long. It carries a uniformly distributed load of
Sir, can I interrupt from there?
yeah
Sir,
UDL. So UDL is 20 kilonewton per meter, which will be total of, this implies total UDL is 120 kilonewton per meter. Yeah. And there is also at the free end another point load of 45 kilonewton. First and foremost, does everybody agree with the diagram as per the question? If I keep the right, left hand supported, yes or no?
Yes, sir.
Okay. Okay, now my suggestion here is to keep it simple. Make sure when it comes to cantilever, you start naming from the free end. That means now I need only 2 points. I will make sure that to avoid mistakes, I'll always name the free end as A, and others I'll name from then right to whichever the free end to the fixed end. So my suggestion to you is name points from free end to fixed end. Is that clear, beta? Clear, guys? Understood? What will be the reaction at B? Upward it will be acting, and it will be total of 165 kilonewtons. Correct, guys?
Yes, sir.
Correct. Now I make the SF table. B and A. I'm going from left to right. Okay. For shearing force, it's no issue, no difference. Then I divide both our point forces. I divide them into 2. Shearing force will be in kilonewtons. To the left of B would be 0. To the right of B would be 0 plus 165 equal to plus 165. To the left of A, plus 165 minus the weight of the entire beam, that is minus 20, it will be plus 45. I carry forward plus 45 minus 45 equal to 0. Does everybody agree with the calculations of shearing? Everything is plus, so I don't have to have anything down below. This is B, this is A. My shearing force in kilonewton, and I have from 0 and there is a lot of debate in MMT whether cantilever is in syllabus or not, and many a times a replacement question has come whenever the cantilever question has come. Okay, but I don't want to leave it undone, because tomorrow replacement does not come, then what do you do? So it is plus 165 here, it goes to plus 165, and from 165 it goes to plus 45, 0 plus 45, so it goes to plus 45, and then it becomes 0. And it is changing because of the UDL, so it will be a straight line. Does everybody agree with the shearing force diagram, guys? Or any questions? This is the SF diagram of the question. Okay, so that means signs will be given keeping in mind the BM, with 0 at the free end, and we have come from free to fixed. Again, we have only 2 points. Let me just make it. Kilonewton meter will be the units. Area to the right of A is 0. When I'm now from free end, I'm coming from right to left. So my BM will be of reverse sign. Why? For a minute, if you have any doubts, you can go back to the beam diagram and see 45 Newton at about B, it will be causing a clockwise movement, and you're coming from right to left, so it will be minus. So here it will be minus sum of the parallel half into sum of the parallel sides 165 plus 45 into the distance between the
6 meters.
two. Yeah, so it is 170 and minus 330 is minus 630, is it?
Yes, sir. Minus 630.
Okay, minus 635. And now we don't keep anything above the x-axis because it's minus only, so we keep it like this. Here is BM in kilonewton meter. Here is B. Here is A. Let me change to now green or blue pen. Where is the cursor, man? Okay, now it is 0 at A and it's minus 630 here at the fixed end. I'm integrating areas under a trapezium from smaller side to bigger side. First, the rate would be less, and the rate is then peaking here, right, Peter? Something like this will be the BM diagram, correct? Correct, Peter? B will be the free. The diagram would be like somewhat like this. It weighs 100 kilonewton, so the beam has a weight. Something like this. It is there, right? This is end A. This is end B. This distance is 2 meters. He's saying. This has a uniform cross section. It's 10 meters. So length of the beam is 10 meters. The weight of the beam is 100 kilonewton at the rate of 10 kilonewton per meter, right? Correct, beta? This is 2 meters, okay? Not 20. It also carries a point load of 30 kilonewton at end B. So there is a point load of 30 kilonewton here at end B. Draw the SFBM diagram stating the values at intervals of 2 meters. Now, those 2 meter things you want to take, you can take. Then you'll have A, B, you already have. Then you'll have 1 point at support. Then another 2 meters will be 8 meters left. So 1. So this is 2 and 2, 4. 6, 8, 1, 2, 3, 4, 5. Okay. So we can call them now. Maybe support can be X. You can name whatever A, B. So support is C. C, D, E, F. These are the points he wants. Let's do as per his requirement. Does everybody agree with the diagram, guys?
Yes, sir.
Yes, sir.
Okay. Yes, sir. Now, where will the reaction be acting, guys?
C.
C. So write the reaction. How much will be the reaction? Please let me know.
130
130. Okay. Okay. So write the reaction.
kilonewton.
RC upwards will be 130 kilonewtons, right, guys?
Yes, sir.
Okay. Now, please make the SF table for all the points since he wants at all these points. So make the SF table. Let's not cut short. Let's go by the language of the question and meet his requirements. One, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 6. We have point load at C. So it is A, C, D, E, F, and B. Sharing force, we have a point force at C and we have a point force at B. Rest else, we don't have point forces. A, it is 0. it is 0, and then there is weight of 2 meters of beam, which is 20 minus 20, gives us minus 20 here. Then it is minus 20 plus 130, makes it plus 110. Take 110 here, minus 20 plus 90 plus 90 minus 20 plus 70 plus 70 minus 20 plus 50 plus 50 minus 20 is plus 30 plus 30 minus 30 is 0. Does everybody agree with the table?
Yes.
Anybody who has doubts with the table, beta, please let me know. Done? Okay. Now we make the SF diagram. It's all plus plus plus. Yeah, all plus plus plus. So no need to have space below this. I have A, C.
Minus 28C, sir.
Minus 20 at C. Okay, now might will have a little bit down below. No problem. D, E, F, and D. Okay, all are equispaced 2 meters each. Let me take a red mark. They are all going to be straight lines. I don't think that needs discussion. At A, it is 0. Then it goes to minus 20. Then it goes to plus 110. Then it goes to, basically it tapers to 0 like this. Khatam. These values will automatically fall in the straight line. Do you agree with me? Yes or no?
So B will be plus 30, then 0. No?
Oh, plus 30. Okay, okay, plus 30. So then it will be like this. Okay, my mistake then. Make it plus 30 and 0. Okay, let me change the color then. Let me draw with green then. It will be minus 20 plus this plus 30, and this will be a straight line, and these values will automatically fall here. Do you agree with me? Yes or no? This will be plus 90, this will be plus 70, and this will be plus 50. Correct, guys? Agreed, the green line is the SF diagram?
Yes, sir.
Half the question is done. Now the BM, you can go by, if you want to calculate, each distance is 2 meters. So let's make the BM table. We don't need any extra point. BM table. Now see what I'm writing. By areas under SF diagram from
Right to
free end. And the free end would be the B end, obviously. Now somebody may say A is also free, but you will work on the longer side of it. B will be the free end, and he said that's why the point force is also at end B. Okay, beta. Now let's make the diagram for it. A table for it rather, not the diagram. BM A. Okay. What I can do is, okay, if I want to write the points, I can write the reverse way, or I can write whichever way you want. That's your choice. What do you want me to write, from B, or you want to keep writing from A and I fill up from A?
From A.
You want to write AC, is it?
Yes, sir. A, C, D, E, F.
But I'll fill up the last one first then. Okay. Now I'll fill up the B first. Okay. BM at B would be 0. Do you agree with me? Yes or no?
Yes, sir. Yes, sir.
Okay. Look at the diagram. Forget about the weight of the beam. What about 30 Newton about F? Is it going to cause Look at the beam diagram here. Is it causing about F? 30 kilonewton is going to cause clockwise moment or anti-clockwise moment?
Clockwise.
Clockwise. And when you're going from right to left, clockwise is positive or negative?
Negative.
Minus. So the values will be minus, and you can be guided by the area. Okay. So at F, it will be minus this area, beta.
80.
Half sum of these two 40, 40 into 280. Sorry, my mistake, guys. It will be minus 80 here. Does everybody agree? It's area of this parallelogram, beta.
Yes,
The
sir.
trapezium, area of this trapezium, right? See, it will be the
Yes.
sum of, it will be the basically what is the half into sum of the parallel sides into, in this case, the distance between them is 2. This 2 and 2 cancels. So it's basically the sum of the sides, right? Correct, beta?
Correct, sir.
For the next one, it will be minus 80 and minus 120. Will become minus 200, right? At E, it will become minus 200, yes or no?
Yes, sir.
It will be this
Yes, sir.
one
Minus
trapezium plus 2 trapezium, right? At
Yes, sir.
D, it will be minus 200 and minus 160. It will be minus 380. It will be minus 380.
नहीं सर 360 होगा.
360.
360, sir.
Okay, 360. Okay, make it 360. Okay, fine. Minus 360 and then the last trapezium. Minus 200. Okay, minus 200. This minus 560. And at A, it will be minus 560 plus. Why? Because it is plus it because it has gone below the x-axis. Yeah, so plus 20. It will be minus 540. Correct, guys?
Yes, sir.
Okay. Now you can make the diagram whichever way it fits in. It is minus 8. There are all minuses. Okay, no plus. Okay. It goes like this. Here is B, here is F, here is E, here is D, here is C, here is A. At A, it is minus 540, and it's basically, if I use a scale of say 100, 200, 3, okay, let's say 300, 400, 500, okay, it will go further down, okay. I think I'll have to relook at the scale, 500 and so on, okay. So minus 540 will be somewhere here. Then it is 560, it goes further down because of, okay, this is because of the trapezium, this triangle that will try to reduce it. So it will be like this slow, slight reduction from here. Then minus 560, say minus 360, so 100, 200, 300, 360 will be somewhere here. Then 200 will be somewhere here. Then 80 would be somewhere here. And 0 would be here. So this would be somewhat like this today.
No, sir.
Okay. The reaction will be how much then?
38 tons per meter.
15, 30 tons.
15, 20 divided by
15, 20, okay. At the rate
20,
of
38 tons per meter.
38 tons per meter. Does everybody agree with the diagram? First tell me. If anybody has any questions on the diagram?
Sir, this 800 tons, sir,
Hmm.
is over 20 meter only.
So what distance have we put over it?
Sir, but in reaction, we are counting it equally as of 200 tons of both.
200 tons of both? I didn't get you. 200 tons of both means what? Okay. How many minimum points? How many minimum?
1, 2, 3, 4, 5.
How many minimum points for SF?
2.
4.
4, sir.
4. Somebody is saying 4. Anybody who feels less than 4. Somebody says more than 4. I don't want to even discuss. You can put as many as you want. But anybody who feels less than 4, please let me know which are those points.
3, sir. 3 maybe.
Okay, which are those 3 points? Please tell me.
Sir, A and the center of the beam, and then end point C. And 5, sir. There is no change. There is no change.
So, yeah, I'm
So
asking
4,
from the.
4.
So that correct? Why?
Yes.
Because there is a change in the uniform distribution at these 2 points, right? There's a break. Correct, Peter? It is 200 tons means it's 20 tons per meter. 20 tons per meter. 800 tons over 20 meters means 40 tons per meter. Correct, beta? Yes or no? Correct,
Yes,
guys?
sir. Yes, sir.
That's why the height of this cargo has been made more. The height of this weight has been made more because that's double. Understood? So now, what will be the shearing force at these 4 points? What will be the shearing force at A?
0.
0.
Okay. I carry forward anything to be divided into 2? Tell me. Any point to be divided into 2?
No,
No,
sir.
sir, no point
No,
load
sir.
there.
No, sir. No point four.
Okay. SF will be in tons. What will be the shearing force? What are the changes from A to C?
That negative 200 tons and positive 380 tons.
Positive 380 tons. Why? Because over this section, 200 tons of this weight is to the left of C, and there is reaction offered by 10 meters of the length. Reaction is 38 tons per meter, so the reaction from A to C will be 380 tons. So the resultant will be plus 180. Yes or no?
Yes, sir.
Yes, sir.
Clear, guys?
Yes.
ये 3080 है ना पक्का?
हाँ,
Yes, sir.
38.
38.
1520 को divide करोगे तो okay, fine. Then you carry forward this plus 180. From C to D, you have this 800 tons of downward weight, and other is 20 meters of reaction. 20 meters of reaction would be plus 760. Yes or no, guys?
Yes, sir.
So how much it becomes then? Plus
220.
sorry, 220
140, sir.
140 plus.
plus 140. No, there is some mistake you're making then somewhere because it cannot be so. Divide
Sir,
50.
The weight of the uniform cross section miss out हो रहा है.
Miss out हुआ है. There is a miss. Something has been missed out. Correct? Because it has to be.
380 C में ही sir.
Sir, C will be 100, sir.
Yeah. See, that's what I'm
100
saying.
sorry.
Okay. So there are three changes from A to C. My mistake also. There are 3 changes. One is this 200 tons of acting downwards. Other is weight of 2 to 10 meters of beam. And third is the reaction over 10 meters. Correct, guys? So what
Yes,
we have missed out is minus 80. That is the weight of the beam. Yes or no?
Yes, sir.
So it will be plus 100. Correct?
And D will be minus 100.
D will be minus 20 meters will be 160. And this will become minus 100. Please correct it and see your table. All of you to see. Please see shearing force at anybody has any doubts, please let me know. At whichever point you want, I'll explain because there is a cutting in
Sir,
the table that yeah.
In the C column, I got minus 200, which was the weight. 380 was the entire slab, which is down. So 80 was what?
One second. What is 380?
380 was this 320.
What was
380? So the reaction is 38 into 10.
Yeah, okay, very good. Okay.
Plus 380 I got, minus 200 I got.
Minus there is also weight of the beam of 10 meters, no beta? From A to C.
A to C beam of for
beam weight is 8 tons per meter, correct?
Yes, correct. Got correct.
Minus 80 is the weight of the beam for 10 meters. Okay.
Correct. Got.
Okay. Same thing. Please apply from C to D and see whether you're getting minus 100 or not. Apply from C to D the same thing and minus 80 tons of the weight of the beam plus 380 tons
plus
of
380
tons becoming 0. And now we make the shearing force diagram. It's all plus and minus also, so we'll have to keep both sides. We'll have A, then we have C, 20 meters from here we have D, and then we have B. And then we'll have it going from 0 to plus 100. So it's plus 100 here. Now, why it is a straight line, guys? Because what are the forces from A to C? 200 tons of weight uniformly changing. 80 tons of weight of the beam uniformly changing. Reaction of 380 uniformly changing. All the three changes which are happening from A to C are at a uniform rate. So the resultant change from A to C would also be at a uniform rate, resulting in this straight line. Yes or no, guys? Please let me know if there is any concern. I'm saying A to C has to be joined by a straight line. Does everybody agree?
Yes, sir.
Yes, sir.
Because all the changes which are there from A to C are at a uniform rate. At D, it is minus 100 and it becomes 0. For the same reason, from C to D, there are three forces. 800 is uniform. Weight of the beam is uniform. Reaction is uniform. So this also has to be joined with a straight line then. And for the same, with the same argument, this also gets joined with a straight line. Does everybody agree? This is which will be required for taking the BM.
BM.
Yeah, so now each of these segments is 10 meters. Now the distance becomes important to me here. Why? Because I'll be calculating areas. And now we can make the BM table. We have 1 to 5 points. So 1, 2, 3, 4, 5. A, C, X, D, B. BM would be ton meter. At A, it is 0. At C, it is plus half into 10 into 100 plus 500. At C, yes or no, guys?
Yes, sir.
Yes. Then plus 500 and another triangle of plus 1000. Then we'll have plus 1000 minus 500 will be plus 500. Then we'll have plus 500 minus 500 becoming 0. Does everybody agree with the BM calculations, guys?
Yes, sir.
Okay, what you can do is try making the BM diagram. Lead the class and make the BM diagram if you're. Ton meter is the unit. You can take one scale of 500, another will be plus 1000. Okay, I mark the points. Please draw the diagram. Okay, anybody, let me come out with it now. Is everybody done with the SF table or anybody still struggling? Please speak out. Last opportunity. Okay. Okay, everybody done with the SF diagram? Any doubt? Last opportunity. Why straight lines? Okay. Anybody struggling with the choice of point X, that it is midway between C and D? None. Anybody struggling to complete the BM table, please ask me. All the triangles are identical, all the 4 triangles. This triangle 1, triangle 2, triangle 3, triangle 4, all have the same base of 10 meters, all have the same height of 100, right? All triangles will have area of 500, right, guys? And using that, we have made the BM table, correct?
Yes, sir. So only issues coming in the BM diagram.
Okay, no, up to BM table is fine with everybody, guys.
Yes, yes.
Can you please repeat the BM table, sir?
Yeah, what is the doubt? Better tell me the doubt.
से है क्या
What is your
Sir.
doubt in the BM table? Somebody's
Okay, sir. Yes,
somebody is
sir.
asking in BM table. Let him ask. Yeah. Let him ask.
Yes, sir. Now, looking at the SF diagram, we can make a center line like at C and make it from vertex to base, then base to vertex.
Arey, yaar, somebody, wait. Somebody has a doubt in the BM table. Let me address him first. Guys, BM table, who had the doubt? Please let me know.
Yes, sir. This 500 plus 500 on the X, right, sir? So this has been, how do you get this plus 500, sir?
Tell me, how do you get BM? How have you been getting BM? You answer that. Maybe you'll see by yourself, beta. How do we get the BM for the BM table? How have we been getting for the beams? How have we been getting the BM for the beam for the BM table?
From the SF graph, sir, which we saw before.
Okay, so what do you get from the SF diagram, beta? Answer, what do you get from the SF diagram, which is called as BM? What do you get from the SF diagram that you call as BM?
The markings.
Speak up. Don't worry, speak up, man. Speak up. What do you? All these questions you have been completing the BM table. Have you been having this problem in every question, beta? Have you been having this problem in every question?
This SF, right, sir?
Sorry?
The area under the curve, we take this for the BM.
Okay, you take area under the curve to the left. Okay. How much is the area under the curve to the left of A in the SF diagram? So it will be somewhat like this.
The vertex to base.
Vertex. I'm drawing from vertex to base. I said base to vertex by mistake. So the second is base to vertex, so it will continue to be steep and then become horizontal near the vertex, right? Do you agree? The first two triangles would be like this, guys. Yes or no?
Yes.
The other would be
Yes,
a
sir.
mirror. Other would be a mirror image of it. Yeah, mirror image of it. You can just horizontally flip this and make on the other side, right?
So here is where I had a doubt.
Yeah.
So now I understood the first two curves. The second curve of triangle number 3, what we have mentioned.
No. So now, you make the diagram from B to X now. Start from B. B to D. B to D would be how, like this? Yes or no? Only you have to just start seeing sense. You have to just see. You can continue making. Nobody's see the first initially even from X beta. Triangle 3 is from vertex to base, correct?
Correct.
Right. So first the change has to be slow. This slow change is reflected by, let me change to red. Initially,
Sir,
the rate of change.
Yes, sir.
Okay. So it's very, very important that you do not carry any information or you misconstrue my statement. I am assuming that the light displacement is uniformly distributed. Why? Because in the absence of information, that is the best I can do. I am not at all saying that the light displacement of a ship is uniformly distributed. So that should not be the impression you should carry with. Okay. Okay. Now this is a box-shaped vessel. The light displacement is uniformly distributed. Cargo distribution can be seen on the diagram. What do you think would be the draft of the ship? Would it be even keel? Would it be trimmed? And if trimmed, would it be trimmed by head or stern? I'm not asking how much is the draft. I'm just asking, would the draft be even keel?
Yes,
Would
sir.
it be
Even
okay? Why the draft would be on even keel? Let me also say, if some people have the doubt, we have made an assumption that the light displacement is uniformly distributed. Okay. Secondly, when I look about amidships, here is the amidships. If I see the weight distribution of the cargo about amidships, forward and aft, it is symmetrical, mirror image of each other.
Yes, sir.
So that means as far as weight is concerned, it is distributed, whether it is cargo or it is the light ship, it is symmetrically distributed about midships. So weight is symmetrically distributed about midships. Yes, correct. Now, what supports the weight in case of a ship, guys? Can you tell me? In case of a ship when she is floating, what supports its weight?
Buoyancy.
Buoyancy. Now, what is buoyancy? Buoyancy is the weight of the water displaced. Weight of the water displaced. And what is the weight of the water displaced equal to? It's equal to the underwater volume of an intact vessel. Okay. Now, if I say that total buoyancy will be obviously equal to the total weight, right? All of you would agree with me. You have told me that she'll be even keel, so I'm just drawing the even keel. We'll continue this discussion why it is even keel. Okay, one is weight. We have just addressed weight so far. Now, the displacement of this ship is, this is 200 tons at the rate of 20 tons per meter. This is 400 tons at the rate of 40 tons per meter. This is again 400 tons at the rate of 40 tons per meter. And this is 200 tons at the rate of 20 tons per meter. The light displacement based on our discussion is distributed at a rate of 8 tons per meter along the length of the ship, 320 divided by 40. Now the total displacement of the ship would be then 800,000, 1200, 1520 tons is the total displacement of the ship. Correct. And as you would agree, by law of buoyancy, this has to be equal to buoyancy. Okay. Now, the buoyancy since it's a box-shaped vessel, the underwater cross-sectional areas will remain same for a vessel which is box-shaped if it is on even keel. Okay. So therefore, since the weights are uniformly distributed along the length, whether it is the light displacement or the cargo, not uniformly, my mistake. They are symmetrically distributed about midships. Buoyancy also would be distributed midships. Why? Because for a box-shaped vessel, you say here the center of gravity of the vessel will be on the midships. For a box-shaped vessel in even keel condition, the center of buoyancy is also midships, and therefore there is no trimming lever which is going to cause the vessel to trim. Therefore, this vessel will be on even keel. Does everybody agree, or there is any more discussion required on it? Guys, tell me. Does everybody agree that the vessel is on even keel? Yes or no? Now, if I treat this vessel as a beam, I can treat it as a beam. It has a cross section, fine. I can treat it as a beam of uniform weight. Then what does it become? It translates into a beam of uniform cross section, which is 40 meters long and weighs 320 tons at the rate of 8 tons per meter. Do you agree with me, or there is any problem in it? Yes or no?
Yes, sir.
And now this beam is loaded with 200 tons of UDL here, 200 tons of UDL here, 400 tons of UDL here, and another 400 tons of UDL here. Okay. This beam is supported by an upward force, which in case of ship is the buoyancy. But if I put this beam on a flat surface, then like the buoyancy, will the reaction be uniformly distributed? Yes or no? Correct, beta?
Yes, sir.
Correct, sir. So if you remember, this was the question of the beam that we had done yesterday. Correct, beta? We had done this question yesterday, right? When there was this one. Yes or no?
Yes, sir.
Correct? Does everybody remember this question we had done yesterday? I have the screenshot ready for today's discussion. It is yesterday's calculation, not from the previous batch calculation. It is from yesterday's. Yeah. Okay. So do you agree? Do you agree that this box-shaped vessel can be represented by this beam as far as SFBM is concerned? Yes or no? Only thing is, in case of beam, it was reaction by the ground. Here now it is the buoyancy which is supporting the weight. Yes or no? Correct, beta? If this box-shaped vessel was to be represented as a beam, would this box-shaped vessel translate into this beam? Yes or no? Or any doubts? Tell me, guys. Is going to translate into this beam, and the beam's shearing force diagram is this one, and the bending moment diagram is this one. That means for this box-shaped vessel, my shearing force diagram would be this one, and the bending moment diagram would be this one. Yes or no? Correct?
Yes, sir.
So every vessel, whether box-shaped or not box-shaped, can be represented and converted into a beam problem. Yes, it can be. Whether we are interested in converting it to beam problem or not, that is our choice. Why? Because this was a simple box-shaped vessel which got converted into a simple beam problem, which we did yesterday. But the cargo distribution, the weight distribution of the ship, the draft of the ship, all these can be variable. The cargo may not be trimmed level, cargo may not be symmetrical about midships, light displacement may not be uniform along the length, the vessel may be trimmed, so buoyancy is not uniform. So if every vessel, not only box ship, every vessel can be converted into a beam problem. But whether the beam is going to be user friendly for solving or not, that is something different. So you may convert into beam, and then you hit a complex beam and you say, no, yaar, this is not a user friendly. This beam is, I know, I have not learned how to resolve this particular beam. So you may hit a dead end based on the limited expertise or limited knowledge that we have acquired. If we are very proficient in maths and stuff, any complex beam can be resolved. So don't have that doubt in your mind whether the beam could have been resolved or not. Any beam, however complex it may be, can be resolved mathematically. But we have not attained that sort of proficiency where we can wrestle our way through with the complex beam situations. Therefore, this simple scenario was only to establish that yes, every box-shaped vessel can be converted into a beam, and beam can be solved. Like in this case, the simple beam problem we solved, and now we know for this box-shaped vessel what should be the value of the shearing force at different points and what should be the bending moment at different points. They are already there from the results that we obtained yesterday. Guys, any questions or clarifications on whatever I have said until now? We have devised a new method of handling the box-shaped vessels. So far, what have we learned for beams? For beams, we get the SF diagram, and from SF diagram, we get the BM diagram. Correct, guys? This we have already mastered in case of beam. Yes or no? Correct? Now, for box-shaped vessels, we will introduce one more diagram, which will be the first diagram to draw. So what we are going to do is, we are going to introduce one more diagram which will precede the SF diagram. So we will make one more diagram here, which will be before the SF diagram, and that will be called as the load diagram. So we will not be keen to convert a box-shaped vessel into a beam as I have explained here. This explanation was only to satisfy that yes, what should be the result of this box-shaped vessel? The result should be what we got yesterday for a simple case. But how would we prefer to handle the box-shaped vessel is through a slight modification. We develop a load diagram. Now, load word, all this while when beam was being used, in some questions it came, the beam is loaded. Okay. This should not be confused here. The word load here means if you get the load at different points along the length, load at each point will be the resultant of upward and downward force at that point. It's not only the downward, it's the resultant of upward and the downward force. That is what is meant by the load in the load diagram. Is that clear, beta? Our steps that will lead to BM will be, first we'll draw the diagram of the vessel, of box-shaped vessel. Second, we will identify the key points for load table, because load table is now what you'll make first, right? Then, based on these key points, we'll make the load table. Once we have the load table in place, we'll make the load diagram. Once we have the load diagram, from the load diagram, we will, like we were making from SF the BM, we will make the SF table. Then from SF table, we'll make the SF diagram. And from the SF diagram, you already know, you'll make the BM table. And from the BM table, you'll make the BM diagram. So these will be the steps involved in drawing the SF BM of a box-shaped vessel. So instead of converting a box-shaped vessel into a beam, we shall deal with it through a load diagram. Why? Because that will simplify the working for us. Is that clear, beta? Is that clear? Problem in understanding at any step, let me know. The first thing will be to make the box-shaped vessel diagram. Okay, I'm going to first make the diagram here. This is my vessel, which is 40 meter long. Breadth is not given, never mind. Divided into 4 holes of equal lengths. Either I write forward aft or I write the hatch numbers, whichever way you feel comfortable, guys. Because hatches and tanks are numbered from forward, we all know. They are all of equal lengths, 10 meter each. We know the cargo. Okay. If the cargo is 200 tons here, what will be the cargo distribution per unit length, guys, for hold number 4?
20 ton.
20, sir.
20 tons per meter, right?
Yes, sir.
If the cargo in number 3 hold is 400 tons, I am sure at the rate of 40 tons per meter. Again, we have the similar thing, 40 tons per meter and 200 tons at the rate of 20 tons per meter. Light displacement of the ship is given as 320 tons. And since we have no choice but to assume it uniformly distributed, it shall be 8 tons per meter. Am I clear, guys? And this is the cargo. Let me shade the cargo. That will give you some idea. Okay. Now this vessel, obviously based on our discussion, will be floating on even keel. So I can draw the even keel waterline wherever I want. Doesn't make a difference. This draft will be corresponding to displacement and the density of the water in which the vessel is floating. Okay. Then, now I say, what will be the buoyancy? It will be equal to the displacement of the ship equal to 1520 tons. And this buoyancy will be distributed at the rate of, can you divide 1520 by 40 beta?
38.
38 tons per meter. I am giving the reason here because it is box shaped and even keel, both together beta, not or, plus even keel. Box shaped plus even keel. If you don't have a box shaped vessel, even if it is an even keel, then the underwater cross sectional areas will change along the length, so buoyancy will not be uniform. And if a box shaped vessel is trimmed, again the underwater cross sectional areas will change and the vessel will not remain even keel. So why the buoyancy is uniformly distributed is because it's a box-shaped vessel and it is floating on even keel. Is the logic clear, beta? And I'm sure if I ask you to identify the critical points like you used to do for beam, I'm sure all of you would pick up maybe this point, because they are ends. What do you see at this point? There is a change in the cargo distribution. And maybe this point where there is a change in cargo distribution. Would you pick up these 4 points? Yes or no, guys? If you were to consider it as a beam, yes or no?
Yes, sir. 4 points, sir.
Okay. Okay. Now, since there is a bulkhead here, we can pick up one extra point also. Like yesterday, also somebody said, let's pick up C. Then we got the C from the table. So if you don't want to pick up, it's okay. But you can pick up C also, this point also, just because there is a bulkhead. That's why. Otherwise, it could have been avoided. If you say, can it be avoided? Yes, it can be avoided because the cargo weight on either side is same. Okay. So with these 5 points, I'll mark these numbers, these names A, B, C, D, and E. Clear, guys? So I have marked the key points. As I said, C could have been skipped also. So if somebody is feeling why C is taken, it's just we've taken out of choice. Had we wanted, we could have missed it out. Clear, beta? Clear, guys? Load table. We'll make the load table for these 5 points. One, 2, 3, 4, and 5. Now again, the sequence of the points from left to right must be respected. Left to right, okay? Because you don't want to again get into that cantilever thing where the signs were to be reversed. A, B, C, D, and E. In the first row, we'll now, what is load? As I told you, load is the resultant of upward and downward forces, downward weights, and upward buoyancy. Now, if you look at this box-shaped vessel, there are two downward weights. What are the two downward weights in this question?
Cargo weight plus
light and
lightweight and cargo.
Correct. So the first thing is, let's deal with the light displacement. So we write like this, light displacement. Are we going to write 320? No. We are taking light displacement per meter. So what are the units of this? Tons per meter, beta. Okay. Now, when you take this light displacement, make sure you divide the first point and the last point into 2, because to the left of A, there is no light displacement. It's 0. The moment I come to A or right of A, it becomes 8 tons per meter. So that means at A, it must be changing from 0 to 8. So again, this cell on top is represents the upper part represents to the left of A. The lower part represents just to the right of A. And I'm sure you'll agree it is 0, 8, 8, 8, 8, 8, 0. Does everybody agree, or anybody has a question as to how it has been filled up? Light displacement at different points per meter, right? Any questions, Peter? For cargo like this? Okay. Now, weight of the cargo to the left of A is 0 per meter, per unit length we are talking about, right? Weight of the cargo to the right of A per unit length is 20. Weight of the cargo to the left of B is 20. Look at the diagram. So I'm being guided by the diagram, right? 40, both sides, then 40, 20, 20, and 0. Please take a pause. See if everybody is comfortable with the cargo weights that have been filled in. Okay, let me take red. It will be the algebraic sum of this. I'm writing 1 and 2. You don't have to write. It will be the sum of 1 and 2, and they'll be algebraic, means they have both sign, both are acting downwards, so they'll just be added. So this number 3 row will be equal to 1 plus 2. Now, which cells to divide? In 1 and 2, whichever cells are divided, whether they are divided in both or they're divided in 1, all the cells that are divided either in 1 or 2 or both, they will by default be divided in the total, obviously, because the 2 are the components of the total. So we see that A, B, D, E were divided on top. Yes or no, beta? Between 1 and 2, these 4 cells are divided. Yes or no? Correct, guys?
Yes, sir.
Okay. Now we find the total of these. To the left of A, light displacement, I'm taking only for the one time explaining you. Light displacement to left of A is 0. Cargo weight to left of A is 0. So the total weight to the left of A is 0. Understood, guys? How I filled in this 0? Yes or no? The the light displacement to the right of A is 8. Cargo weight to the right of A is 20. So it becomes 28 here. Does everybody agree now? Understood? Now I'm not going to mark another for B, C, and D. Okay. So what happens? 20 plus 8 becomes 28 here, and 40 plus 8 becomes 48. Why? Because in B, 8 is there, which is on both sides of B. So obviously it will be added to 20 and 40 both. So 28 and 48. Is that clear, beta? Are the weights for B clear? Total weight for B clear, beta?
Yes, sir.
For C, it will be 48. May I request everybody to fill up the remaining 4 cells before I fill up, if you're making the table?
Yes, sir.
In which direction does the weight act, beta? Downwards or upwards?
Downwards.
And are we going from left to right? Look at the diagram. Have we named from left to right? Yes or no?
Yes, sir.
So when we go from left to right, is the downward force positive or negative?
Positive. Downward for negative.
Negative. So we put a negative sign in front of all these ones because this is the negative one. Then, right? So now we have got the total weight at all these key points that we picked up per unit length, of course. And we have put a negative sign because we are going to go from left to right, and from left to right, as per the sign convention, downward weights are negative. Right, guys?
Yes, sir.
Now what is left is upward force. There is only one upward force, that's buoyancy. Now we make a row for buoyancy. In tons per meter. This is my row 4. Now we have already discussed here guys, that buoyancy is uniformly distributed along the length. So I'm going to pick up from here where we left. Okay. Now, but to the left of A, there is no buoyancy, and to the right of E, there is no buoyancy. So like the light displacement, I'll divide these two cells into 2, and then it will be 0, 38, 38, 38, 38, 38, and 0. Does everybody understand, or is there any confusion about why it's these values? Clear, beta?
Yes, sir.
From left to right, buoyancy which is acting upwards, should it be positive or negative?
Positive.
Positive, sir.
So we put a positive sign here. And now the resultant of 3 and 4 will give us the value of the load, guys. Resultant of 3 and 4 will give us the load. And this is this value of load that we'll use to draw the load diagram then. Now, now load is based on row 3 and 4. Whichever cells in row and 3 and 4 are divided, all those cells need to be divided. And if you see both 3 and 4, then A and B are divided and D and E are divided. Am I right, guys?
Right, sir.
And we get the algebraic sum. To the left of A, 0, 0, 0. To the right of A, minus 28 plus 38 plus 10. To the left of B, minus 28 plus 38 plus 10. To the right of B, minus 48 plus 38 minus 10. At C, it is minus 10. To the left of D is minus 10. Then it is plus 10. Then it is plus 10. Then it is 0. Please satisfy yourself with the values of load that have been now obtained. Box shape diagram was needed up to the load diagram. Now for shearing force, our focus will be on the load diagram. Okay. We will look at the load diagram and use the same concept which you used when you were making BM from SF to pick up critical points for shearing force table. That means all the points where the load has been worked out, they get default by default, and any other point where the load diagram cuts the x-axis will also have to be included. Am I clear, guys? Same concept, no change in the concept, yes or no? Correct? Well, what do we write? SF table, and we write by areas under the load diagram. And we make it for 5 points because there is no extra point where it is cutting the x-axis. So shearing force will be in tons. Why it will be tons? Because load is in tons meter, x-axis is in meters, so it will be tons again. So A, B, C, D and E. A, B, C, D and E. Guys, now since you are integrating areas under the curve, there will not be sudden changes. So now there is no need of dividing the cells. Why? When we were using the SF for making BM, we never had the need of dividing because there will be no sudden jump. Whatever sudden change has to take place, it will happen in the first table that you make. For beam, the first table you were making was the shearing force. For box-shaped vessel, the first table you're making is the load table. So the sudden change which had to happen, where you needed the cells to be divided, would be always only in the first table and not thereafter. Am I clear, beta? Clear?
Yes, yes.
And these distances are all 10 meters, you already know. So what is the area to the left of A under the load diagram? It's 0. Does everybody agree?
Yes, sir.
What is the area to the left of B in the load diagram? 10 plus 10 into 10 plus 100. Correct, beta? Yes or no?
Yes, sir.
Now we carry over this plus 100 first. What is the change from B to C? B to C is minus 100. Yes or no? This area, correct, beta?
0.
Change is minus 1. So becomes 0. We carry over 0. From C to D, it's another minus 100. So it will be minus 100. Correct, guys? We carry over minus 100. The change from D to E is plus 100 and it becomes 0. Does everybody understand how the SF table has been made, guys? Shape of the load diagram. Why? Because we are using the load thing. So it is plus 100 and minus 100. So we have A, we have B, we have C, we have D, and we have E. And we have shearing force in tons now. It's plus 100 here, minus 100 here. Let me change the color to blue now. So the curve. At A, the shearing force in the table is 0. At B, it is plus 100. At C, it is 0. At D, it is minus 100. At E, it is 0. Look at the load diagram. What should be the shape of the SF diagram from A to B, guys? You already know the concept.
Slant lines or straight
Slanting, straight slanting line. Put the scale, join them. For the same reason, put the scale, it will be all straight line up to all. Any questions on the SF diagram? Guys, first, can everybody make the box-shaped vessel and load the information? Mark the water line. If you feel it's going to be even keel, mark it even keel. If you don't think it's even keel, then mark it the way you feel appropriate. Please draw, represent the loads, and do it. I will wait for 10 seconds, then I'll quietly make. I will not utter a single word unless you have a doubt and you need clarification. If your box-shaped vessel is correctly made, first step is well taken then. Is this the diagram you made?
Yes, sir.
Or something else?
Yes, sir.
Very good. Please calculate the buoyancy, and if you made it even keel, then decide whether the buoyancy is uniformly distributed or not.
Sir, that cargo compartment 10 tons per meter, sir.
Yeah, okay, my mistake. Thank you for correcting. 10 tons. Okay. 10 tons per meter. $1,200 tons at the rate of 80 से divide करोगे तो क्या बचेगा? 15, is it? Okay. Everybody is with me on this, or does anybody need any clarification? Please speak up if you need any clarification on the diagram. Again, I would say you need to rake up the issue at that particular step so that you know which is your weak area. When you reach that spot or weak zone, that is the time you need clarification. So shall I assume that everybody who's logged in is good with the diagram, guys? From the left end, to the right, name alphabetically A, B, C, D, E, F, whatever minimum number of points you need to name. I have told you which side to start from so that we don't have different notations. They'll unnecessarily confuse you. So from left to right, can you please name whatever minimum points you think need to be named on this diagram for the load purposes. And if you have named, then as far as I am concerned, I would have taken these 4 points. If you have taken anything extra, you can take, but it is not actually required, right, beta? Does everybody agree with it? Class, choice of points for load. Is this what you have filled up for cargo? Just see for the 4 points. All the 4 cells will have to be divided. This will be 0, 20, 20, 10, 10, 20, 20, 0. And this will have the minus sign. Yes or no, guys?
Yes, sir.
Anybody who's got any clarification required for the total weight can now ask. This has come from the above 2 rows. If you are not getting this, let me know where are you messing it up. Don't come to load table problems after 4 questions, beta, because then you will be wasting your time by not understanding the 4 tables. I'll push you. If you ask me a question, I'll ask you 10 counter questions, but that is okay. That is with a purpose. That is with a purpose to hammer in the right information rather than saying yes or no. So don't go on the back foot if you are being questioned. Somebody was asking about the light displacement beta. Are you okay up to load now or any concerns? The person who had a problem with the light displacement beta, are you okay with the full table or now there is any concern still?
Yes, okay, sir.
तो पक्का श्योर ना? नहीं तो बेटा सारा क्लास बेकार चली जाएगी तुम्हारी. अगर कुछ है तो पूछ लो अभी. Otherwise you'll be missing out on the entire class. It will go down the drain unnecessarily. Okay. Anyway, okay, good. Now, can the class make the load diagram? Please lead me now. Make the load diagram, guys. I would have loved to make it under the box-shaped vessel, but I'll make all the 3 diagrams under this. Then here I wanted some more space, so I'm making it separately here. These 20 meters. C is here. E is here. This is 20. I have not marked the midpoint. I've just marked it on the diagram. It's not in our table as such. No issues. Our values are, this will be load. So please mark the x-axis load in tons per meter. Please take care of these small things that I'm marking. It is +5 and -5. And based on the values that we have got, the load diagram will be 0 to -5. The remaining -5, then becoming +5, then remaining +5, then becoming -5, becoming -5, 0. So +5, -5, -5. Does everybody agree with me? Yes or no? Any questions on the load diagram, beta? It's a MMD question and you'll be happy to see how simple the question is. Okay, now next. Look at the load diagram. Now the job of the box-shaped vessel is done. Don't cut it. I am cancelling it so that what I'm trying to say is its job is completed. You will not cut in your working. You will leave it as it is. Now, I didn't look at the load diagram and tell me what should be the minimum number of points for the SF table beta. Guys, how many?
Same, sir. 4.
Same number,
Okay,
sir.
very good. SF table right here by areas under load diagram. Shabash. We make it for the same 4 points, and now there is no question of division or anything. It's a straight run now. What will be the units of SF, guys?
Done, sir.
Tons. Very good. Point order must be respected. C and D. Area under the shearing force diagram to the left of A, please fill up. Area under the SF diagram to left of B, please fill up. C and D, please fill up. Is that correct, beta? It's 0, minus 100, plus 100 and 0. Yes or no?
Yes, sir. Correct.
Guys, anybody in the class not getting the shearing force at the 4 points correctly? Or if you have any doubt, let me know. None? Fantastic.
Sir, at C point C, sir.
Tell me what is the confusion? What is the confusion? You have to tell me the confusion, beta.
Yes, sir. Sir, minus 100 carry forward हो गया, sir.
Yeah, then what is the change
And
from
then
B to C?
it's,
Tell what is
plus
the change
200
from
you got.
yeah. So then what will be the shearing force at what will be the shearing force at C? Tell me then. You only answer, beta.
Okay, okay, sir. 220, 20, 40 into 5 for 200. Yes, sir.
Got the answer by yourself? Yes or no? Got it, beta?
Yes, sir. Yes, sir. Thank you. Thanks.
Okay, okay. Now, can I request the class to make the SF diagram? Make the SF diagram, please. Make sure you shape it based on the shape of the load diagram. This is SF in tons. I'm sure all of you would agree. It will be straight lines, slanting straight lines. This is the SF diagram. Does everybody agree, beta?
Yes, sir.
Okay. Then where is it cutting the x-axis? Mid-length? Yes or no?
Yes, sir.
So this is x. Mark that as x. And each of these distances you can mark on this table, on this diagram, because you'll need for areas for BM. So you can mark the spaces between AB, BX, XC, and CD so that there is no confusion. This is minus 100. This is plus 100. Now, guys, how many points required for the BM table?
5, sir.
5. 5. Very good. Make the BM table by areas under SF diagram. BM will be in tons meter. 1, 2, 3, 4, 5. It is A, then B, then X, then C, and then B. It is 0, half. So this is minus 1000. Yes, then it is minus 1000 and another minus 1000 will make it minus 2000. Then minus 2000 plus 1000 will make it minus 1000. Minus 1000 plus 1000 will make it 0. Is the calculation of BM correct, guys?
Yes, sir.
Okay. Now, based on the diagram,
सर 3 पॉइंट लेके नहीं कर सकते हैं.
Sorry,
Only 3 points are A, X, and B. BM calculation.
how will you shape it with A, X, and B?
Area of triangle.
एक मिनट. What was the thumb rule I told you about the points for BM table? Can you repeat that? What was the thumb rule for choice? I don't mind answering questions, but questions should be something which has not been taught or something. Okay, let's see. Number 1, mark the forward aft, whichever. Number 2, number 3, number 4. It's 125 each. $125 tons at the rate of 10 tons per meter. Okay. Next is 180. Third is also 180. $180 tons. Can you divide by 12.5? How much it comes better at the rate of?
14.4.
Sorry?
14.4.
14.4 tons per meter. Okay. Whatever they are doing, it's okay. Okay. Look at this. Now mark the water line. The vessel floats at an even keel draft of 3 meters in seawater. So you can mark the water line wherever you want. Doesn't make a difference. We don't know where 3 meters is going to be. This is 3 meters of draft in seawater. Okay. Well, how much is the total cargo beta in this now then? Can you just total the cargo? Is 125.
610, sir.
610. What is not given here is the light displacement of the vessel. Yes or no, beta?
Yes, sir. 1845.
Yes, sir.
Yeah.
That's
But
a
what,
light
what,
yes, sir.
yeah, but he's given you the breadth, he has given you the draft, he's given you the density.
Displacement निकाल सकते हैं.
Correct. So you can find out the load displacement.
1845, sir.
Yeah. So it will be, so this has nothing to do with SFDM. This has got to do with your basic understanding of law of flotation. It's 50 into 12 into 3. This is the underwater volume into 1.025. How many tons it comes to, beta?
1845, sir.
18. This implies the light displacement will be equal to 514.
1, 2, 3,
1, 2,
3, 5.
3, 5 tons. Okay, beta. 1, 2, 3, 5 tons. Okay. Can you divide 1, 2, 3, 5 tons? Light
24.7.
Okay, light displacement 1, 2, 3, 5 tons at the rate of 24.7,
24.7, sir.
24.7, sir.
tons per meter. Okay. Guys, any questions up to this that is required to be basically for load table? Also we'll need is buoyancy. Buoyancy will be equal to 1845 tons and divide by 50. How much it comes to, beta? At the rate of
36.9.
6.9.
Okay, 9 tons per meter. Now we are all ready to get the load table done. Any questions up to this point, beta? So the only difference here is in the questions that we had taken earlier, the light displacement was given upfront in the question itself. In this particular question, the light displacement had to be obtained by calculating the load displacement and subtracting the amount of cargo that you have on board the ship. I don't think that requires anything much to do. Now let's name the points. I'm sure it leaves no doubts. Though the middle point we can skip if we want, but for the same reason as I told you in the beginning.
Just small doubt, I'm really sorry to ask this.
Yeah.
In previous questions, whatever we did, we had cancelled out
I'll answer only the questions if people have, otherwise I'll keep quiet. In the table, do not forget to miss out the units. That's all I'm trying to emphasize upon. No problem. Those who have solved can continue with SFBM. No, close the question. There is nothing for me to speak. Complete the question.
Yes, sir. Please give me a few minutes.
So if somebody says at which points you have the maximum shearing force, it's C and D. Is that clear, beta? Don't worry about the sign then.
Yes,
if somebody is asking, okay. And the BM diagram would be like this. It will be all plus this time. A, C, A, B, C, D, and E. Let me take some other color here. Now I can take which one? Maybe red, blue, सब हो गया. Okay. ठीक है, blue रखते हैं. It's going to be half the triangle will be. Your BM value, beta, somebody who was having doubts, it will be one triangle that is 27.5. Yeah.
875.
Into 12.5. You divide by 171.875, right? Yeah. 170. So this is double of it, right? So 171 point something, then double of it here, then equal to this here, and 0 here. So it will be the same thing.
So can you just round up this to 172 and then just plot it?
Sorry, say again, beta. Say again.
Rounding off, like we can take 172 for a round off value.
Yeah, you can take I would suggest if you're rounding off, at least keep one decimal place. Don't make. How does it make a difference? See, when you take the scale for BM, no, beta, you have two values. One is X, other is 2X. So you can just mark them randomly, no. You don't have to take 1 centimeter is equal to one thing and then try to put that,
Yes, sir.
Okay. See, guys, I think what is bothering him is probably the scale. What I'm saying is, don't worry about the awkwardness of the figures, bete. When you're drawing the BM like this, on the BM scale, I take 1 point here and at the same distance, I take another one here. This is that. This I put as whatever decimal places I want to take. I can put it as plus 171.875 and this becomes double of that, right? Understood? What does it mean? Is cargo weight 20 tons at X? X is a point. But we are saying 20 tons per meter. And you did not challenge me. Why? Because it was a simple case which was very evident. So nobody challenged me. And I'm taking you back to that. So when you are saying 20 tons per meter, what does it actually mean to you? Would somebody like to say? You made an attempt.
No, it is just one.
Okay. This concept is very similar to instantaneous speed.
Sorry, sir. Sir, my internet was disconnected. I didn't.
So we have not done anything. Don't worry.
Sir, can you explain me once again?
You have not missed anything. That's what I said, beta. Okay, you're not missed. Okay. Guys, instantaneous speed. When you're driving, and we say, what is your speed? You say 60 kilometers per hour. At that time, when you look at the speedometer and you immediately say it's 60 kilometers per hour. Does that mean you have covered 60 kilometers? No. What does it mean? If you continue at the speed what was at that point in time, and you continue it for 1 hour, then you will end up covering a distance of 60 kilometers. Yes or no, beta?
Yes, sir.
Okay.
Yes, sir.
Okay. Now, the weight of the cargo at a point is like instantaneous speed. There it is per hour, here it is per meter. Okay. Now, that means whatever is the breadth of the cargo, whatever is the height of the cargo, if it continues to be same breadth and same height, sorry, same breadth and same height, over what length? Over a length of 1 meter. Correct, beta? Correct? The weight of this cargo will be 20 tons. Do you understand now what is meant by cargo per unit length? Yes or no?
Yes, sir.
Yes, sir.
That means, beta, if suppose at 10:02 31 seconds, I asked you the speed and you said 60 kilometers per hour. It was at that moment. Okay. That means now if I continue moving at the same speed for 1 hour, I'll end up covering 60 kilometers. That's what it means. Now, as far as the cargo weight is concerned, it depends on the volume of the cargo, because density of the cargo will be same throughout the hold, right? Now, it will depend on the volume of the cargo. Now, volume of the cargo will depend upon what? It will depend upon the length of the cargo, it will depend upon the breadth of the cargo, and it will depend upon the height of the cargo. Do you agree the volume will depend on these three things? Yes or no? Correct?
Yes, sir.
Which view of the ship are we making? We are making the side elevation and we are saying per unit length. So that means we are talking of cargo per unit length. That means we are not going to disturb breadth and height. That means if the breadth of the cargo remains whatever it is at X, pay attention to what I'm saying. If the breadth of the cargo remains whatever is the breadth of the cargo at X, height of the cargo remains whatever is the height at X, and both these things remain unchanged for 1 meter length, then the volume of the cargo and its weight will be the weight of the cargo per unit length at point X. Is that understood? That is the meaning of what you're saying, 20 tons per meter. Correct, beta?
Yes, sir.
Correct? Yes or no? Diagram. This is the trimmed cargo. I want at this point X. So if I continue the same height of the cargo for 1 meter, this is 1 meter length of the vessel. Breadth, of course, it's a box-shaped vessel. Breadth will remain unchanged. Height I have fixed, same height over this meter. Then this is the volume of the cargo that will be there for over 1 meter. Yes or no, beta? Correct, beta?
Right, sir.
Yes, sir.
Yes, sir.
The weight of this volume will be the weight of the cargo. That will be the weight of cargo per meter. Is that clear? Have you understood the concept of cargo per meter that we have been using it in the table? You did not question it because it was trimmed level, and you straight away divided the total weight of the cargo in the hold by the length, and you happily accepted it. But it's important that you appreciate what does it actually mean. Why? Because if the cargo is not trimmed level, then the height of the cargo at each point is going to change. Let's say now this one. Let's say the cargo is trimmed like this. This is the cargo, beta, sloping cargo. Now, let us say now we are talking about box-shaped vessel, so please don't lose sight of that. Suppose here is point X, and now I'm asking you, what is the weight of the cargo per meter at X? Now, X along the length is not 1 meter. X is a point along the length. Now, what is the height of the cargo at X? This is the height of the cargo at X. Yes or no, beta?
Yes, sir.
Correct. So going by the same thing, if the same height of the cargo and same breadth of the cargo continues for how much length? 1 meter. then the weight of that cargo will be weight per meter at point X. That means I continue the same height for a distance of length of 1 meter, and the breadth, of course, being the box-shaped vessel, remains same. This cargo will be the weight of cargo per meter at X. Have you understood, guys? How will it be dealt with the sloping cargo?
Sir, can you repeat, please?
No, sir. Please repeat.
What is it that MMD May 22 floats in seawater with the iron ore of stowage factor 0.67 cubic meter per ton, stored to a height of 4 meters at mid length, and sloping uniformly to nil at the ends. This is the cargo lengthwise area, and of course it is along the full width. The vessel then floats in fresh water at an even keel draft of 4 meters. Fresh water, okay. Draw the SFBM diagram of the vessel. Guys, firstly, does everybody agree with the diagram, yes or no?
Yes, sir.
Agreed, sir.
Okay, first point. Anybody has any doubts on the diagram first? Let's placement of the ship. Can you please calculate the load displacement, which you can calculate because the draft is given at load displacement in fresh water. What is the load displacement of the ship, guys? Calculate.
Sir, 960 tons.
Very, very good. Shabash. It will be 30 into 8. 8 is the breadth. Into 4 meters into 1, the RD of fresh water. And he's saying 960 tons. Everybody is okay with this step? Of the cargo. So the cargo weight, guys, will be equal to what? Volume of the cargo divided by stowage factor, yes or no? Correct?
Yes, sir. Yes, sir.
Look at the diagram. Don't give me the value. How can I get the volume of this cargo? Visualize the hold, which is cuboidal.
एरिया निकाल के सर 8 से मल्टीप्लाई कर देंगे एक ट्रायंगल का
Area multiplied by breadth, yes or no, guys?
Yes, sir. Correct, sir. Correct.
So this area of the full triangle, facing triangle along the length is half, base is 30, height is 4. This is the full area multiplied by 8, that becomes the volume, divided by the stowage factor, it becomes the cargo weight. Can you calculate and give me the value?
$716.42.
716.42. Is that correct, guys? Can you just quickly check once?
Yes, sir.
7 to 8. 7 to 8.
7 to 8, is it? How much is it coming?
716, sir. 716.442.
42.
Okay, that I've written. If somebody is saying probably giving a different value, that's why I was wanting to check. 432, 32 into 15 divided by 0.67. 0.67. Okay. 716.42. Yeah, 417. It is 418 actually. 42. It's okay. So this can give us the light displacement, guys. Light displacement will be equal to minus 960. If we subtract from here, it's 243.58, right?
Yes, sir.
Correct, sir.
Yes, sir.
If I divide this by 30, if I divide by 30, because I have to assume that light displacement is uniformly distributed, it comes to 8.12 tons per meter. Yes or no, guys?
Correct.
If we are rounding out to 2 decimal places,
Yes,
if we are rounding
correct.
up to 2 decimal places, it's 8.12 tons per meter. Any questions up to this point, guys?
Sir, if height of the cargo, this one, just now what is it?
What did we just do here in this?
got that. Thank you.
Okay, fine. Now, using the same concept, I made these statements with intention for A and C. Using the same concept, can I get the weight of the cargo per unit length at C?
C will be 0.
At C will be 0.
So B का बात कर रहे हैं ना मैं?
Acha, okay, sorry, my mistake. C is my, it's my
B
fault.
32, sir.
32, okay. Now, what is the
क्या मतलब 32.47 आया है कैलकुलेट
okay, if the weight of the cargo, height of the cargo is 4 meters, if this height of the cargo continues over 1 meter length, over the breadth of the ship, which is 8 meters, what will be the volume of the cargo? Volume of the cargo will be 4 into 8 into 1. Yes or no?
Yes, sir.
Yes,
And
sir.
this divided by the stowage factor will become the weight of the cargo per unit length at B. Yes or no, beta?
10.76.
Yes or no?
Yes, sir.
Please let me know, because I don't want to rush through this point. Because this is the only change. Rest everything is going to remain same. The only thing that is going to change is this particular row, that is weight per unit length, beta. This is going to change. That's all. Does everybody agree that if the whatever is the height of the cargo at B, what is it? 4 meters. So weight per meter at B. Now B is not covering a distance of 1 meter. It's only at point B, we are saying. So what is it if the same things, same parameters continue over 1 meter length that are at B, then the weight of that particular cargo will be the weight per meter at B. Is that clear, beta?
Yes,
Clear,
sir.
guys?
Yes, sir.
And how will we get the weight? We'll get the volume of that cargo divided by stowage factor. So that means,
47.7.
yeah, so if the 4 meter height of the cargo continues for 1 meter length of the ship, whose breadth is 8 meters, the volume will be 4 into 1 into 8. That will be the volume of cargo. Anybody who is not convinced with the volume of the cargo, let me know, guys. Where is coming from? This will be mine plus 23.88 and becomes 0. Are these values of load correct for me, guys, or any doubts?
Correct, sir.
Same game.
Yeah, okay. So now we'll make the load diagram. You can make the load diagram here. A, midway was B, end was C. At A, it is changing from 0 to plus 23.88 and minus 23.88. So you can take like this, but don't worry about it. The decimals coming in. Somebody was discussing about the scale a while back, no? In the last question. Is that clear now? You can quickly finish off these questions like this. Okay, then we have the load. At A, it changes from 0 to plus 23.8. It changes, sorry, yeah, plus. It goes to minus here. It goes to plus again and becomes 0 here. Now these free ends will be joined by straight lines. Now why by straight line, beta? You see, yeah, there are three weights. There are three forces, vertical forces, which are responsible for the load. One is the light displacement, which is uniformly changing. So that will be a horizontal line. Buoyancy, it's uniformly changing along the length. That will be a horizontal line. It's only the cargo which is slanting, correct? So the slant of the cargo will also make the resultant slanting, yes or no?
Yes, sir.
Correct, guys? Understood? Have you understood why this line is going to be straight slanting line? Yes. Here we have minus 23.88. Then I'm sure all of you would agree this will be the midpoint, correct? Of A and B. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
And
7.5.
likewise, this will be midpoint. Why? Because the values on both sides are same. So this will be 7.5, this will be 7.5, this will be 7.5, and this will be 7.5 meters. Now, I'm sure you will all agree that we will need at least 5 points for shearing force now. Yes or no? For shearing force table, we'll need 5 points. Yes or no, guys?
Yes, sir.
Yes, sir.
Because we had 3 points for load diagram, and at 2 places, the load diagram has additionally cut the x-axis. Yes or no? Correct, beta?
Yes, sir.
So shearing force in tons would be, we have first point A, then we have X, then we have B, then we have Y, and we have C. All these triangles are identical. Can you calculate area of one triangle, beta? Any one triangle? So
89.5.
what I'm saying is this triangle 1, this triangle 2, triangle 3, and triangle 4 are, so area of triangle 1 is equal to area of triangle 2 is equal to area of triangle 3 is equal to area of triangle 4, and each one of them with plus minus signs will change, of course, but value wise will be equal to half into base into height. Correct point, guys? How much is the area going to be?
89.55.
89.55 will be the area. Does everybody agree? Has everybody understood what I have said, beta?
Yes, sir.
So now, to the left of A, under the load diagram, shearing force would be 0, area is 0. At X, it will be plus 89.55. At B, it will be 0. Yes or no?
Yes, sir.
Okay. Then at Y, it will be minus 89.55. And at C, it will be 0. Yes or no? You keep adding these triangles, right? Plus, minus, whatever the sign is. Does everybody agree with the values of SF? You can keep adding the triangle, triangle 1 plus triangle 2 plus triangle 3 and all that, right? Guys, any questions on SF values?
No, sir, no.
No, sir. Very good, very good, very good, very good. Now we draw the SF diagram. A, X, B, Y, and C. We have plus 89 and minus 89, so I can say plus 89.55 minus 89.55. It's 0 here, it's plus here, 0 here, it's minus here, it's 0 here. Now I am integrating areas under a horizontal line or a slanting line. Look at the load diagram. Look at the load. So what will be the shape of the SF diagram, guys?
Sin theta curve.
It will be a curve, right? It will be a curve. So the first one we are integrating from vertex base to vertex. So it will be shape base to vertex. Yes, it will be horizontal here like this, and then from here also it is base to vertex. So it will be a mirror image of it. There will be identical things. The other will be exactly replica of it. You can see the load diagram. This will be the shearing force diagram, guys.
So SF will straight lines, right, sir?
Why SF will be a straight line, right? 3/4. It is coming 3/4 from the diagram also, right? Yes or no? If you are not getting it, then please read from here. Only thing is, then if you make a mistake in drawing the curve, then your values you will pick up will be wrong. See, what is happening is, I told you, if you want to put this at midpoint Z, you have 63, and at X, you have 89.55. Correct, beta?
Yes, sir.
So by Simpson's first rule, we can calculate this area, yes or no, beta?
Yes, sir.
I was asking you your value for a purpose. You said 63, good enough.
Yes, sir.
Somebody may said 65, that's good enough. Never mind. Somebody may say 60 also, it's okay. Doesn't make a difference. It's okay. The graph is drawn for use only, right? Now for rule
Yes,
1, the coefficient will be 1/3. Correct, beta?
yes, sir.
Beta, अगर AX 7.5 है, तो what is the common interval? 7.5/2, yes or no?
Yes, sir.
Yes, sir.
Into the SOP area. SOP area for rule 1, 141 होगा. So this will be
Yes, sir.
multiplied. It will be 0 multiplied by 1 multiplier plus, you said 63. 63
Yes.
multiplied by 4 plus 89.55 multiplied by 1. Understood, beta?
Yes, sir.
Please calculate this area and give me the value. This is your area.
Sir,
447.75.
No, let him give from 63. You are giving from 63, beta?
No, sir, वो तो accurate वाला था.
नहीं, तुम एक्यूरेट करते रहो ना, अगर तुम्हें समझ में आ गया तो कोई बात नहीं बेटा. You can
वो भी
continue.
नहीं आएगा ना. 358 है ना.
अरे वो तो वो आया ना 358 तो खाली तुम सिम्पसन रूल से लगाया ना, तो उस पे 1/3 into 7.5/2 भी तो करेगा.
Sir, 345.55.
That is the final area you are giving me, correct? Or you are giving the bracket वाला value?
Sir, bracket वाला value, sir.
उससे ये भी तो लगा दो ना बेटा. Give me the area finally ना बेटा.
Just a minute.
Multiply this value by 7.5, divide by 6. It will go like this and will peak somewhere here. Correct, guys? This will be the diagram from A to X. Yes or no? Correct, beta?
Yes, sir. Yes, sir.
And then from X to B, there will be a peak created here, and it will be somewhat like this. Yes or no?
Clear, sir.
And then, where is the maxima is coming at
Sir,
E?
B 864.
Sir, B is 864, not 0.
864. Okay, sorry, my mistake. So it will continue going to B, and at B it is becoming 0. Correct, my mistake. Sorry, my mistake. This will be the shape of the BM diagram, correct? This will be the BM diagram.
Yes, sir.
Okay. This is plus 864. Now, only difference that will come is somebody may get plus 864, somebody may get plus 880, somebody may get plus 850. That is the difference that will come in the peak value. That's all that will happen, right, beta? And all three, four would be right. Let me also tell you, you will feel that, am I going to lose marks? It may make a difference of a mark or two, nothing more than that. Okay, so somebody tells you mine was plus 880 and you are getting plus 864. Don't panic, it's perfectly fine. Okay, beta, jisne mere ko, the guy who told me, did you actually get 63 there, or were you just estimating something? Somebody who was asking for triangle earlier and who gave me the value of 64. So now is it clear?
That's what I'm saying. By calculating by triangle, it is coming 61.162. Abhi 63 कैसे? I don't know, sir. I did by triangle method, it is accurate.
Arey 63, he's read from his graph, yeah. He's saying he read from his graph. You can't read values from the graph. It has midship compartment 20 from side, 20 by 25. With its forward bulkhead midships, okay. Extending from side to side, with forward, okay. The permeability is 70%. The compartment contains watertight flat at 6.3 meters. Calculate the drafts forward and aft and the GMT if the compartment is bilge below the watertight flat. So what is the concern as the watertight flat at 6.3? So this is H, 6.3 meters better, and it has permeability. And now we have to solve this question. Okay. Lost buoyancy. So is D1 matching for all of you? Yes or no?
No.
Lost buoyancy in this case, or let me write lost buoyancy in this case will be 20 meters of length, 25 meters of breadth, 6 meters of draft into permeability of what is the permeability? 0.7. How many cubic meters is this volume? Can somebody please calculate and give me? Okay. Okay. Now, if anybody does not understand water plane, up to 6.3 meters will be partial. Some part will be lost. Above 6.3 meters, it will be fully intact. So first, we'll carry out a check. How much will be the buoyancy regained if the vessel sinks by another 0.3 meters? That means the water line goes in line with the watertight flat. Correct? That's what I explained to you guys. Plane from 6 meter to 6.3 meter. How would it be? The water plane in the bilged condition. Of course, I'm talking in the bilged condition, guys. The water plane will be partially lost. Yes or no?
Correct.
Correct. So buoyancy regained if vessel sinks to 6.3 meter draft, which is same as the height of the thing. It will be whole water plane, that is 120 into 25 beta, minus lost water plane 20 into 25 into 0.7 multiplied by 0.3 meters. How much is this volume coming to beta?
795.
795. 795 cubic meters is what you'll regain. That means your final water line is going to be above the watertight flat. Does everybody agree with this? Therefore, sinkage or buoyancy to regain above watertight flat would be equal to 2100 minus 795. This comes to how much, guys? 130.5 cubic meters. Okay. Therefore, now above the watertight flat, the water plane will be fully intact, guys. Therefore, sinkage beyond 6.3 meters will be equal to buoyancy to be regained above 6 meters is 1305, and the water plane will be 120 meters by 25 meters. How many meters is the sinkage, guys, beyond?
0.435.
0.4. Okay, therefore D1 will be equal to 6.3 plus 0.435 equal to 6.735 meters. Now, calculations are right? The D1, correct, guys? Yes or no?
Yes, sir.
Correct, sir.
Okay, very good. So can I clear this and continue with the question after this? Or do you want me to calculate it?
Draft.
Draft, okay. Now, LCG initial will be 120 by 2, that is 60 meters. Correct, guys? Why? Because she was even keeled before bilging. Yes or no?
Yes.
Okay. And this will be equal to LCG final. That is not an issue. Correct, guys?
Yes, correct.
Correct, sir.
Okay. Now, LCB, let's calculate LCB by moments. LCB final will be equal to underwater volume 120 into 25 into 6.735 into 60 L by 2. That is the moment of the underwater volume up to W1 L1 minus what is underwater but not contributing to buoyancy is 25. 20 is the length, 25 is the breadth, 6.3 meters is the height of that, 0.7 meters, 0.7 of that into the distance of this would be half the length will be 60. So this will be 50 meters, right? 50 meters, correct, guys?
Yes, sir.
Divided by 120 into 25 into 6. This is the LCB. What is it that you're getting?
61.225, sir. 61.225.
Okay. Is that what you're getting? Everybody's getting this? Those who have solved it where there is a dispute?
Yes, sir. Yes, sir. 61.225.
Okay, very, very good. So we have LCB, we have LCB. LCF will be L by 2. Why? Because in the final water line, the full thing is intact. So it will be 60 meters, right, guys?
Yes, sir. Correct.
LCF will be L by 2. Why? Because this is the water plane in the at W1L1, right? So now what do we need? BML, the full water plane is intact here. This one is intact at the W1L1. This will be the center of flotation. So BML will be equal to what will be BML equal to? It will be L square. Yeah, so B is 25 into 120 cube by 12 divided by 1 upon length into wet into draft of 6 meters. So 25 gets knocked off. So B square upon 12D. How much is the BML you're getting?
Sir, 200.
200. Okay. Now, since the kg is given in this question, you will also have to get the kb. In any case, kb would be required for GM also. Correct, beta? Yes or no?
Correct.
So
Yes, sir.
so kb will have to be obtained by principle of moments. Why? Because up to the watertight flat, there is a partial loss of water plane. Above the watertight flat, the water plane remains intact. So it will not be half of D1. It has to be calculated by moments, right, guys?
Correct, sir.
Right, sir.
Okay, so kb final will be equal to moment of the whole underwater volume, that is 120 into 25 into 6.735. And you'll see that I'm not changing anything. Whatever we have done, I'm strictly sticking to that. This is the vertical moment of the underwater volume about keel minus the vertical moment of the volume that is not contributing to buoyancy, that is 20 into 25 into 6.3 into 0.7. This is the volume which is not contributing, into 3.3 by 2. That will be the lever, correct, guys?
Correct, sir. Correct.
Divided by 120 into 25 into 6. Can you give me the kb beta? kb final?
3.394.
394 meters. And where all these values are 0.7489. So 0.749 meters by stern. Yes or no?
Yes, sir.
Correct, beta?
Yes, sir.
Correct, sir.
Yes, sir.
And TF will be half of it. Why? Because
Yes, sir.
center of flotation is midships.
That's
So
it.
TA will be equal to
37.45,
0.34. 0.37.
4.
या 4-5 राउंड ऑफ करोगे तो 0.75 हो जाएगा, ठीक है. Okay, add this to this draft D1. D1 was where did we get it? 6.735. 735 plus minus 0.375 will give you the drafts forward and aft. Correct, guys?
7.7. Yes, sir. 7.110 and
Okay.
6.36.
Bulk cargo stored in 5 equal holds of so much. I'll just draw the diagram, ask you if there is any doubt or anything you think needs clarification, and I'll move on. 100 meters, breadth is 15 meters. It is divided into 5 holds. Is floating in fresh water at 5 meters, is loaded with bulk cargo. Okay. So 5 holds, 1, 2, 3, 4, and 5. 5 equal holds. Okay. 1, 2, 3, 4, and 5. Let's say this is number 1, number 2, number 3, number 4, number 5. Okay. So number 1 hold contains, number 1 and 4 contain 1400 tons. They are all of equal length, so don't worry about any aberrations in drawing. 2 and 4 contain 1200 tons. And number 3 contains 1500 tons. Okay, the vessel is floating at an even keel draft of 5 meters. So that means now, if you see around midship is here, beta. In this question, the midships would be here. Okay. If you see about midships, are the weights uniformly distributed on both sides of midships? Yes or no?
Yes, sir.
So here, since it is floating on even keel, cargo weights are uniform, symmetrically distributed about midship. It means, now there is no assumption in this question. It means the light displacement is also symmetrically distributed about midships, right, beta? Because, so what we have to get is the light displacement. So we can get the load displacement of the ship by law of flotation. It will be 100 into 15 into 5 into density at 5 meters even keel in freshwater, okay, into 1. So many tons will be the load density. Cargo will be the sum total of all the cargoes, and this will give you the light displacement. And then the question can be done by everybody, yes or no?
Yes, sir.
6 meter wide has a light displacement of 120 tons. Iron ore of stowage factor so much is loaded 3 meters high at the forward end and sloping 3 meter high at the forward and aft end and sloping to 0 at the center. Draw the SFBM diagram to scale. Note the cargo has no slope in the athwartship direction, right? So 24 meters, breadth 6 meters. It has a cargo of light displacement is 120 tons. Iron ore of stowage factor 0.6 is loaded to 3 meters high here and 3 meters high here, and at midships it becomes 0. So this is the cargo, guys, in the vessel. Okay. Draw the SFBM diagram. Obviously, the vessel will float at even keel. Whatever the draft weight doesn't make a difference. Whether less than 3 meters or more than 3 meters doesn't make a difference. Okay. Light displacement is given. The stowage factor of the cargo is given. So cargo weight will be calculated by volume of cargo divided by stowage factor. Correct, beta? Yes or no? Shall we quickly do this question, guys? Because sloping we have done only one. If you want to do, we can run through this question quickly.
Yes, sir.
Yes.
Yes, sir. Yes.
So let's run through this question. No problem, beta. Light displacement is 120 tons. Now weight of cargo, let me know if there's any concern, will be this area multiplied by the breadth, that will be the volume, divided by stowage factor. So what will this area be? One triangle is half into base is 12 meters. Height is 3 meters. This is area of one half triangle. Multiplied by 2, because I have two such triangles, multiplied by breadth of the vessel, which is 6 meters. The numerator, this calculation, what I have written while speaking, is the volume of cargo. Does everybody agree or any concerns?
Yes, sir, I agree, sir.
Anybody in the class who has not understood how this becomes the volume of cargo, guys? And when volume of the cargo is divided by the stowage factor, which is 0.6, this will become weight of the cargo. And can you calculate and give me? In the meantime, if somebody has doubt, you can ask me better.
So whenever when I already taken the 3 meter height, then why 6 meters?
What is 6 meters? 6 meters is the breadth, breadth of the ship.
Okay. Oh.
6 meters is the breadth of the ship. This is the area. Let me just change the color. What is your concern? I didn't get you, beta. Can you just tell me where are you getting stuck?
Just put 2
we multiplied by 2. Okay.
Yes.
That becomes the area of triangle 1 plus 2. But this cargo is stored across the breadth, so we multiply by the breadth, and that becomes the volume of the cargo. Correct?
Yes, sir. Correct.
How many tons it comes to? 60 tons, you said, is it?
360.
360 tons. 360 tons. Okay. So 360 tons is the weight of the cargo. Is that clear? Why we needed the weight? Because we need to know the buoyancy. Okay. So therefore, load displacement will be equal to light displacement of 120 plus 360 tons of cargo will become 480 tons. And this will be equal to the buoyancy, which will be at a rate of divided by 24, 20 tons per meter. Buoyancy will be evenly spread at 20 tons per meter. Does everybody agree with this? Yes or no?
Yes.
Okay. Now, only thing is the cargo weight. Now, I'm sure all of you would agree that minimum number of points I must have are 3. Yes or no?
Yes, sir.
So let's make a load table. You guys make the load table. Make mistakes, never mind. Make the load table, because if you make mistakes, then only you will be able to correct it better. Please do it. especially those who wanted me to do this question, it's in your interest that you please make the load table for 3 points A, B, C. You know the structure. I will not even write anything. You make it, then I'll fill it. And then if you have a doubt, we'll address it. बेटा क्वेश्चन करने का फायदा तभी होगा when you take the lead now and you exactly know where you are getting stuck now, like somebody said how this became multiplied by 6. So when you have the problems, then only you will be able to understand what it is. I will not write some things intentionally. I'll not write beta. And if you have a problem, you can ask me because I want you to think over it first.
So light ship is 5, right?
I took buoyancy, is it? Okay, my mistakes. Thank you for correcting me, beta. Thank you for correcting. I just okay. Thank you for correcting. Okay, fine. Guys, if you're not getting anything, don't take it down. Don't just copy. If you have a doubt, please clarify. I'll leave it there because once the load diagram is there, then you know the process thereafter, right? The load diagram would be like this. I'll have A, I'll have B is C, midway I'll have B. My values are minus 15 to plus 15. And this is the load. Please don't forget to mark. Better mute kar lo zara, please. Don't forget to mark the y-axis. Load is in tons per meter. Equal to area of triangle 2 will be equal to area of triangle 3 will be equal to area of triangle 4. And each one of them would be half into 6 into 15. That is 45 units, right? So now from the load diagram, we make the SF table, for which we'll have to use 5 points, including X and Y. Does everybody agree on that part? Or uspe bhi koi 1, 2, 3. How many? 1, 2, 3, 4, 5 points. No? Yeah. 1, 2, 3, 4, 5. Okay, 5 points. Let me make them equal distance. Okay. So it's A, X, B, Y, and C. Minus 45 and plus 45. The first triangle. If anybody now anybody who was doubtful yesterday and still has doubt, okay. So first value is 0. Next value is minus 45, right? See guys, what I was trying to say yesterday was we are integrating area under this triangle. Let me make it here. This triangle is 6 meter at the base and 15 meter height. They don't look okay, that's okay. And area is 45. Now, what I was trying to say is we have calculated area at the beginning, A, and I have calculated area at X. Okay. At A, the area was 0. At X, the area was 45. So minus fine. No, okay. What I was trying to say is that if you were to calculate the area midway between A and X, that means if you had to calculate area at 3 meters from here and 3 meters from here, you don't have to waste your time in calculating. What I was saying is This will be 0.25 times of 45, that is the area, and this will be 0.75 times of the area. You can directly use this relationship. That's what I was saying. Yesterday somebody was worried about this. Is that clear now, beta?
Yes, sir.
So if I say, let me use the blue marker, what is the shearing force at point P? Shearing force at point P will be 75% of triangle area, that is 45. So what is the 75% of 45? Can you give me?
33.75.
Anyway, I don't need the value on the scale, you see. This is half of 45. This is 1/4. This is 3/4. So midway here, the value will come somewhere here. Is that understood, guys? Why? Because we have gone from base towards vertex. Yes or no? Have you understood, guys?
Yes, sir.
And when I join them, you see automatically it's taking that shape. Is that now clear to some of you now? Better clarity now on what I was saying?
Yes, sir. Yes, sir.
Okay. Likewise, now it becomes 0 at B. So it will be the same thing.
Mirror
If you
image.
see, yeah, this will be 25% of 45 from here. You go, so that will be somewhere here, and it will go back to be a mirror image of this. Is the SF diagram? They were exactly mirror image. They are symmetrical, beta. So this is the distance which is causing the problem. But I hope you have understood what I'm saying, right? This part is same as this part. Okay, they are both same. Okay, beta. Okay. Now at Y it is plus 45. So it will continue like this. And again, mirror image of this will come here. And this is my shearing force diagram. If anybody has any question to ask, all the 4 areas, 1, 2, 3, and 4 are identical. Yes or no?
Yes.
And yesterday, when somebody gave me 63, and what I was trying, who gave me 63 yesterday, beta, that value? Is he in the class? Beta, somebody gave me that value from cargo weight is given as 200 tons. Yeah, it's here. Okay. Now, based on these assumed values,
Sir, can we do this in first 5 minutes?
Investment is not a concern. I'm sure cargo is where you'll have a problem. At A, it's not a problem, it will be 0. At C, it is not a problem, it's 0. At B, what will be the weight of the cargo per unit length? It will be if the height of the cargo, which is H, is continued over a length of 1 meter, multiplied by the breadth of the ship, will this become the volume of the cargo per unit per meter at B? Yes or no?
Yes, sir.
Correct, beta? Divided by stowage factor. What I'm saying is this the weight of cargo per meter at point B? Yes or no, guys?
Yes, sir.
Correct. And now, if I put the value of H from here in this expression, H was 10 into stowage factor upon B, and then I multiply by 1 and by B and sorry, B by stowage factor, right? B by stowage factor. This B and stowage factor is already there. B and B get cancelled. Stowage factor gets cancelled. So weight of cargo per unit length at H is 10 tons per meter. Is that clear, beta? That will go into your load table. That is what will go into the load table.
Yes.
That is the only catch in this question, nothing else. Rest all you know. Please see it. If anybody has any questions about geometry used here or any to bother you up to the, as per the question, put the cargoes and mark the water line. Let the forward part be to the right, let the after part be to left, so that our diagrams are similar, okay? We have been keeping hold number 1 to right, so let's keep hold number 1 to right, okay? And let's name the points from A, B, C, D in sequence from left to right. So please do the diagram and let's see, so that we are, at least the first part we are all comfortable with. I am not going to speak anything because I have told you how we need to make the diagram, so that all of us are making the same diagram. Follow to make the same diagram so that there is no discrepancy. Is that what it is, right, guys? And complete up to the third row of total weights.
Sir, 31.885, sir.
885, okay, my mistake, then I'll make it 885, okay, beta.
By 20.5.
Yeah, okay. No mind. The source will lake, 14 से lake.
नहीं सर 875 ही आएगा
875 आएगा
875 ही आएगा सर
875
Okay, you can check. Okay, I'll make it 875. No problem. I'll make it 875. It's okay. Because as I'm also adding while I'm doing it, I don't keep the table against my this thing, because that will basically take away the spirit of solving the question. Anyway, that's fine. 30.
So 20.75, that is.
This will be 20.75, is it?
no sir same 20.5 other one
20.5.
20.75
Yeah,
next one is
okay, fine.
Sorry,
fine,
sir.
fine,
My
fine.
correction.
No problem. Water displaced by the ship, yes. Now, in all our earlier questions, it was a box-shaped vessel on an even keel condition. So the underwater cross-sectional areas, mark my words, underwater cross-sectional areas from one end of the ship to the other end of the ship were identical, and therefore the buoyancy was uniformly distributed on all the questions that we have taken up to now. Yes or no, beta? Not understood. On even keel. This was the volume, of course, integrating with the breadth. This is the area, and the volume, underwater volume, was the weight of this water was the buoyancy. So if I took at point A, in this case, that means at point A, since the draft was the same, so the volume of 1 meter of underwater hull was this much. Correct, beta? Correct?
Correct.
And this weight of this water became buoyancy at A in tons per meter. Correct, beta?
Yes.
Equal to. This volume was equal to the draft of the ship at A multiplied by 1 meter of length multiplied by the breadth of the ship. That became the volume multiplied by the density of the water. This became the buoyancy per unit length at A at any point. Right, guys? Yes, in all our earlier questions, the draft at all the points was same, and therefore the buoyancy per unit length at any point that we have taken until now was uniform. And what did we do? We just divided the total buoyancy by the length of the vessel in all our earlier questions. Yes or no, beta? Very similar to a hold where you have cargo which is trimmed level. The first question which we took, in which we took the weight of the cargo, how did we say? We said if it was 200 tons over 10 meter length, then we said weight of the cargo is 200 by 10 equal to 20 tons per meter. And basically the concept behind the two was same. In one, it was the weight of the cargo. In the other case, it was the weight of the water displaced. Yes or no, guys? Or by 1 meter of the vessel, right? Correct? Reduce the slanting cargo. And then we said, now the weight of the cargo per unit length at different points is different. Why? Because the factor that was causing the difference was the height of the cargo. Yes or no? Correct, beta? Correct?
Correct.
Now, in the
Correct.
same ship, I just shift some cargoes internally, and now I create trim in this vessel. Has the 1 meter length of the ship changed? No, 1 meter will remain 1 meter. Has the breadth of the ship changed? No. Has the density of the water changed? No. What has changed at different points is now the draft. Correct, Vite?
Correct, sir.
Is different from draft here, is different from draft here, and draft here. Points has changed. Is the buoyancy per unit length going to change at different points? Yes or no?
Yes.
It was used for getting cargo per unit length. It was the height. What did we say? If the same height of the cargo continues for 1 meter over the entire breadth of the ship, then the weight of the cargo is the weight of the cargo per meter at that point. Yes or no, guys? Correct?
Yes, sir.
Yes, sir.
Now, exactly like the height of the cargo, what is the parameter in buoyancy? It's the draft. Correct? What is changing? Is the draft in the trimmed case? Yes or
Yes,
no?
sir.
Yes, sir.
Correct. So we'll use the same thing. That what is the deciding factor? It's the draft. So if the same draft, what is the draft at that point? The point in question. If the same draft continues for 1 meter length, then what will be the volume of the water displaced? And what will be the weight of that water? That will be the buoyancy at that point per meter. Understood, guys? Understood, beta? Density of the water is, let us say, delta. And let us say here the draft of the ship is D. I'm talking of point X now, no other point. If I want to find out at X, what is the buoyancy it will be in tons per meter. Buoyancy will be in tons per meter. Then that means whatever is the draft D at X, the D at X, if this continues for a length of 1 meter over the breadth of the ship, will this become the underwater volume for that draft over 1 meter? Yes or no, guys?
Yes,
Correct?
sir.
Density of the water in which ship is floating, that will become the buoyancy per unit length at point X. Understood? Understood, beta? Means the drafts are different. Draft at E is 4 meters. Draft at A is 6 meters. What will be the draft at C, guys?
5 meters.
5 meters.
5 meters.
And
What will be the
6 and
draft at B? 5.5.
5.5 and
And this
4.5.
will be 4.5. So draft at A is 6 meters. Draft at B is 5.5. Draft at C is 5 meters. Draft at D is 4.5. And draft at E is 4 meters. Right, guys? Now, we can just write down the formula once, and then we'll just keep calculating and fill up our thing. Now, what will be the buoyancy to the left of A, guys? Tell me that first.
0.
0.
What will be the buoyancy to the right of E? 0.
6.1. 6
Yeah.
into 1.
No. Array, right of E. Right of E.
E
This
0.
one, right of
0,
E.
sir. 0.
Yeah. Okay. Now what we can write like here like this is buoyancy at any point in tons per meter will be equal to the draft where at that point multiplied by 1 meter length multiplied by breadth of the ship multiplied by density of the water. Correct, Vite?
Correct.
Yes or no? So now we can calculate to the right of A. Now we don't have to keep showing calculations. We can do it on our calculator, and you can do it to the right of A or just to the right of A. The draft is 6 meters. So 6 meters continues for 1 meter over a breadth of 5 meters in seawater of 1.025. 30.75 will be the buoyancy here. Correct, Peter? In tons per meter. Am I right, guys? Please see. Guys, is that correct? Next one.
Plus 7.7.
Okay, next, Peter.
Plus 7.7.
Okay.
Minus 5.1.
Okay.
Minus 5.1.
Okay.
Plus 3.8.
3.8.
Plus 3.8.
Plus 3.8 and 0.
Yes, sir.
Aarti is correct, beta. Can you please confirm and validate before we go ahead and make solution in front of me, beta? Otherwise, that will be stereotype. Yeah, he's absolutely right. He's absolutely right. Only the first section and the last section will be divided. Correct.
Okay, sir.
Oh, that was the problem. Yeah.
Then
Okay.
we have
Next.
to. Okay, sir. We do it.
Correct. So that means this will be 7.7. This will be 5.1. This will go from here. And this will be 3.8. Is that correct? Yeah.
So one more thing.
And
P
this
में
will
जो
be
ऊपर वाली वैल्यू भी चेंज होगी सर.
ऊपर वाली भी चेंज होंगी किसमें?
P में जो लोड की राइट और लेफ्ट दो वैल्यू ना हमने राइट वाली चेंज की प्लस 7.7 है उसके ऊपर माइनस 3.7 भी आएगा.
तो दोनों में आएगा ना ये. यहाँ लोड में तो चारों आएंगे. लोड में चारों एक मिनट. So that was my mistake. Yeah, tell me.
Just one thing. Why are we not
Divided? So this will also be all divided. This will all be divided. This will be 0 and 0. This is minus how much, beta? 1.1. If you round off to first one decimal place.
Yes, sir.
1.1, sir.
Yeah, okay. This one will be minus 31.875 minus this. How much is it?
Minus
3.7.
Minus 3.7.
Okay. Next one down below.
Plus 7.7.
Plus 7.7. Next one.
Plus
5.6.
5.6 plus or minus?
Plus.
Okay. The next is minus. Next is how much, beta?
Minus 5.1.
5.1. Next one.
Minus 7.7.
7.7. Next one.
3.8 plus.
Minus plus 3.8. Okay. 3.8.
Plus 1.3, sir.
1.3 and 0. Correct, guys?
Yes, sir.
Okay. Now these are the load values. Okay. So what we have done here is we have rounded off to 1 decimal place. Okay, guys. Any doubts about? Sorry, off to 4 and 6. There is already a mismatch between the buoyancy because buoyancy will be based on the drafts. Yes or no? You are calculating the buoyancy based on draft. Yes or no? But the actual displacement of the ship is 819. So there is already a mismatch between buoyancy and displacement. That is why there will be some adjustment which will be automatically required when we make the load table. After making the load table, I'll come to that. But can you appreciate this fact that actual displacement of the ship is 819 as per the weights which are on board? But when the displacement is calculated using the drafts, forward and aft, that means by principle of flotation, that means you're calculating the volume using the volume of buoyancy by drafts. Then the displacement is coming 820. And now to answer my friend who was getting agitated, if I don't multiply by 1.025, then what is the displacement coming? If you multiply by freshwater, what is the displacement coming?
800.
800. Then how do you justify the difference between 800 and 819? Okay, so even with seawater, there is a discrepancy of 1 ton which is coming between buoyancy and displacement. It is not actually that law of flotation has failed or something. It is because of the rounding off of the drafts that has been done by the question person who has set the question. Is that okay, beta? You know why the difference has come now?
Yes.
Is that clear? Okay. Now we'll make the load diagram. Okay. We have A, B, C, D, and E. We have values of plus minus 5, 7. Okay. So we can have up to 8 graduations. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is minus 8. That is plus 8. And I can be guided by these graduations. Okay. At A, it goes from 0 to minus 1.1. It comes to minus 1.1 here. Then it goes to minus 3.7. 1, 2, 3, 3.7 would be somewhere here. This will be a straight line. Why it will be a straight line, guys? Because the 3 forces involved are the light displacement, which is uniformly distributed, so horizontal line. Cargo from A to B is trimmed level, horizontal line, but the buoyancy line is a slanting line, and therefore that results into the resultant being a slanting straight line. Okay, then it becomes plus 7.7, so it comes to here. Plus 7.7. Then it comes to plus 5.1. 1, 2, 3, 4, 5. Somewhere here. Plus 5.1. It comes to minus 5.1. 1, 2, 3, 4, 5. Then it goes to minus 7.7. Then it comes to plus 3.8. 1, 2, 3, 3.8. Somewhere here. and becomes 0. Is the load diagram clear to everybody now, guys?
Yes, sir.
Okay. Now, what I was saying is, if you compare this trapezium with second trapezium, they should have been same. Here it is 1.1, here it's 1.3, here it's 3.7, it's 3.8. Why is the difference coming? The difference is coming because of this 819 and 820 thing that I just shared with you. Is that clear, beta?
Yes,
Why?
sir.
Because the load is the resultant of weight and buoyancy. In the load table, the total buoyancy you have factored is 820 tons. The weight that you have factored in this is buoyancy you have factored is 820 tons. Weight you have factored in the load table is 819. And that is what is showing up as these differences. Understood, guys? Understood, beta?
Understood, sir.
See, what you're seeing is trapezium 3 and trapezium 4 are exactly same, right? 7.7, 7.7, 5.1, 5.1, correct? Yes or no?
Yes, sir.
Correct. There is a slight variation coming in 1 and 2. Yes or no?
Yes, sir.
Now, if this area of 3 and 4 will cancel each other for shear, because shearing force at E has to be 0. Yes or no? If the shearing force at E has to be 0, then 3 and 4 will nullify each other. 1 and 2 should also nullify each other. Yes or no? Correct, guys?
Yes, sir. Correct, sir.
Why will they not why are they not nullifying here? They are not nullifying because there is a mismatch between displacement and buoyancy that has been used in making the load table. Understood the reason now?
Yes, sir.
Guys, any question on this? So what we will do here is now we will rationalize the value of the load on the load diagram. This is my own suggestion to you because such methods are not documented anywhere. Yes, tell me.
So can you tell me, explain this 819?
Don't cancel anything. Don't cut out anything. What do? I just make a cross here and make it 1.2. I put a cross here and make it 1.2. The mean of the two. This is 3.7, that is 3.8. I can change any one of them. Doesn't make a difference. I can change this one. I could have made that 3.7 here, or I can make this one 3.8. So that my SF at E will become 0. Understood, guys?
Yes, sir.
Have you understood what have I done? And I have not deleted anything. I'm not saying make alterations anywhere. No.
Excuse me, sir.
Yes.
Saurabh here.
Since we are restricting our working to 1 decimal place, we said either I make this one 3.7 or I make this one 3.8. That choice was with me, right, beta?
Understood, sir. So we made the adjustment by making the sides
Values
equal.
Yeah, yes, correct.
Values equal. Yes, sir. Okay.
Guys, is that clear now? Does it make sense? And as it is not cutting any extra point, so I don't think SF table should be of concern. We'll make for these 5 points the SF table, right? Will be in tons A, B, C, D, and E. We know trapezium 1 and 2 are same, 3 and 4 are same, so we can just calculate those areas. At A, the shearing force would be 0. At B, it will be the negative trapezium, this one beta, which will be minus half into sum of the parallel sides, 1.2 and 2.5 into, this is 32 meters, so 8 meters each into 8. So it is minus 20, correct, guys?
Yes, sir. Minus 20.
We carry minus 20 and we calculate the area of this trapezium now.
Minus plus 51.2.
Plus 51.2 which makes it plus 31.2. Am I right, guys? Please check and see.
Yes, sir.
Then it is plus 31.2.
Sir, one doubt, sir, here.
Yeah, tell me.
1.2.
One forward plus.
Narendra,
we carry forward minus 20. Last will be plus 20. Automatically becomes 0. Now you understand. Now you see sense why I rationalize the values, beta.
yes, sir.
Okay. Up to this place, I don't think there will be any challenge. You'll be able to manage. Even drawing of the shearing force, you'll be able to manage. The problem will start when it comes to BM. And I'm warning you upfront. Let's make the shearing force diagram before that. Not to worry about it. We'll see it when we reach there. Okay. It's 0, A, B, C, D, and E. Okay. At A, it's 0. 31 is the maximum value, so we can take this about 10, 20, 30. So 31 would be here. No, minus 20 first. Okay. 10, 20. So minus 20 here. And then plus 31 at C, minus 20 at D, and 0 at E. Okay. Now, this first trapezium, if I treat it as a triangle, then it is from vertex to base. Correct, beta? Correct? Okay. So it is vertex to base, so it will be more like this, right? It's little horizontal and then coming like this. The next is from base to vertex. So it will be somewhat like this here. So this one is curve. The other part will be mirror image of it. Okay. So whatever you have done this side, it will be just replicated on the other side. Okay. This becomes the shearing force diagram. Please look at the shearing force diagram and let me know if you want to discuss anything. Because everybody will cut it differently. Now, basically, one thing, the moment I look at this diagram, one thing is very clear. BM at the end has to be 0. Yes or no? BM at E has to be 0. Correct, beta?
Yes, sir.
Correct. So now I'm telling you the practical way of doing the question. Okay. That means if you see this area 1 from A to X should be equal to area 2 from X to C. Yes or no? Then only. Why? Because 2 and 3 are alike. 1 and 4 are alike. Correct, beta? If 1 plus 4 has to become equal to 2 plus 3, then 2 and 1 have to be equal. Yes or no? Can you see that sense what I'm saying? Correct, beta?
Correct.
Okay. Now the problem will start is because it's not made of straight lines. This point will be a challenge. Now mathematically, I can calculate this point between B and C, where it's going to become 0. This distance I can calculate, guys. This distance I can calculate. Where the equating it to minus 20, correct?
Yes, yes, sir.
If I do that, the errors will be lesser.
Yes, sir.
But everybody it will result into a quadratic equation, use of roots of quadratic equation, and everybody may not be comfortable with that. I will do that at the end for those who want to pick it up. Those who don't want to pick it up, because it's not going to be so easy for everyone in the class to really go by. Now, how do those people, or even those who want to solve, may not have the luxury of time of solving? Now, you see, what do you do in such cases is you smartly do some rough calculation on the side and then try to manipulate. Okay. One is area 1 comprises of 2 areas. This area and this area. Yes or no, beta? A to B and B to X. Yes or no?
Yes, sir.
Correct. Okay. What I can do is for this very shape, I will read from my graph. Now, what you need to do is possible. Why? Bigger the scale on the x-axis, you will be able to read off these values with more precision and accuracy. If you make it very small on the x-axis, all your errors will get magnified in reading this point. Understood, guys? Understood, beta?
Correct, sir.
Okay. B to C is 8 meters. B to C is 8 meters, if you see. Okay. What I can do is, and now I'll do by my graph, let it be as much out as it is going to be. Never mind, it's okay. Doesn't make a difference. Now you tell me, first I will calculate area A to B, and I'm doing it in rough. A to B, I'll have to calculate by use of what you call as Simpson's rules. Okay. Now the way ordinate at B is 20, ordinate at A is 0. And what will I have to do? I'll have to go to the midpoint and pick up the ordinate somewhere here. Whatever my graph says, as it appears to be this, I have taken 10, 10 each, no? Okay, so this appears to be about, let us say if I take it as 8, I have not done any calculations. I'm just picking up what is visible from my graph. Okay, so I have 3 ordinates, 0, 8 and 20. So can I calculate this area from A to B in rough? A to B in rough. It will be 1 by 3 coefficient. A to B is 8 meters. So common interval will be 8 by 2 into SOP area will be 0 into 1 plus 8 into 4 plus 20 into 1. How much this area comes, beta? Can you quickly? This is in rough. This is not in the fair, guys. This is rough work for adjustment I'm doing. How much is it coming?
69.33.
Okay. Okay, 69.3, 1 decimal is good enough because as it is, you're reading from the graph. Okay. Okay. The second area from B to X. B to X. Okay. B to X. I can treat this quickly as it appears in my diagram. Instead of applying Simpson's rules again, I can treat it as what you can call it as triangle, and I can quickly do it. Now, if B to C is 8 meters, tell me, guys, in your opinion, from my diagram, what does this distance appear to be on that scale of B to 6 being 8 meters?
1.
4 would be somewhere here. 4 would be somewhere here.
2 meters.
Yeah, 2 to 3, something like this, right?
Yes, sir.
Yeah. What do you want me to take? Whatever you say, I'll take that.
2 meters.
I'll take 2, sir.
Okay, you're taking 2 because you need to learn to adjust. So this area will be half. Base is 2, height is 20. It becomes 20 units area. Correct, beta? That means this area from A to X, this is in rough I have done, is 89.3 units. Correct, beta? 69.3 plus 20. Correct?
Correct.
Okay. Now, my area 2 should be nearly 89.3, not precisely, because Simpson's rules will never give precise. What will I do? If I can get my area 2 something between 80 to 100, 80 to 100, then that means I can nullify these areas because I know the difference is coming because of the values that I'm picking up. So don't try to make it exactly 89.3. It will never be so precise, guys. Now, what I'll do is I'll work around so that area A2 is anything between 80 to 100 units. Okay. Am I clear?
Yes, sir.
And what will I do? I will nullify 1 and 2 by remarking, saying that this is because of the errors in reading from the graph, because BM at E has to be 0. Okay. So now we basically find out this area. Now, if you see, if you have taken this as 6 meters, 2 meters, this will become 6 meters, guys. Yes or no? Correct. Now for area 2, let me use a green marker. For area 2, the total distance becomes 6 meters. This is 6 meters. This is 31.2. This is 0. We take another ordinate midway here. And when I take an ordinate midway here, it appears to be 18, 19, yes or no?
Yes, sir,
Correct.
19.
Okay. First, I'll calculate this ordinate. I'll take this as x in rough and I'll quickly calculate it. How do I calculate? This area 2 will be equal to area from x to c would be equal to 1 by 3 into interval will be 6 by 2, 3 into 0 into 1 plus x into 4 plus 31.2 into 1. And this area in rough, I will equate to 89 and I'll get approximately the value of x. Can you get me the value of x? This becomes 0. So this will be 89 minus 31.2 divided by 4 is x. What does x become equal to?
14.4.
14.4. Okay. Now what I'll do is I'll smartly rub out this curve from here. So that means my middle value should come somewhere here. What I'll do is I'll displace this here and I'll read off here and slightly change this curve. Understood, beta? Understood?
Yes, sir.
Nice, sir.
Okay. Now I'll after doing this in rough, now I'll come to my fair one. 89.3. Area from X to C. Okay. Now area from X to C, guys, what we can just do is now we had taken this value to be about, you told me 14 meters or so, right? You said it should be about 14 meters, right? When I equated to 89.
Yes, sir.
Right. Now what I'm doing here is I read it somewhere here 15 meters or 14 meters and I calculate area C 1 by 3 into. Now this you said was 6 meters. So the common interval will be 3 into 0 into 1 plus. You said 14. So if I want to take 14 exactly, I can't take up to decimal places because the scale will not show that much. 14 into 4 plus 31 or 39, what is that? 31. 31.2 into 1. Can you calculate this?
87.2.
87.2. This is how we can smartly finish it off. Now plus 87.2 and here I say roughly equal to 0. Understood, guys? What am I trying to tell you? So have you learned this little bit of adjustment which has to be made in rough, guys? Because from the graph you will otherwise struggle to zero it. Yes or no?
Yes, yes.
And now plotting these values by curve, same concept of triangle from base to vertex or vertex to base. You can draw the BM diagram for these values. This is how this BM has to be addressed in case you do not want to calculate. And this 2 meter also you took by what it appeared. Accordingly, this became 14. Okay. This could have been more precisely calculated by calculating this area of the trapezium